Welcome to not just a course but an experience that is set to transform your understanding of Spring Boot from ground up. This course is not just about passively watching the videos, but it's actually about being hands-on, doing stuff, writing code, and improving your confidence to become a better Java developer. So let me start with some facts over here now. It's been a while since I've launched this course out in the market, and I have been continuously updating this course since the launch based on the student feedback. There have been a lot of improvements that I have been doing into this course, and this is the most updated Spring Boot course that you will find out in the market. Now, who am I? I'm Faisal. I'm an entrepreneur with over 13 years of experience in building products from ground up. I have built a lot of products that have been used by global audience, and my experience and passion for teaching have empowered a lot of developers to excel in their careers. Now, there are a number of benefits that set this course apart from all the others out in the market. The number one benefit is the true instructor support. So this is a course where I as an instructor is full-time committed to your learning. I've quit my full-time job and I have become a full-time instructor now. Yes, you heard it right. I did this because I believe in providing the best learning experience possible. And with this, I'm 100% committed into your growth and success. Second benefit of this course is there are no teaching assistants. Yes, you heard it right. There are no teaching assistants, which means that all the questions are answered by me directly. And unlike other courses where you would be left with all your questions with nobody to answer, I'll be taking the charge and answering all your questions. Third benefit of this course is depth and breadth. So this course is a comprehensive hands-on course where we'll be covering a vast range of topics around Spring Boot. So we'll be starting from the basics and we'll be graduating towards the advanced topics later on. Fourth benefit is a real world project. So yes, we'll be building a enterprise grade production ready e-commerce application with a lot of functionalities, and during that process we would be learning a lot about Spring Boot. So we'll be diving together into complex topics such as cart management. So how can you manage your shopping carts? How can we manage inventories? How can we manage the security of the application, and so on. We'll be also managing orders as well. Fifth benefit is up-to-date content. I'm 100% committed to provide you with all the updates with the newer versions of Spring Boot and Java. And after enrolling into the course, you'll be having lifetime access to these updates. The next benefit I have is hands-on practical learning. So every concept that I teach is designed in a hands-on way. Okay, so you have to follow, and I'll be providing you with the source code as well, so that you don't have to focus on typing the code, but instead you can take that code and understand what actually is happening in the application, and that can help you save a lot of effort. So it's a pure hands-on course where you will be doing things along with me, and we are going to learn a lot of stuff. Now, who is this course for? So this course is designed for learners of all levels. So whether you are a beginner in Java web development, or you are a developer who is aware of Spring Boot and what it is, and you have used it before, then too you will be learning a lot of advanced stuff over here. So I would encourage you to participate. And yes, this course is 100% beginner friendly. I break down concepts in a very simple manner which is easier to understand. So if you are a beginner, don't worry, I'm 100% committed to help you succeed. Also, this course is backed by 30-day money-back guarantee, making it completely risk-free for you. So as a next step, I would encourage you to take a look at the course landing page and go through the several preview videos that I have made available to you before enrolling. So preview videos will give you a gist of whether this course is right for you and whether this is something that you would want to commit. So if this course resonates with you, you can enroll with absolutely zero risk. And once you enroll inside, I am on the other side waiting for you. So let us begin talking about how web works. So we'll talk about two things first, the internet and the web. And it's crucial that you understand the difference between the two. So what is internet? Internet is a global network of computers that is connected through various technologies, including cables and wireless connections. On the other hand, World Wide Web is a way of accessing information over the medium of internet. And this particularly involves the usage of browsers to view web pages that are linked to others using something called as hyperlinks. All right. Now, internet or the working of web involves something called as a client. Now, here you can see this is the computer, which is a client, and then you have the concept of a server. So web typically operates on the client server model. Okay. Now, client over here, like I said, is a web browser like Chrome, Firefox, Safari that you normally use to access different websites. Now, this client will send the request to the server. Okay. So there is something called a server, like I said. Okay. So it will send the request and it will also receive the response. Now, server is a computer designed to process the request that is being sent by the client, and server also delivers the data back based on the request over the internet or the network. Okay. So this is how web typically works, a simple working wherein you have client which will request something to the server and server will get back with the response. Now, when you want to visit a website, what you typically do is you type in the URL. Okay. Now, there are different URLs like www.google.com, instagram.com, facebook.com. You'll have URL for different websites, and URL stands for Uniform Resource Locator. Okay. So you'll type this in the browser, and this URL is a specific type of URI. Okay. It identifies the website or the resource that you want to access over the internet. Okay. So what happens is when you type in the domain name to find this particular resource, your browser will translate this particular domain name, which is human friendly, into a IP address. Okay. So everything on the internet is identified with the help of IP addresses. But IP addresses are not human friendly, right? You cannot remember an IP address. And that is why this concept of domain names that exist. Okay. So what happens is domain name is translated to the IP address. Okay. An IP address is mapped to a domain name. This is what you can think of as to how things work behind the scenes. Okay. And this process of translating to the IP address and IP address back to domain name is known as domain name system. Okay. You can think of this like a phone book of internet. Okay. Where you have a domain name that is being mapped to the IP address. Now, let me give you an example for this. So what I would do is I would switch over to my browser, and over here, I'm just going to look up for a website. So the website name is What's My DNS. Okay. Now, this is a tool that helps you look for the DNS, which means you can look up for the IPs. Now, let me type in www.google.com. The moment I type in this, you will see all the IPs essentially over here. Okay. And these IPs are from various locations. Okay. So if I copy any of these and if I paste it here in the browser, you'll see I'm taken to this particular URL. Okay. So what happens is you type in the address. Here you type in the address, which is essentially the IP of the server in the hindsight. Okay. And whenever you are typing in the address, the request goes to that particular server, and then you are given access or you are shown this particular web page. Now, normally we don't type in IPs because IPs or remembering IPs, it's not a human friendly practice, right? Imagine like you remembering all the numbers of different websites, right? So that is not human friendly, and that is why this domain names exist. All right. So I hope this makes sense as to why this concept exists. So it is really important that you understand that in the hindsight, behind the scenes, it all works with IP addresses, and IP addresses, you must be aware, it is used to identify a resource on the network, right? And internet is nothing but a network, right? So that is how things work. What happens is you make a request from, like you say, www.domainname.com. Okay, you have a corresponding IP address, and then you hit that particular server, and then you get a server response, which is nothing but the web page, which is coded in HTML. And your browser is designed to display HTML content to you all, along with CSS, JavaScript, and all. So it displays the web page, and you see the web page, and then you interact with the web page. All right. So this is how things work. Also, this entire thing follows a protocol. So if you see over here on these dot, if you click, you can see this connection is secure. Okay, and if you click over here further, and if you see the entire address, you'll see HTTPS. So this is the protocol, https://www.google.com. So this is a protocol that governs this entire communication between web browser, which is nothing but the client, and the server. Okay, so this is the protocol, and protocol means a set of rules that are laid out for this communication to happen. All right. So this is how the entire web works, and I hope you have a fair understanding of how things work in the hindsight. Now let us first talk about what is a client and a server. So we'll be talking about client first. What is a client? So a client is any device or an application that requests services or resources from a server. Now, if you have to talk about a client in the context of web, a client is typically a web browser that users will interact with to access the web pages. Okay. Now, a client can also be any other kind of software, like an email client or a mobile app that could request data from a server over the internet or another network, right? So if you're making use of an email client like Gmail or Outlook, that is also a client, right? Because it is talking to the server and getting mails for you. In case of a mobile app, you are accessing a remote server right from your mobile phone, right? So they are also an example of a client, right? And a web browser is also an example of a client, right? Let us talk about some characteristics of client so that this can help you understand more. First is user interface. So clients usually will have user interface, and this will allow individuals like us to interact with the applications or services that are being requested, right? So in case of a mobile app, you have an interface where you can interact. You have a interface in case of an email client. You also have an interface when you are making use of a web browser, right? So client will have an interface because it is user facing. Another point that I would want to mention in terms of characteristics is a client requests services or resources, right? So when you type a URL into your web browser, a browser, which is client, is requesting the web page from the web server. So what is a client behavior? A client behavior will normally be to request services or resources from the remote server, right? Third characteristics would be it would receive data. So after a request has been made, the client receives data from the server, processes it, and it will present it to the user, right? For example, if your web browser is requesting some information about a website, it will get that information from the remote server and it will display it as a web page to the user, right? So these are the three major characteristics where a client will have a user interface, it will request services, and it would receive data. Now let us talk about a server. Now what is a server? So a server is a computer program or a device that provides services or resources to different clients, right? Servers are designed to handle requests from multiple clients, and they can send them requested data or services, right? So what happens is you have a server in place, and that server would be involved in handling requests from multiple clients. So multiple clients can send requests to the server, right? For example, if you have a server, you will have multiple mobile apps like sending requests from the phone to request something that you need to display, right? Now, a server can host websites and information, and it can respond to the request from the browser or web pages, right? Let us talk about some characteristics of a server. So number one characteristic is it's always on, right? So servers are typically always on and they are always connected to the internet so that they can handle the request at any time from the clients, right? A client can request anytime. For example, you can open Instagram or any other app at any time you wish, right? And you will find the requested information. Like for example, if you're opening WhatsApp, you're going to see messages from your friends, family, or whoever your contacts are, right? And it's not like you won't receive messages during this time, right? So a server won't be off. It's typically always on and it's always there to serve you. A server can handle multiple requests as well. So they are designed in this way where they can handle multiple simultaneous requests from many clients, and they can manage traffic, resources to serve each request appropriately. Also, servers are designed to send data. So when a server receives a request, it takes a look at the request, it will process it, and it will receive the necessary information or the resources that it needs to send back to the client. And then once it has gathered all the data and the resources that it needs to fulfill the request, it is going to send them back to the requesting client. Okay, so it will typically send data. So these are the characteristics of the server, right? Now how they interact. So you have a mobile phone over here in the picture. You have a computer which can represent a browser. You have a remote server, right? Now what happens is there is a process of sending in a request, right? So a user will interact with these devices, that is mobile phone or a computer, and using these devices it will send a request to the server, right? Server will receive the request, it will process it, and it will send them a response back to the client. And this response could be the requested web page, the result of a query, or simply some confirmation of the receipt, right? And then what will happen is the client who has sent the request, and it will receive the response. So what it will do is it will take the response and it will display it onto the browser to the user. Okay. Now let me give you some example of client servers in daily use. So number one example would be web browsing. So when you use a browser is essentially a client, and you're using it to visit a website, right? To check some information. The browser will send the request to the website server for the web page. The server will process this request and send back the web page, which browser will then display. Okay, this is one example of a client server in action. Then you have another example as email. So you will have email client like Outlook, Gmail, and this will send a request to the email server to send or retrieve the email, right? The server will process this request and it will revert back with the response appropriately. So this is client server model in action, and I'm sure if you have been making use of technology, mobile phones, desktop, you would have used them at some point in time, right? So that's client server for you. Hello and welcome to this class. So let us begin talking about what are APIs. So what are APIs? So APIs stand for Application Programming Interface, and it's a set of rules or protocols that allow one software application to interact with another. So basically it defines the format or a way in which two software applications can communicate with each other. So let me give you a nice analogy that could help you understand APIs better. So imagine that you are at a restaurant and you, the customer, represent the application. The kitchen over here represents another system or the service. And now let's say if you want to order food, the food is the functionality that you wish to order. Okay. So let me put this down for you. So in a restaurant, the customer is an application. Kitchen can be another system or the service. Now menu here is the API specification that lists all the dishes that you can order, how they are served along with their prices. Then you have the waiter, which is the intermediary or you can say waiter is the API over here who takes the order from the application and goes to the kitchen, which is another system, okay, and then serves the order back to the customer. And then you get food, which is nothing but the response, okay. So waiter brings back the response for you, which is nothing but the food. Now you as a customer, you don't need to understand how kitchen works. You are just sitting on the table, you just get the menu, you take a look at the API specifications, which is nothing but the food that will be served and the amount, okay. So you know the amount as well for different items. Now you tell the waiter, okay, this is what I want. So API does the job of going to the kitchen, making sure that your request is processed, and then it brings back the response for you, which is nothing but food, and you can have your food then. Okay, so this is the restaurant analogy to help us understand APIs. Okay, now if you have to talk how API works in terms of system, so take a look at this diagram over here. So here in the diagram, you have a web application which is running in the browser over here. Okay, then you have the internet. So browser will send a request over the internet to the server, and this browser, let's say, is being accessed by the user, and the browser is displaying some data from the server in the background. Okay, so here what will happen is the communication for the data access is done with the help of the APIs, as you can see over here. For example, if a user clicks on the login button in the browser, system redirects the user to the home page if username or password is incorrect. So this communication with the server, whether the username and password is correct or not, is done with the help of APIs. So you have browser that sends in the request, then it accesses the API using which some interaction happens on the server, and in turn the server interacts with the database, which will send the response to the browser back. Okay, and based on the response, the browser decides whether the user should be shown the home page or he should be asked to log in again. Okay, so this is how APIs work. Basically, they act as an interface for applications to interact with each other. Okay, so API is nothing but an interface, as you can see. Now, APIs can be private, partner based, or public. Okay, so private APIs are internal APIs, as the name suggests. Okay, and they are supposed to be used by the same app internally, and they are not available to the public. Then we have partner-based APIs, which are built and shared with specific business partners. So, for example, if I'm a company, I have a partner with whom I want to integrate my system. So I will design APIs that will be only used by that partner, and they won't be exposed publicly. So they are partner-based or partner-specific APIs. And then there are public APIs, and they are APIs that can be used and accessed data from your system, and anyone in the world can create an app that can access your system and display the data. For example, Twitter had public APIs, so anyone in the world can access the APIs and create Twitter-based apps. Okay, you have Facebook APIs that are public, so you can access Facebook APIs and create apps that are built on top of Facebook. So these are public APIs. Okay. Now, what is the need of APIs? So number one need is that it reduces the manual effort. So let's say you are creating an app that displays all the tweets that have been done by a particular user in the past. Now here you can take the data from the Twitter in a spreadsheet and show it into your app. But you will have to do this every time a user tweets, and this is very manual effort. If you integrate the API, the tweets will be fetched automatically whenever a new tweet is available, because you're directly integrating with Twitter, right? And this will reduce a lot of manual effort where you don't have to copy the data into spreadsheets, and this will automate a lot of stuff at your end. Okay, so it reduces a lot of manual effort and it automates a lot of stuff. So here you will notice, since the manual effort is reduced, automation comes in place, because all the latest data is always available with you, irrespective of whether you are doing it manually or not. So it's automated because you have integrated two systems. So this is the importance of APIs, okay, or the need of APIs. So that's about APIs and how APIs work. So when talking about APIs, it's also important that you understand the different types of API requests that exist. So what are the types? So the number one type is the GET request. Then we have the POST request, PUT request, and DELETE request. So API request that you are doing to a server can be categorized to any of these four types. Now let us understand each one of them. So we have GET request, and this request is used to retrieve or get something from the server. Now this can be any resource, any data, or any kind of information that you need from a particular server, and server will help you fetch this from the database. And GET requests are only used to read data and not change it. So like the word says, GET. So it is just used to get the information and not to modify anything on the server. And whenever you're using this kind of request, you will get status codes like 200 OK, or if you're trying to access something that does not exist, you will get 404 not found. Okay, so this is GET request. Then we have POST request. Now POST request is used to create a resource on the server. So if you are allowing users to sign up through your mobile application, you will have access to the create user API, and with the help of that API, if the user signs up, you can create a user onto the server, which will in turn get saved in the database. So this way you are making use of this API to save the user's information and credentials, and you can do this with the help of POST request. So you cannot use GET request in this case, you will get an error. So the request type has to be POST. And when using POST request, some common status codes that you will encounter is 201 created, because when you create anything on the server, that is what server will respond generally. And if you're trying to access something that does not exist, you can get 404 not found, or you can even get bad request status code if you are not calling the API correctly. Alright, so this is about POST request. Then we have PUT request, and this type of request is used to update something that already exists on the server. For example, if you are allowing users from your mobile application to update their personal information, so if they have an edit profile page, they will update the information, and once they hit save, you as a mobile developer can call the PUT request, which you have been given access to. And with the help of PUT request, you can save the information and update it against the user. Okay. And keep in mind, PUT request is not used to create anything, not to get anything, but it is used to update something that already exists on the server. And when you're working with PUT request, you will normally get 200 OK if your request was successful. You can get 4 not found, or you can get bad request, which is 400. So this is about PUT request. Then we have delete request, and delete, as the name suggests, it is used to delete resources from the server. For example, if in your mobile application you have a way for users to delete their account, for example. So this way you can make use of delete request. If the user presses that button, you might want to delete the user account details and everything that user has done in your application. And you can make use of delete request for this particular purpose. And keep in mind, delete is just used for deletion purpose. It is not used for post, put, or updating anything, or getting anything, or creating something on the server. Alright, and normally you will get 200 OK if your request is successful. You might get 404 not found if you're trying to query something that does not exist. Okay, or you might get 400 bad requests if the format is incorrect. So this is about delete requests. So these are the different types of requests that exist and you can make use of in your application. Alright, That's about this class. I shall see you all soon. Thank you. Now let us begin talking about what is a REST API and its architecture. Now first, let's begin talking about REST API itself. So REST API stands for Representational State Transfer. So this is the full form of REST. And then you have API, which stands for Application Programming Interface. So it's Representational State Transfer Application Programming Interface. Okay. Now this is a popular architectural style for designing networked application, and this uses HTTP requests to access and use data. Now what do I mean by HTTP request? These are requests that make use of HTTP protocol. All right. So now the data in this particular type is sent over the network and is received generally in the form of JSON or XML. Now JSON and XML are the forms of representing data. Okay. So this is about REST. Another thing you should note over here is that REST is stateless, meaning that each request from a client to the server must contain all the information that server needs to understand the request. So server does not store any state about the client's session on the server side. Okay. So server won't know who the client is and which request the client has done earlier. So what it means is, if a server is interacting with the 1,000 clients, okay, it is not storing the information of the 1,000 clients that are interacting. Okay, it is just receiving the request. It is taking a look at the request, and every request has everything that it needs to process the information, right? And this statefulness ensures that each API call can be made independently, and this improves the scalability, visibility, and allows for easier caching and a lot of stuff like reliability. Okay, so this is one important point that you need to remember, that REST is stateless. Now let us talk about some principles of REST API. Number one is the client-server architecture. So the client and the server must be separate from each other, and they should be allowing each other to evolve independently, right? So they both are independent. Another point is stateless. Like I said, each request from the client to the server must contain all the information needed for the server to understand and complete the request. The server should not store any client context between the requests. Can be cached. So what this means is, clients can cache the responses to improve performance. Okay. And this helps improve the speed of the responses on the client's end. So REST is opaque in terms of layers, which means that a client cannot ordinarily tell whether it is directly connected to the end server or to an intermediary along the way. Okay, so there can be a layered system, okay, which client is not aware of. Okay, so this layered system architecture helps provide a stable and secure environment. Okay, which means that there can be more servers in between the client and server, or there can be more layers of communication, right? Uniform interface. Now uniform meaning all the endpoints that are designed are uniform in nature. Okay. Now web services that are built following the REST architectural style are known as RESTful web services. Okay. So the web services that follow these principles are known as RESTful web services. Now in RESTful web services, the most commonly used HTTP methods are like GET, which is used to retrieve the information from the web server, POST, which is used to create something on the server, like for example add a new comment, like it will create a new record or something on the server. PUT will be used to update something on the server, and then you have delete, which will be used to delete something on the server. Okay, so these are the different methods. Now talking about the benefits, there are several benefits like simplicity, because working over HTTP protocol makes REST API pretty simple to use and implement. Scalability, so since they are stateless in nature, means they can scale to handle large number of requests. Flexibility and portability, so data is not tied to resources or methods, which allows for more flexibility in how data is returned. Visibility. So communication between client and server is done using standard HTTP methods. Okay, and these methods are understood by different components on the internet. Okay, so this improves the visibility of the interaction as well. Okay, so this is about REST API and how it functions. Hey there. So let us begin talking about HTTP and HTTPS. Now, both of these are protocol that are used for transmitting the information over the internet. Okay. Now, if you talk about HTTP, HTTP stands for Hypertext Transfer Protocol. Okay. And this is like the meaning, or I should say the full form of HTTP. Then you have HTTPS, which stands for Hypertext Transfer Protocol Secure. Okay. Now, HTTPS is essentially HTTP but with security. Okay. Now, what this means is that both of these are protocol, but the information that is transmitted using HTTPS is more secure, and the integrity of the information is well maintained in HTTPS. Okay, now if you are talking about both of them are protocols that are designed for transferring data information on World Wide Web. Okay, they both operate on client server model. So there is a client who is making a request, sending a request to the server where the server is being hosted, and the server will respond with the information. Both the protocols are making use of similar methods like get, put, post, delete, and these methods are being used to perform actions on the web server. They even have status codes like 200 OK, 404 not found to indicate the success or failure of a requested operation. Alright. Statelessness. So HTTP and HTTPS both are stateless protocol. Okay, meaning they don't inherently remember anything about the previous web session. Okay, so every request or response is independent. Okay, and every request is treated as a new request, and servers do not retain the session information of the clients. All right, so this is something that you need to know about both the protocols. Also, both HTTP and HTTPS can transfer data in various formats, including HTML, XML, JSON, and plain text. So the difference is only about the security. HTTPS is more secure and these days more common when you're working with web. All right. So if you head over to the browser, here you're going to see google.com. And if you click over here on this icon, you are going to see this padlock icon which says connection is secure. If you click over here, you'll see that your information like credit card numbers, password, everything is private when it's sent to this site. You'll see it also has a certificate, okay, which is the certificate of security. You can see over here. This is all the detail about the security. Okay, so this is what it is. And if you click over here, okay, and if you see, it's HTTPS, right, and not HTTP. Alright, so majority of the websites make use of HTTPS protocol, and it's more common in today's world. So that's about HTTP and HTTPS. You just need to remember that HTTPS is HTTP protocol with security. Alright, I hope this makes sense. Let us start talking about status codes and APIs. Now, when you communicate between systems with the help of APIs, there has to be an indicator which indicates the result of the request. Now, this can sound like an acknowledgement. So when you communicate with someone, you need some sort of acknowledgement from that person. And this is exactly how it works in the case of software systems. And this acknowledgement in case of APIs is status code. So when APIs communicate, they use status code to indicate the result of the request. Okay, and these status codes are part of the HTTP protocol, and they can tell you whether the specific request that you did to a particular server has been successful or there were some failures or issues along the way. Now, let me give you an example. So let us say you have a cloud server here, as you can see, and you have two clients. So one is the mobile phone and you have an application that is running on the desktop. This is how a typical application looks like. You have a remote server and then you access the data on this remote server with the help of a client, which can be right from the mobile app or it can be through the browser. Okay. Now, when you want to interact, you will send a request to this cloud server. Okay. So this request goes to the cloud server and then you expect a response. So you get a response along with the status code. And this code tells you whether it was successful, like the request was successfully processed or it was not. And there are different codes that indicate what happened with your request. Okay. Now here, status codes are important because whenever we make a request to the server, okay, we receive the response, of course. So response will get, but who will tell us whether it was successful or it was not? So with the help of status code, and status code is that identifier that helps you understand this. Okay. So status codes are 3-digit numbers that represent the status of the HTTP response. And they help us identify the outcome of the request. And status codes can be classified. So there are 5 categories in which status codes can be broadly classified into. Okay. And the first digit of the status code defines the class of response, while the last 2 digits do not have any role in the categorization. Okay. So for example, you have this one category which starts with 1, and this means informational and it indicates that the request was received and the process is continuing. Then you have 2XX, so it can be 200, 201, and this indicates that the request was successfully received, understood and accepted. Then you have 3XX and this indicates redirection. Okay. Now, this will tell you that the further action must be taken in order for the request that you have sent to complete. Okay. So if there are redirects, like 301 is the code to redirect. So you will receive a response starting with 3. Then you have status code starting with 4, which indicates client side error. So you as a client are requesting something from the server, and if there is an issue from your end, that is what a status code starting with 4 means. Now, an issue from your end meaning like you can send requests that might have bad syntax or like incorrect parameters, or the request is not formatted properly in the right format. So all these kind of issues are arising from the client's end, and that is when you get the request response with the status code 4XX, and this indicates client error. Then you have 5XX, which indicates server error. So like there will be scenarios wherein the server failed to fulfill an request, like there is an error or there is an exception that has happened or the server crashed or something. This response code will start with 5XX. Okay. Now let us take a look at some of the commonly used status codes. Okay. So the number one status code is 200 OK. Okay. And this is like the most commonly used status code, and this is standard response for a successful HTTP request. Then you have 201, and it indicates the resource is created. Okay. So whenever you are sending a request to the server to create something, like for example, to create a user or create a product or something like that, then you get 201, which indicates that whatever your request was, it has been created. 204 means no content. And what this indicates is the server has fulfilled the request, but there was no representation or nothing to return. 301 indicates moved permanently. Okay. And whenever you try to hit a URL or an API call which does not exist or it has been moved, then you send the status code as 301. and this tells you that the requested resource has been moved permanently. Then you have 400 bad request, which means the server could not understand the request due to an incorrect syntax. So if you as a client are sending some request to the server and the syntax or the parameters are not right, then you get 400 bad request, which tells you that the request you sent is not valid. Then you have 401 unauthorized. So this indicates that the request that you send does not have authentication credentials, or it's not authorized. So there will be scenarios wherein some APIs will be authenticated. Okay, so if you try to access, let's say, Twitter APIs, those APIs need to be authenticated because you cannot access users' information without authentication. Now, if you try to access the API without authentication, that is when you get 401 unauthorized. And this tells you to include the authentication information as a client into the request that you are sending to the server. Then you have 403 forbidden. Okay, so this indicates that the server received the request, it understood it, but it refused to authorize it. Okay, so it's something forbidden that you cannot access. Then you have 404 not found. So this means like you're trying to access something that does not exist, and that is when you get 404. So if you're trying to access a URL that does not exist, you get 404 error. Then you have 500 internal server error. So this means that whenever you're sending a request to the server and there has been an unexpected condition, okay, because of which an error has occurred on the server, and that is when you get 500, okay, which indicates that some issue has occurred on the server. So these are different commonly used status codes. Okay, now understanding status codes is crucial when you're working with APIs, because they help you understand the essential information about how a request is processed, and it also tells you what happened to your request. Okay, so it gives you a clarity as to what is happening behind the scenes. Alright, so that's about status codes, and I shall see you all soon. Thank you. So few things we need to understand is resource, URI, and sub-resource. So when doing web development, you might come across these terminologies, and it's important that we understand what these things mean. So let's talk about resource first. Now, a resource is any piece of information that can be named or identified on web. Okay, you can think of it like object, data, or service that can be accessed by the clients. Okay, and it's one of the key concepts in the RESTful architecture that represents this type of information like object, data, or service. Now, a resource is not just limited to documents or files. So normally people just associate a resource with documents and files. It can be anything from a text file, image, collection of other resources as well, a non-virtual object like a person, or abstract concept like a service. All right. And if I have to give you an example, let's say in a social media application, a resource could include a user profile, a photo, or a list of friends, or even a specific post or a comment. So that is what a resource is in the context of web development. Now let us talk about URI, which stands for Uniform Resource Identifier. So a URI is a string of characters, and it's used to identify a resource on the internet, either by location, name, or both. So it provides a mechanism, I can say, for accessing the representation of resources over the network. Okay, and of course this access is done using protocols like HTTP or HTTPS. Okay, now URIs are a broad category that include URLs, okay, and URNs, right? And let's talk about sub-resource now. So a sub-resource is a resource that is hierarchically under another resource. So it's a resource within another resource. That is what is known as a sub-resource. And it's a part of a larger resource that can be accessed using extending the URI of the parent resource. Okay, so if I have to access a sub resource, I have to extend the URI of the parent resource. And sub resources are often used in RESTful APIs to maintain a hierarchy sorts in the data. Okay, and it facilitates easy access to related resources. All right. Now, if I have to give you an example, you might have a user resource in a blogging platform with the URI/users, right? And a specific user could be a resource accessible at /users/user ID. So this is a hierarchy, as you can see. All right. Now, if each user have a blog post, and a post would be a sub resource of that user, and it would be identified something like this. So you will have /users, user ID, and then you will have /posts, and then you can have post ID as well. Okay, so I hope this makes sense. All right, what is the importance of all of this in web development? So in web development, number one importance is organization. Like, it enables you to organize data, functionality, okay, and it makes it easier for developers to navigate and manipulate the application structure. Accessibility, so you can easily access the related sub resources together. Okay, and scalability, of course, this hierarchical structuring or proper structuring allows for a scalable application design as well. Okay, so that's about these concepts. I hope this was useful. Hello everybody, let's start talking about what is a web framework. So first, let's get into the specifics of why do you need a web framework. So if you look at most of the web applications that exist today, they have a lot of things common in them. For example, all web applications need to serve the web page when a user tries to access a certain URL. All web application needs to have the aspect of security. All web applications need to have databases, authentication, and so on. So there are lots of common elements that exist in the different web applications that exist today. So these are just the standard list of things that I mentioned over here. But the question is, should you build this thing as a developer every time when you build an application right from scratch? So think of this as building a house. So if you build a house, you would need some blueprints and tools, okay? And for web development also, that is how things work. So you need set of tools, like some set of pre-built things that you would be incorporating in your web application. And developers earlier had to build these things right from scratch, okay? So if you have to build a web application in Java, you have to manage things like security, authentication, and everything, like how a URL is accessed and all these things manually. So this was the case early on, okay? And this was written manually by the developers every time they create a new web application. There was no boilerplate or a starter template that they could use. And this was very effort taking and is required by almost every website out there. Like, developers cannot say no to this, okay? So you can compare this with the analogy of building the house, okay? What if you had a set of tools, a blueprint ready, okay? Because every house needs that, okay? They would need certain tools. They would need some sort of a blueprint to set up things quickly. And that is where web framework comes into picture. So what if I would tell you that you could have some prefabricated components that you could use, okay? And you could just use these prefabricated components that you could assemble to make a house with fewer errors, a lot more faster. So by prefabricated components, I mean pre-built walls, doors, windows, and so on, okay? Now, you could assemble these faster, yes, right? Like, if you could get a list of prefabricated components, you could put them all together really, really fast. And you could also reduce the number of errors that you would get during the process. So this would make the entire process a lot more easier, faster, and you could focus on important things rather than doing repetitive things. And of course, this would make you fast. Now, this is what a web framework does. So what is a web framework? So web framework is nothing but a collection of tools and modules that is needed to do standard tasks that are required across every web application. Okay. So web framework consists of some standards. Like for example, every website needs to serve web pages, interact with the database. They also need to interact with the web host. And hence, web framework take away these repetitive tasks and have a standard defined which you as a developer can follow and use that as a starting point. So rather than creating a blank new file when you start creating a web application, okay, you can use something called as web framework, which has some set of things already pre-configured. And this makes you a lot more faster. The benefit of this is you get to focus on important things rather than focusing on or doing a lot of repetitive things. For example, you can focus on business logic rather than setting up things and the boilerplate code. So that is what web framework is, and it makes your life a lot more easier. So you can compare this with the analogy of house building. So if you could have pre-built house, like a pre-built wall, pre-built windows, and so on. Like windows you would need for every house, right? You would need them in different sizes. So what if you could have a set of windows with different sizes and you could just pick the window that you want whenever you're building a particular house. Okay. So if you want a window of 3 feet, like 3 feet wide, you have a list of windows, like you have 3 feet wide, 4 feet wide, 6 feet wide. So you could just pick 3 feet wide window and you could use it in the house. And that makes your life much more simpler rather than building things every time from scratch. So that is what web framework is. So let's talk about the popular web frameworks that exist in the market today. Now there are many web frameworks available for different programming languages, and each has its own strengths. Okay, we'll talk about some of the most popular ones. So the number one is Spring Boot. Okay, so Spring Boot is a Java-based web framework and it is used to build a lot of enterprise applications out there. Okay, and it allows you to build them really quickly. So it takes away the hassles, a lot of auto configuration, and there are a lot of good features that Spring Boot offers to the developers. Okay, but yeah, Spring Boot is one of them and it is Java based. Then you have Django, which is a Python based framework. Now Django is also known as batteries included web framework, which means it includes a lot of common functionalities built in. Okay, so if you learn more about Django or if you read more about Django framework online, you will see this term batteries included being used at a lot of places. Then you have Flask, which is also a Python framework, but it is much more lightweight, flexible, and it is great for small projects or when you need more control over the code. Then you have Express, which is a JavaScript based framework and it's a part of Mean Stack or Mern Stack. Okay. Now, what I mean by Mern Stack is Mongo, Express, Angular, and Node. Okay. So this is widely used for building APIs using JavaScript. Then you have Ruby on Rails, which is also called as ROR, and it is based on this Ruby programming language. Okay, and it is known for its philosophy of convention over configuration. Okay, and it helps you increase your productivity once you understand its conventions. So that's Ruby on Rails. Now, a lot of these frameworks are being also used by top companies. For example, Instagram and Pinterest use Django internally. Twitter, Airbnb have used Ruby on Rails. LinkedIn uses Express.js for server-side rendering. Netflix uses Spring Boot and so on. So if you learn and Google a bit more about these frameworks, you will know there are a lot of companies, big tech companies, they are using these frameworks for the day-to-day life. Okay. So that's about web frameworks, and I shall see you all soon. Thank you. Hey there. So let us begin talking about Spring Framework. All right. Now, let us talk a little bit about history as to how Spring Framework has evolved over years. And if you are a Java developer, it's likely that you would have heard about this particular framework. All right. So this framework was developed by a person named Rod Johnson in the year 2022. Okay. And this was developed as a solution to the limitations of Java Enterprise Edition platform at that time. All right. So the first version was released in the year March 2004. And since then, a lot of developments and versions have been released. So the reason why this was released is to simplify the enterprise application development at that time by providing a lightweight alternative to the complex and heavyweight stack of Java that existed at that time. All right. Now, what does Spring do? So like I said, it was built to provide an alternative to the complex and heavyweight Java Enterprise Edition stack. And since it's an answer to that, Spring simplifies enterprise application development. All right. So once you start using Spring, you will know like how it simplifies a lot of stuff for developers, right? There are a few key principles that we should be aware of. Number one is simplicity. So Spring will simplify complex technologies, okay, and it's simple to use. Modularity, so it will encourage modular application architecture through loose coupling. Testability, so it will promote good programming practices such as programming with interfaces, dependency injection, and so on. So if you're not aware of all of these concepts, don't worry, okay, you will understand as you learn more about Spring. But for now, you just need to keep this in mind, all right? Key components of Spring. So there are a few key components that you will hear about often when working or talking about Spring. Number one is the core Spring framework. Now, this is the foundation of the Spring ecosystem. This is a core module essentially, I should say, and it provides a lot of features like dependency injection, aspect-oriented programming, transaction management, and so on. All right. Then you have Spring Boot. So this is a project within Spring ecosystem, and this further simplifies the process of building standalone production grade Spring based applications. All right. And it provides a lot of defaults, a lot of auto configuration, a lot of pre-configured stuff that allows developers to focus only on writing the business logic, application code, rather than wasting time in configuring stuff. All right. You will learn about this, like how Spring Boot makes your life easy when you create your first Spring Boot application. So hang on for that. All right. Spring Data. This is another thing that you will hear about. So Spring Data provides a unified and easy to use APIs for working with various data access technologies. Okay. So whenever you're building an application, let's think of this way. You will be working with data, right? And where does your data exist? Your data normally exists in database, right? And when you work with databases, you have different kinds, like you have relational databases, NoSQL databases. Your database might even exist in cloud or locally, right? So with the help of Spring Data, you can work with different database providers or different data providers with ease. All right. Next component would be Spring Security. So when working with any application, right, security is a must. And this is one of the components that enables you to like secure your application by implementing authentication, authorization, protection against common security threats, and so on. All right. Then you have Spring Cloud. Now this provides tools for developers to quickly build some common patterns in a distributed system. So these are some of the core components of Spring. You can even see that these are the modules within the Spring ecosystem. All right. And there are many more, but these are like the main ones. All right. Use cases. Now, number one use case of making use of Spring is like building enterprise applications, of course, because that is why this was developed, right? To simplify the development of enterprise applications. Okay. Microservices architecture. This is one of the important use cases. So if you are building Java based services that are segregated, all right, and they have been divided into microservices, then for implementing that you can make use of Spring. And it is also used for building a lot of web applications. Okay, so Spring essentially is being used for doing web development. So these are the few use cases of Spring, and this is a short overview of Spring framework. So now it's time that we talk about coupling. And when we talk about coupling, they can be broadly categorized into two types. One is tight coupling and loose coupling. So let us understand what tight and loose means in the context of software design. So coupling in general refers to how closely connected different components of the systems are. Alright. Now, understanding these concepts is crucial because they significantly impact the flexibility, the maintainability, and the scalability of software applications. Alright. So coupling essentially is something that determines how closely connected different components or systems are. Alright. Now your software would have different components, right? Like it might have, let's say, authentication component or some other component. How these components are connected to each other. That is what coupling is, right? And coupling can also refer to the connectivity between systems, right? Now let us talk about tight coupling first. All right. Now what is tight coupling? So tight coupling describes a scenario where software components are highly dependent on each other. All right. Now this means that a change in one component will necessitate the changes in another, and this would make a system more rigid and harder to maintain. All right. Now this is what the dependency means over here. Okay. So if you notice, I have used this term highly dependent over here, right? So highly dependent means that if you make a change in one component, that would necessitate that you should make a change in other component as well. That means it's highly dependent on each other. Okay. And that is what tight coupling is. Okay. Let us talk about loose coupling. Now, loose coupling, on the other hand, refers to a design where components are less dependent on each other. Okay. Now, what do you mean by less dependent on each other? It simply means that a change in one component will have minimal or no impact on the other components. Okay. And what this enables you, so this makes your system much more flexible and easier to modify or extend. All right. So if you're making change at one place in your system, it does not mandate the changes to be implemented in other parts of the system. So changes are easier to manage. All right. So that is what loose coupling is. Okay. Now, an example, if I have to give you, of a loosely coupled system is, let's say you have an application that is interacting with the database. Okay. And there is an interface. Okay. It is interacting with the database through an interface. So if the database changes, you can just adjust the implementation behind the interface. Okay. And this would not affect the rest of the application. Okay. The business logic doesn't need to know the details of how data is stored or retrieved. Okay. So if this is just going over the head, don't worry. When we do things hands-on, you will have a complete clarity about this as to how interfaces make this possible. Okay. But for now, just understand that loose coupling describes a scenario where the software components are less dependent on each other. All right. Also, let's talk about the importance of loosely coupled systems in software design. So number one important thing about them is flexibility and maintainability. So loosely coupled systems are easier to maintain and update. Okay, so if there is any update that is required in one component, it does not require widespread alterations throughout the application, right? So it's relatively really easy to maintain and modify, right? Another important thing about this is scalability. So if your system is loosely coupled, it's easier to scale, enhance features, add new things, because individual components can be improved and replaced without impacting others. All right. Testing. This is another important point when it comes to loosely coupled systems. So if components are loosely coupled, they can be tested independently, right? Because you can really isolate the things and you can diagnose the issues. All right. So these are a few important things that depict the importance of loosely coupled systems in software design. All right. Let us talk about achieving loose coupling. Okay. How can you achieve loose coupling in Java? Number one way to achieve is through using interfaces and abstractions. Okay, so you can make use of interfaces, abstract classes to define contracts between components, hiding the implementation details. All right. So if you're familiar with Java, you will know like interfaces and abstract classes enables you to define contracts. So you can make use of them to achieve loose coupling. So Dependency injection. Now this is a technique where components are passed from an external source rather than creating them internally. So for example, if there is a component that has some dependency on another component, so the other component will be passed as a parameter to the first component, okay, so that it can be used, and this is known as dependency injection. All right, event driven architecture. So components will communicate through events or messages, and this will reduce direct dependencies on each other's methods or data. Okay, so these are like some of the things using which you can achieve loose coupling in software system. All right, so that's about tight and loose coupling. Hey there. So now it's time that we go a little bit hands-on and understand what is tight coupling and what is loose coupling. So we have understood theoretically as to what tight and loose means. But it's time that I show you, okay, because when you see an example, you get a better sense of what the concept actually means, right? So I am here on IntelliJ. So open IntelliJ IDEA. Okay, I see a lot of recent projects. Okay, I have been using IntelliJ a lot lately. Okay, so there are quite a few projects that you'll see over here. But what I would do is I would create a new project. Okay, you won't see all these recent projects if you're new to IntelliJ, but I would encourage you all to create a new project here. Okay, make sure you have selected Java here, put in your project name here. Okay, and also select the location where you want your project to exist. Okay, so what I really did is I clicked on this folder icon and I navigated to the directory where I want this project to be created. Okay, once you select the directory, so this is a directory on my desktop under courses, okay, where I wish to have my project being created. And I want to call this project as Spring Example. Okay, and you can see over here, the project will be created in desktop courses SPFS and /Spring Example. Okay, select Maven as your build tool over here. Okay, be sure to select the latest version of JDK. Okay, anything later than 17 should not matter. All right, and then I would encourage you all to say create, but be sure to select Maven as the build tool because Maven is what we'll be using. All right, and I'm not adding any sample code. Okay, so I'll just say create over here, and what this is going to do is this is going to give me a fresh brand new project with a pom.xml. Okay, now pom.xml is a file that can help you manage like all your Maven dependencies, not your Maven dependencies, but all the dependencies that your project needs using Maven. Okay, I have this what's new in IntelliJ IDEA latest version. I'll close this. I'll close this. Okay, project is up and running. Okay, I have this main folder, and what I am going to do is under Java, I am going to create a new package. Okay, so first we are going to see, okay, I'll give you a demonstration of what tight coupling is. So I'll say com.tight coupling. Something like this. Okay, we can create something like this, com.tight.coupling. I'll say okay. And we have this package now, and under this package, we'll create some files. Okay, so what we are going to do is we are going to simulate a scenario. Okay, and the scenario is going to be where we want to fetch user details from a database. Okay, and we are going to implement actually a solution, a very simple solution using tight coupling. Okay, so I'm going to create a few classes. One is user database, like so. Okay, this is one class, and then I'm going to have a user manager over here. So I'm going to say user manager, like so. Okay, and then I'm going to have one more class, which is going to be the main class. So I'm going to say tight coupling example, like so. Okay, so I have user database. Okay, now what this user database is going to do is this is going to access the database, and it is going to get the user information from the database. So it is going to have all the code that allows this application to interact with the database. Okay, so I can have all the code interacting with the database, and let us say I have a method over here. Okay, let's say I want to get the user details, like so. Okay, and I'm going to say return, and I'll say user details from database. Okay, pretty simple. I'm just returning string, and this is just a hypothetical example. Here you can have code, so you can access database over here. Okay, like so. All right, this is done. So I have this user database, and it has a method which is returning me some user information after interacting with the database. All right, now I have the user manager. So what user manager is going to do is, okay, I have a public method over here. Okay, I have a string, I have get user info method here. Okay, and then I'm going to have curly brace, and here I need to make use of the method that we have created over here. Okay, so this method here. So what user manager is doing is, user manager is responsible for managing all the user information. Okay, so it is also going to make use of the methods that we have defined in the user database. So what I need is, I need to make use of this method, and for that I need an instance of user database, right? So here what I'm going to do is, I'm going to say private, and I'm going to say user database. User database is equal to new user database, like so. Okay, now what I can do is, here I can say user database dot get user details. All right, so we are now able to get the user information from here. Okay, now let me switch over to tight coupling example over here. So this is going to be the entry point for our application, and here what I'm going to do is, I'm going to make use of user manager. I'm going to say user manager is equal to new user manager, like so. And here I'm going to, okay, here I'm going to print in user manager dot get user info. All right, now if you run this, it should run without any issues. All right, you should see the output. You can see user details from the database, and this is the string that you have like hard coded over here. Okay, but if you have any database, and if you're connecting your application to the database, you can have your database logic over here. Now what is happening over here is, user manager is tightly coupled with user database. You can see over here how we are like hard coding this over here, right? So tomorrow, let's say our application evolves and we are making use of database A over here. Okay, so let me add a comment, and I'm making use of database A. Okay, and this A can be anything like MySQL. There are so many database vendors, PostgreSQL. Okay, so let's say you're making use of a database over here, and tomorrow if you want to switch to a database B, what are you going to do? So like B can be a web service. So let's say we are no longer making use of a database. We are now making use of a web service. Okay, or let's say we are making use of MongoDB now. Okay, we have changed our requirements. Okay, or something like that. So if there is a change in the database, right, since this is tightly coupled over here, this coupling is happening over here. Okay, so a lot of code will change, and it will be difficult. Like user manager class will also change. Like you will have to touch the code inside user manager just because the database is changing, which is actually not good. Okay, because a small change, and these changes frequently happen in your production grade applications. Okay, now let us see how you would implement the same thing using loose coupling. Okay, so what I'm going to do is, I'm going to like create one more package here. Okay, I'm going to say com.loose, and I'm going to say coupling, something like this. All right, so this is a package, and I'm going to, let's say, copy this thing over here. This entire thing I'm copying over here as well. Okay, and I'm going to close this all. Okay, if you come over here, I have this tight coupling example. I'm going to refactor this, and I'm going to call this as loose coupling. Okay, something like this. All right, and this, okay, so I need to change this as well to loose. It did not ask me automatically. Ideally, IntelliJ asks me whether you want to refactor all the usages, but yeah, that's okay. So now we are here. This is loose coupling example. Okay, now what you would do is, to promote loose coupling, we are going to make use of an interface. Okay, so what you can do is, you can have an interface or an abstract class as well. We'll make use of interface for the sake of this example, but abstract class can also be used. Okay, so you can make use of an interface or an abstract class that defines the contract for fetching the user details. Okay, so what I would do is, I'll say new interface, make sure you select an interface here. Okay, and you can say user data provider. So I can call it anything. I'm calling it user data provider. And here I can specify how I want my user details to be fetched. So I can say get user details, for example. Okay. If I want more methods, I can just declare those methods. So get user details, get username, get password, reset user password, and so on. So whatever methods I want to have when interacting with the database, I can define those over here. Okay. Define as in just declare. I won't be providing any implementation. Okay. Now what I can do is, instead of like having the database over here, okay, I'm going to implement. So whatever class I'm going to create, okay, which has the database logic, I'm going to actually implement this provider over here. Okay, let me show this to you. Okay, so let us say here, instead of user database, I can see this as, let's say I'll refactor this. Okay, I'll refactor user database provider like so. Okay, and I'll refactor this. Okay, and I have this over here. I don't need to get rid of this. Okay, I can simply say implements and I can say user data provider, something like this. Okay, and you can see it is overriding now. This is this thing. This has come over here, which means it is overriding. Okay, you can also add the override annotation over here if you wish to. Okay, something like this. So this is now overriding the definition, or like the method that we have in the interface. Okay, and we are providing the implementation over here. Okay, now what we can do is we can go to the loose coupling example over here. Okay, and instead of creating the instance of user manager over here, okay, we have user manager over here, and this is in loose coupling. So what I would do is I would remove this. Okay, I would say user data provider. Okay, so this is our interface. Okay, I'll say database provider over here. Okay, so let us say we are working with the database right now. Okay, and I'll say new database. So here you're making use of class now. Okay, so what you have done is here you are creating an object of the interface. You are instantiating an object, and you are assigning the object of the class over here. Okay, you can see this is the class. All right, this is a class. Okay, which means it's an implementation of an interface. All right, and in Java you are allowed to do this. All right, and what you can do over here is now, so this is done. Now what we need to do is we need to make use of user manager. All right, but we have not yet modified user manager. So let's come over here. Okay, so here if you see, we are getting like all the red marks because we have renamed the classes. Okay, which is completely fine. So this was an example of tight coupling where we were like hard coding the creation of the object. Okay, but here what we are going to do now is we are not going to hard code. Okay, so let me show you what we are going to do. So here what I'm going to do is I'm going to have a constructor. All right, so instead I'll have a private user data provider. Now what is user data provider? This is a class member, and if you go over here, this is an interface. So we are like having an object of the, or a reference variable of interface over here. Okay, and here I'm going to have a constructor. So I'm going to say generate a constructor. I'm going to say okay, and you can see this is the constructor. Now when instantiating user manager, we are going to provide the implementation as the parameter to this constructor. Okay, so this is an interface, right? Now if you want to fetch the data from the database, you can pass in the object of this class, which is an implementation of user data provider, and it will work over here, right? So these are Java concepts. It will work over here. So let me show this to you. So what I will do is I'll say over here user data provider dot get user details. Okay, so this method remains same, and if you come back to the main class over here, okay, if you are instantiating user manager over here, okay, you can say user manager, and I'll say with db over here is equal to new user manager, and you can see it's asking me for a parameter. So what I can do is, okay, I need to pass in the parameter. So I need to pass in the object of user database provider. right? This class instance. Okay. And here what I'm doing is I'm having the reference variable as the interface, right? So here you can see, I'll copy this and I'll pass this here, right? And this should absolutely work fine. Okay. So if I say user manager with DB, get user info, and if you run this, this should work absolutely fine. No issues as such. Now you will say, hey, why like so much to do? Okay, the earlier one was pretty simple, right? This is like you're creating a reference variable of an interface over here, and you are like assigning it an object of the class, and then you're passing over here, and here you're handling it, all of that. Why you need to do this? So let me give you an example. Let's say our application evolves. So today we are making use of a database. Let's say this is database A. Let's say our application evolves to B. Okay. Let's say we want to make use of web service, and also we want to make use of MongoDB. All right. Let me show you how it will work. Okay. So let's say we want to make use of a web service. No problem. I'm just going to create an implementation of user data provider that talks to the web service and gets the data. Okay. Let me show this to you. So I'm going to say web service data provider. So right now we are having database provider, right? Now I have web service data provider, okay, over here. And what I can do is I can say over here, private. Okay. So here in the user database provider, you had implemented this thing, right? User data provider. So here also I'm going to do the same thing. All right. So let me remove this. I'll say implements user data provider. The moment I do this, I get an error. I need to implement this. Fine. And here I need to add a string that fetching data from web service, right? I save this, and now see the magic. If I come to loose coupling main class over here, okay, now let me show you what I mean. So here I'm going to create user data provider, okay, and right now I want to fetch data from the web service. So I'm going to say web service provider. Okay, so I'm naming my objects uniquely so that it's easy to distinguish which object you're using. All right, I'm going to create an instance of web service data provider here. I'm going to say user manager. Okay, user manager with web service WS. Okay, and I'm going to say new user manager, and I'm going to pass web service provider over here, something like this. All right, and what I can do is using this, okay, with web service dot get user info, you are now able to fetch data from the web service as well. Okay, you can see over here, it's the same user manager class. We have not changed anything. We have not touched user manager. I'm just closing this. Okay, you just added a new provider. So you have an interface that sets the contracts. Okay, so what it's telling any application developer that joins your team, it is telling him that, hey, if you want to provide data source into your application, you need to adhere to this contract. You need to implement this. So if you implement this, you have to provide implementation of this method, right? The moment you provide implementation of this method, so since this is an interface and class relationship, okay, what you can do is in the main, you can create a reference variable, okay, for the interface, and you can assign it an object of the implementation, which is absolutely valid in Java. And then when passing data, when working with user manager, you are like accepting the implementation of this interface. So whoever implements this interface can make use of user manager. That is how it is, right? Isn't this amazing? And this is an example of loose coupling. Okay, now this is really helpful. And even if you add one more manager over here, so let's say we add one more manager. Let's say I have new database. Okay, so I'll say new database provider, something like this. Okay, new database has come in. Let's say we are making use of Mongo. I'll say implements user database provider. All right, and I will, let's say here, from here, implement this. Okay, and I can say new database in action, something like this. All right, and now I've just added the logic of new database, okay, with the help of user data provider. I have not changed the existing code. A new file has been added. That is it. And what I can do is I can come over here. I can just copy this. Okay, here instead of web service provider, I can say new database provider, something like this you can have. And here you can say with new DB, something like this. Okay, here you need to pass this. Okay, this you need to make use over here. All right, you're done. If you run this, you can see fetching data. Okay, it's giving you fetching data from web service. Let me see why. User data with new DB, user data with new DB, new data provider. Okay, so here instead of web service data provider, it will be new database provider. Okay, so be sure that the instance that you are assigning over here, like the instance, that is what you want to use. Okay, so like you saw, I just use web service provider and the output I was getting was from the web service, right? So it was fetching data using web service. Now I change this, so this will switch to new database. All right, so you can see how adding a new database was easy in our application, and this is a great example of loose coupling. Okay, I hope you have a fair understanding of how loose and tight coupling are working here. So in this particular example, let me close all of this. In this particular example, user manager was tightly coupled with user database. Okay, this example, you can see user manager was actually making use of an interface, right? And whoever implements that interface, okay, it was able to make use of user manager. Okay, so during runtime, whichever object type this reference variable was having, that method was being executed. Okay, that provider was being used. So interfaces are being used over here to promote loose coupling. And I hope you have a fair understanding of how loose coupling is important when you want to design a system that is flexible, maintainable, scalable, and so on. Okay, tight coupling is never scalable. Remember this. All right, I hope this was useful. Welcome back, and it's time that we talk about some of the core concepts of Spring and even understand it. Okay, so there will be few concepts that I'll talk about, and I'll also explain this to you with the help of some source code. So please pay attention. These concepts are really important and will form the base. All right, let's first talk about loose coupling. So loose coupling, what is loose coupling? It's a design principle. It's a way of you designing things that aims to reduce the dependencies between components within the system. Okay, so you can say a system is a loosely coupled system when components interact with each other through an well-defined interface. Okay, and they will have minimal knowledge of each other's internal workings and the implementations. Okay, and they are very modular, flexible, and easier to maintain. All right, let me also explain this with the help of the source code. So this is our project. Okay, we have different data providers. Okay, so this is our user data provider interface, and whoever wants to provide any data into our application needs to implement this interface. So this is like a contract, right? Now we have database provider, we have new database provider, and we even have a web service provider. Okay, you can of course group all these providers into a new folder or a package over here, sub package, and you can organize them. But for now, we have three database providers over here in action. Now, if you take a look at the user manager class, this user manager class is dealing with the interface here. So this is the interface, right? This is not the class. Okay, so if you are making use of any of the classes over here, which means any of the interfaces over here, sorry, not interfaces, which means any of the implementations over here of user data provider. Okay, this would make user manager tightly coupled. So if you're making use of, let's say, web data provider over here, okay, web service data provider, this is an implementation of user data provider, right? And since this is an implementation, this step or this move is making user manager tightly coupled with web service data provider. But we are not doing this. What we are doing is we are making use of an interface over here to interact with the web service data provider if we want to, right? And this kind of a setup means that the underlying data provider can change without modifying the user manager's code. How? We have already seen this, right? So if you try to add a new data provider, what would happen is there is no change in user manager. Okay, you have to just add the new provider, and then you have to go into the main class over here. So we had this main class created, and you need to just call it. That is it. You're not making any changes, anything into user manager. And why is this? Because we are interacting with the providers with the help of an interface, and we are not directly making use of the implementations or the providers directly. We have an interface in between. Okay, and this is very helpful in promoting loose coupling, and this is what loose coupling is. All right, so I hope this is making sense. So this is loose coupling. Let's go ahead and let's talk about inversion of control now. So inversion of control is also a design principle. It's a concept that exists where the control of the object creation and the lifecycle management and everything about an object is transferred from the application code to an external container or a framework. All right. Let me explain this. So in simpler terms, inversion of control or IOC, this is also called as IOC. So it means that instead of your code managing, creating the objects directly using the new keyword, the control is inverted. Okay. And objects are provided to you by the framework or container that you're using. Let me explain this to you. Okay. So I'll switch over to ID here. Here in the ID, what is happening? So if you need an object of this, so this user manager needs an object during runtime of user data provider. So the type should be of user data provider, right? Now what is happening is here during runtime, you are calling user manager over here with different object types. So you are calling first with user database provider, then you're calling with web service data provider, then you're calling with new database provider. So different object types, you're making use of different object types to call user manager, right? So what is happening is here during runtime, right? During runtime, this particular class over here, this main class, okay, loose coupling example, this is having the main method. So this particular class is managing the object creation, and it is making sure that user manager gets the appropriate object during runtime. Right? So this is being managed in the code right now. So this is not inversion of control, right? What is inversion of control is if you don't manage this in the code, and if this management of providing the object during runtime is handled by the framework itself. And which framework am I talking about? It's the Spring framework, of course, because that is what we are learning, right? So if Spring framework somehow provides us the object during runtime, so we won't be dealing with this step over here. We won't be dealing with this step. Okay. So if I comment this step and Spring framework somehow provides me the object during runtime, that is what is known as the inversion of control. Okay. And why it's called inversion of control? Because right now we are controlling it, right? We are controlling it with the help of this code, and this control is passed on to Spring framework, which means that the control is inverted, right? So you are passing on the control of doing this to Spring framework, right? So this is inversion of control. You are like inverting, or there is an inversion over there, right? So this is what the inversion of control concept. Okay. And this is one of the important concepts when you're talking about Spring framework. So when you are reading about Spring framework anywhere on the internet or any books or anywhere, you will come across this particular concept. It's really important that you understand this in a simple way. Okay. So here I have this example put up purposely. Okay. So we purposely manage the objects first, right? So instead of user manager creating the class over here, creating the object over here. Okay. What we are doing is we are making use of this particular class, and we are injecting this particular object into user manager. Okay. And who is doing the job of injecting this? We are doing the job of injecting. This loose coupling example class is doing the job of injecting it into the user manager, right? So this is inversion of control at work, but this is not actually being managed by Spring framework right now. So when it's being managed by the framework, it is known as Spring framework. But right now we are only controlling it, right? I hope this is making sense. So we will be soon switching over to inversion of control, where we will allow Spring framework to manage it. Okay. But right now I'm managing it so that you get a better sense of how this is being managed and how bringing Spring into picture will make your life easy. That also you will understand. Okay. So to understand how Spring is making your life easy, you should also understand the toughest part first, right? So if you do things the hard way and then if you switch to Spring, my belief is that you will understand the value of Spring framework even better. Okay. Because you went the hard way first and then you are adding Spring framework and then you're understanding, oh wow, Spring does all this automatically. Okay. So that's the aha moment that you will go through. All right. But that is what inversion of control is, to put out in a very simple way. Inversion of control. So the control right now that is happening of the object management, object creation, and the dependency injection. Okay. So we are injecting the dependency, right? User manager is dependent, like user manager needs this particular thing here, right? And it is dependent on this, right? We need to provide this dependency. So this process of providing the dependency is known as dependency injection, right? So who is providing this? We are providing it from here. Okay. So we are controlling it and we'll soon pass over this to Spring framework. And that is when inversion of control will be in action. Okay. So this is inversion of control. Dependency injection. Now what is dependency injection? I just spoke about it. Okay. So dependency injection is also a pattern that is commonly used in object-oriented programming languages like Java. Now what happens over here is the dependencies of the class are provided externally rather than they are being created within the class itself. So what I mean over here is, okay, if you take a look at this code, here we need this dependency, right? We need an instance of this type, right? Are we creating the instance of this type within user manager itself? No, right? We are bringing it externally with the help of this constructor. So whoever is creating the object of user manager has to provide this. Why? Because this is a dependency. So I'm telling whoever is calling user manager, I'm telling them, hey boss, I need this whenever you are creating the object. So if I try to create an object without this, okay, you'll get an error, of course. So I'm telling the caller that, hey, you need to provide a dependency, which is of what type? Which is of user data provider. So see over here, you're getting this in the syntax as well, right? So you have to pass this. And what you're doing over here is you are injecting the dependency, right? This is being injected into user manager, right? And what is injecting? Injecting means you're providing something externally, and that something is typically the dependency itself, right? So this is what dependency injection is, and we are using this concept in our source code. All right. So I hope this is clear now. And coming over to the concept of beans. So if you've read about Spring Framework, or if you're a Java developer, you must have heard of this concept of beans. Okay. What is beans? Objects that are managed by frameworks are known as beans. This is the simplest definition of beans. Now let me explain this better. Okay. So let me come over here. Here I just said, okay, here we are providing the objects during runtime, right? We are providing the dependency to user manager during runtime, right? You would agree to this. Object is being created. We are providing it during runtime. Object is being created. We are providing during runtime. Okay. We are making use of new keyword as of now. You can see new keyword is being used at so many places, right? Now, if we are making use of Spring features, okay, we won't be creating the dependency, but instead Spring would be doing this for us. It would be managing the life cycle. It would be injecting the dependency on the fly, right? Now for Spring to do that, it has to manage the objects, right? It needs to become a manager. It needs to manage the object so that it can provide whoever needs it during runtime, right? So in order for Spring Framework to allow the management of objects, this concept of bean exists. So bean is nothing but an object that is being managed by the framework. Now, which framework I'm talking about? Spring Framework, of course. So if we want like user data provider to be managed by Spring, we will make it as a bean. And that is what a bean is, right? So this is the simplest explanation of bean and what it is. All right. Now, when I say that the framework is managing beans, okay, or managing the objects, it means that it is managing everything about the object, like the life cycle, the instantiation, and everything, right? And we need to provide something called as configuration to Spring Framework, which talks about the details of the objects that Spring Framework needs to manage. All right. And this configuration is normally provided using a configuration file. So you just need to have a configuration file and you need to have that in the project. Spring will pick it up and it knows, okay, these are the objects that I need to manage, and these are all the beans. All right. And Spring Framework will take care of the rest. All right. So that's about these concepts, people. So these concepts are really important, like the concept of loose coupling, really important. Inversion of control, it's really important. We don't have this implemented yet in our project. We are controlling the object management and the injection of the dependencies, that is also being managed by us right now. So in order to get Spring to do that, we need to use the inversion of control, right? Dependency injection, we saw what is dependency injection, and beans. So these are the 4 important concepts that you need to understand when learning Spring. I hope this was super useful. So let us now talk about Spring Container and configuration. Okay. So what is a Spring Container? So Spring Container, you can think of it like a box, okay, and it manages the creation, management of the objects in your Spring application. So if you have the application running, like a Spring application running, okay, you might want Spring to manage your objects, right? And Spring, with the help of Spring Container, manages the objects. So you can see this box is a Spring Container. And then you have these objects 1, 2, 3, 4, and the entire life cycle of the objects is being managed by Spring Container. So it takes care of the life cycle management. It provides the objects on runtime. So if any of the classes or any of your code needs these objects during runtime and is dependent on this, so this dependency injection is being done by the Spring Container. Okay, so all of this is being taken by Spring Container, and it is one of the important concepts in Spring Framework. Okay, so this is Spring Container. Okay, now there are 2 types of Spring Containers. One is the application context. Okay, and there is one more called as Bean Factory. Okay, Bean Factory is the simplest container which provides basic support for dependency injection. Okay, and application context is a little bit more advanced container than Bean Factory. Okay, and normally people use application context only, but these are the 2 types that you should be aware of. Now we have a Spring Container. Okay, it is managing all the objects. Okay, but one question I would want to ask: how does Spring Container know which objects to manage and where are they defined? So all of that, the details of what to manage, who will tell Spring Container? So we as a developer are responsible to tell Spring Container that we want to manage these objects, and we can tell Spring Containers with the help of a configuration file. Okay, so we'll have some configuration defined created in our project that will be picked up by Spring Framework, and with the help of that configuration, the Spring Container would know, okay, these are the objects that I need to manage, and it will pick up those objects and it will instantiate them. Okay, and it will do everything that it needs to. So this is something that you need to know. So configuration files is something that you need to define to tell which objects are supposed to be managed. All right. Now, what does configuration files contain? Configuration files will contain the Bean definition. Okay. So if you want an object to be managed by Spring Framework, you need to make or declare that particular object as a bean, right? Only then it will be managed. And the configuration file will have the bean definitions. Okay. And definitions meaning like a few lines of code which tells, okay, this is the class and this is something that needs to be managed by Spring. And there is a syntax for that, and Spring Framework will do the rest. Okay, you don't need to worry about the rest. All right. So that's about the Spring Container and the configuration files. So let us now start setting up a Spring project. All right. So I have this project already open, Spring example. Okay. And if you take a look at the project structure, we created this as a Maven project. right? And whenever you create a Maven based project, you get this special file called pom.xml. And this is a file that has the list of all the dependencies, the project configuration that you need. Okay. So you can see over here that we have like some versions defined here. You can see we have the JDK version. Okay. So this is Java 21 version, compiler target. That is something that has been defined. And this is something that we selected during the project creation. Okay. Now what we need to do is we need to convert this project into a Spring project. And how are we going to do that? So we are going to do that with the help of Maven by adding some dependencies over here. Okay, so we need to tell Maven that we need to add some dependencies. So understand this, people. We are making use of Maven. Now earlier, even before Maven was there, if you want to add some dependencies into the project, you had to go to the Google. You had to get the jar files, .jar files of that particular dependency. And you had to add that dependency into the project. Okay, like you had to add those jar files. Okay, so when I say you had to add dependencies, it means you had to add those jar files. But now with Maven, what happens is you just specify the dependency over here in this file, and Maven will do that job of getting the jar file for you. Okay, because I've worked in early days of Java, I used to code, and I have added the jar files into the project. Okay, and trust me guys, it was very difficult because there would be instances wherein you would download a wrong jar file. Okay, and it was very manual. You download, then you copy it to the project location, then you go to the project properties and you add that jar file. But here Maven is making your life easier. Okay, so what we need to do is we need to add two dependencies. Okay, so I'll come over here. I'm going to search for Maven repository over here. Okay, so what is Maven repository? Maven repository is a repository of all the Maven dependencies that you can search, browse, and explore. So this is the official website. You can click on this. All right. And over here, you can search for literally all the dependencies. So since we need Spring dependencies, so we are going to add two dependencies to convert our project into a Spring project. First one is Spring Core. Okay. Now what is Spring Core? So if you see over here, basic building block for Spring that in conjunction with Spring Beans provide dependency injection and IOC related features. And you can see this is the official one. So I'll just go over here to Spring Core. And on this particular page, you are going to see over here, you can see like all the details of this dependency. And here you can see the versions. You can see so many versions over here. Okay. So depending on when you're watching this video, there is a possibility like new version might have come in. Okay, so you can see there are versions being released very frequently, you can see. Okay, so you might see some new version come up over here. Don't worry, just select the latest one and just add it based on the steps that I'm showing you. Okay, because these version updates are really frequent, and I'll update the video if anything significant is introduced or anything changes. All right, anything significant changes. So just click on this. You can see over here, this is the dependency and this is something that you need to add. And you can see over here, Maven, this is the Gradle, this is Gradle Short, Gradle Kotlin. So you have different options over here, depending on which build tool you are using. We are using Maven, right? So I'll copy this, I'll come over here and I need to add this over here. Now to add this, we cannot directly paste it. So of course we'll have to paste it, but before that we need to add a dependencies tag like this. Okay, because under this tag we are going to have all the dependencies added. So I'll add this tag and within this I'll add this dependency. Okay, so you'll see a few red marks, which is absolutely fine. Don't worry about those red marks. Okay, but we added Spring Core. Now what is Spring Core? Spring Core is the foundation of Spring Framework. Okay, it has all the building blocks that our application would need, like all the core utilities and all. Okay, so if you are wanting to convert a Maven project into a Spring project or any project, even if you're using Gradle, you need to add Spring Core. Okay, the next dependency that we are going to add is Spring Context. Okay, that is also important. So I'm going to go over here. I'm going to search for Spring Context. This is the one. So you will go over here, select the latest version like you did for core, copy this, come over here, okay, and you can paste it. All right, and you can save this. Okay, so this is done. Now what you need to do is, okay, whenever you change anything in the pom.xml, what you need to do is you need to reload the changes. Okay, why you need to reload? Because depending on whatever changes you have done, okay, what Maven is going to do is it is going to fetch all the dependencies and it is going to store all the dependencies over here in the external libraries. Okay, so you can see right now we just have Java 21 as the dependency here, right? There's nothing else. Now let me do a refresh. So you can hit refresh over here from here, or you can go to Maven on this M icon and you can also hit refresh over here. Okay, so that is also going to do the same thing. Okay, just in case if you don't see the refresh over here, right? Now you could see when you hit refresh, you'll see some processing at the bottom where it is going to fetch everything. And the moment processing is done, you're going to see the external libraries folder just got updated. You can see, okay, you can see you have, so we had added Spring Core and Spring Context, but you can see a lot of other things have also been added. And these are all related dependencies that our project would need. Okay, so we literally didn't have to do anything. We just specified the dependency over here, and Spring, or I should say Maven, did a wonderful job of getting all the dependencies, all the jar files. You can see these are all jar files from the internet. You can see. Okay, so this is for your information. Okay, you can keep a check on the external libraries folder over here. Okay, so this is about configuring a Spring project. We have just added dependencies, and with the help of these dependencies, our project is now ready to make use of Spring features. All right, so I hope this was useful and I hope you are able to follow the steps. Welcome back. So we have our project set up to work with Spring or to make use of Spring framework. You can see the dependencies have been added in pom.xml. Now what we are going to do is we are going to get started with creating our first bean, and we are going to create a very simple bean. So it is going to be a very simple class which does something really simple, and we are going to get Spring to manage the objects of that class. All right, so first, what we need to do is we need to make sure that the dependencies of Spring are added and we are working with a Spring project. And that is something we have made sure. Now what I'll do is, as a next step, I need to have a class whose object is going to be managed by Spring. So I'm going to say new, I'm going to say new Java class, and I'm going to create this particular class in car.example.bean package. All right, this is a sample package that I'm creating, and I'm going to name this particular class as my bean, something like this. You can call it anything you want. Okay, so this is done. My bean is created. All right, and you can see the package is also created because I entered the fully qualified class name. All right, now what I'm going to do over here is I'm going to have a property or a class member. I can say message. Okay, so this is a bean which has message in it. All right, and what I need is I'll generate some code over here. I need a setter, so we are going to set the message. Okay, and I'm going to print the message. So I'm going to say public and void show message. Okay, something like this, and then I'm just going to say message, and here I'm going to say message. All right, this is done. And also I can have a string representation over here, so I can override this string like this. All right, so this is our class, very simple class. It has one class member message. We also have setter inside, show message, and toString. All right, so this is done and ready. Now what we need to do is we need to get Spring Container to manage this particular class object for us. All right, and for that we need to have a sort of instruction which we are going to provide with the help of configuration file, and we are going to make use of XML format for the same. All right. So what I'm going to do is I am going to head over to resources here. I'm going to right click and I'm going to create a new file here. And I'm going to call this particular file as application bean context.xml. All right. Now we need to add some code over here. Okay. And to add that, I'm going to switch over to our browser because there is going to be a little bit of boilerplate code that we need to add. So I'm going to say over here XML schema based configuration for Spring. You can search for this XML schema based configuration and you're going to get this official URL, which is 40 XML schema based configuration. And this is from the official link. So just click on this. I'll just zoom in a bit, scroll down, and here you are going to see this equivalent file in the XML schema style would be. Okay, and you need to just take this over here. Okay, and you need to come over here, paste it over here. Okay, and you can see this is how the XML starts. All right, we need to add something like this to get started with. All right, so this is done. Okay, we have the bean tag open with some code over here. Okay, now what this code does is this code will set up the necessary XML namespace and schema details to allow you to correctly define and validate Spring Beans. All right, so here you can see the bean tag. Okay, we are setting the XML version first of all and the encoding at the top. Then we are setting up the schema location, you can see, and the namespace. All right, so this is the starting part. Now what we need to do is you need to define the bean. So if you scroll down a little bit, you can see like this particular tag over here. Okay, bean ID, you can see here this as well. All right, so this is bean and you have to specify the ID. ID is nothing but like the name of the bean with which you want it to be identified, and class is nothing but the location of the bean. So what I'm going to do is I'm going to copy this again. You can even type this out. Okay, it's not much. I'm going to copy only the bean tag here, not the property. Okay, property is something that will come to a little later. But here I'll type in bean and I'll close this bean tag, something like this. All right. So now over here, we are providing the definition of the bean. So under beans tag, we have a bean definition. ID is nothing but the identifier of the bean. And I'm going to just call it my bean. Class. So what is the class? Class is going to be a fully qualified class name. So I'm going to say car.example.bean.mybean. Okay, you can see IntelliJ was really helpful here. Okay, so this is done. Now this is the XML configuration. We have given the bean definition. So we are telling Spring that, hey, I have this class created here. Okay, this particular class at this location. I want this particular class to be managed by Spring Container or by Spring Framework. And this is what the identifier of this class is. So if I say I want the object of this class, you need to provide it. Okay. And I won't be making use of fully qualified class name, but I'll be making use of this ID over here. All right. That is done. So now what you need to do is we need to head over here. Okay. And here under this package, I need to add one more class, and I'm going to call this particular class as app. You can call it anything you want. Okay. And this is a class that is going to have the main method, something like this. Okay. Now what we are going to do is we are going to make use of the class that we have created. Now we'll be writing some code to make use of the bean. So first I'm going to load the Spring context from the XML configuration file. So I'm going to say application context. I'm going to say context is equal to new class path XML application context. And over here, I'm going to have the name of the XML file. Okay, so I'm going to say application bean context.xml, something like this. Okay, just make sure you don't make any spelling mistakes here. Otherwise, your code won't work. Okay, so, okay, this line is a little bit long, so I'm going to just take this to a new line. Okay, so I have this Spring context being loaded. Okay, now what I'm going to do is I'm going to say my bean is equal to context dot, you can see this get bean method, and here I'm going to pass which bean I want. So what is the identifier of the bean? It is my bean. Okay. And then I'm going to simply say system.out.println myBean. I'm getting this red line over here. So I'm going to just cast this to myBean. Let me run this. You can see the output over here. So this is coming in from here. Okay. This toString method in action. Okay. So it is giving us the string representation of this particular class object. Okay. So we are able to get the object, but right now the message is null. Why is it null? Because it was not initialized. There is no initial value. We are not calling the setter or anything. Okay. So just head over to app.java and let us understand what happened over here. So it was a 3-step process. Okay. In the first step, we first loaded the Spring context from the XML configuration file. Okay. So what we did is we made use of application context. And if you go inside, this is an interface. You can see this is an interface in Spring representing the IOC container that manages the beans and the dependencies. All right. And we made use of class path application XML application context. So this is a specific implementation of application context. And this implementation loads the context definition from an XML file located in the class path. Okay. And this class is responsible for setting up and configuring the Spring container. Okay. And as the argument, as you can see, I have passed in the name of the XML file. And this is the XML file that contains the Spring Bean definition as to where is it located, its ID, identifier, and so on. Okay. So it's loaded, and Spring container with the help of this XML file knows that this is the class that I need to provide when requested. Now in the next step, what we did is we retrieved myBean from the context. Okay. So what we are doing is we are making use of getBean method. And we are saying that, hey, from the context, give me myBean object. I need that. Okay. And since this is being managed by Spring now, Spring gives you the object of the same. Okay. And then we are just displaying the bean information. Now, one small problem we have over here, in fact, I would say 1 second. So if you run this, you saw that we were getting the message as null. Okay. And here, if you go, you saw something called as property. Now, what is property? Okay. So property is a tag which is used within the bean definition within your XML configuration file. And what it does is it provides the values for the attributes defined within the class. Okay. So over here, if I want to initialize message with some value, I can provide that with the help of property. Okay. So what I can do over here is I can come over here. I can say property, something like this. You can see property name. I can say message. So what is the name of the property? It's message. What is the value I need to provide? I am a first bean. So I can provide any value here. Okay. This is done. I can close it this way. Let me run this again. Okay. Let us run and see. You can see the value is now being populated over here in the message, and it is being printed with the help of toString. Okay. Now what happened over here? Okay. So what happened is when you added property, what Spring context IOC, Spring IOC does is it invokes a setter, like the corresponding setter from the class. Okay. And it will set the value over here. Okay. So whatever value you're passing, so it will look for message over here because property name is message. So it will look for message, it will look for the corresponding setter, and it will set the value. Okay, that is what Spring IOC container is going to do. And this call to the setter is being done automatically. We are not doing this. We have just told the Spring IOC container via this configuration file that, hey, this is a property that you need to initialize, and this is the value. Okay. Okay. It will also work without this property tag. We did an execution without this property tag, but the value that we got was the default value, right? And default value can be anything. It can lead to errors, but if you want the attributes to be initialized properly, you need to make use of property. And if you don't have a corresponding setter, so let me comment this. If you don't have a setter and if you're making use of property, let me run this. You can see you get an error. If you scroll up, you'll see it clearly says error occurred, exception occurred during context initialization. Okay. And what is the error? creating bean with my bean defined in class path resource has failed because invalid property message of bean class. Bean property message is not writable or has an invalid setter method. It does not have a setter. We commented the setter, right? So that's the problem, and it is not able to create that bean, and the application has ended, right? So I'll just uncomment this. I'll run this, and you see this absolutely fine, right? So yeah, this is the entire mechanism, and here you can see like the dependency injection also in the work. Okay, so you need this object. Okay, this is provided to you by Spring. Okay, and you can see like how Spring is managing, and whenever you ask for it, it is simply going to provide that particular thing to you at any point in the program. All right, so that's about bean creation and how you can create your first bean. I hope this was useful. So now it's time that we talk about the life cycle of a bean. What is a bean? Objects that are managed by frameworks are simply known as beans. And to work with beans, you need to have something called as bean definition, which will include the configuration metadata that the container needs to know to create and manage the bean. The bean configuration or the bean definitions can be provided in various ways, like XML configuration file. You can even have annotations and Java-based configuration. Beans are configured using XML files where each bean is defined within bean tag with attributes specifying class, properties, and even dependencies. You can even make use of annotations like component, service, repository, and these would be picked up by Spring and managed as beans. Now let us talk about life cycle. So the first step in the life cycle of the bean is instantiation. So this is the first phase where the bean instance is created using the bean definition and the constructor injection. Then the population of properties would happen, which means that the properties would be set on the bean instance either through the setter, constructor, or field injection. Then you would have initialization. So during this step, the initialization method is invoked after the properties are set. Then your bean is marked ready for use, and once the bean is used, it is destructed, okay, or it is removed from the container during the application shutdown. So this is the typical life cycle of the bean. Okay, so that's about bean life cycle, and I hope this was useful. It's time that we talk about dependency injection. So dependency injection is a design pattern that is used in software development to achieve loose coupling. Okay, and we can achieve loose coupling by removing the direct dependency instantiation. So whenever there is a dependency, normally you instantiate one class within another, right? And with the help of dependency injection, you can simply remove that instantiation process, and the dependency can be provided on the fly during runtime. How it can be provided? It can be provided with the help of dependency injection, and there are two ways of doing so, or two types I can say. One is constructor injection and other one is setter injection. So these are the two types of dependency injection that exist. And now let's head over to see how constructor injection and setter injection work. So now it's time that we talk about constructor injection. What is constructor injection? Constructor injection is a type of dependency injection where dependencies are provided to the class that is dependent through its constructor. Simple. Okay, so here to provide the dependencies, constructor is being used, and that is why it is called constructor injection. And how is the dependency provided? So of course, we are making use of arguments and parameters to the constructor when the dependent class is instantiated. All right. And this particular thing, constructor injection, ensures that the dependencies are available when the object is created. Let us take a look at a hands-on example for the same. And I'm going to switch over to IntelliJ. So now over here in IntelliJ, what I'm simply going to do is I will create a new class. Okay, so we are going to take a new class example, and I'm going to have this class as let's say specification. Okay, so this is a specification class for the class car. Okay, so we will be having two classes. One is the car class and another one is the specification class, which is going to maintain the specification of the class. Sorry, not of the class, but of the car. Okay. And this way we are creating dependencies between two classes, and we'll take a look at this example. Okay. So specification, and I'm going to say car dot example dot constructor dot injection, something like this. Okay. You can call your package whatever you want, but I'm making use of this here. Okay. And I'll also need one more class over here, which is the car class. Okay. This is done. I'll also need one more class over here, which is the app. Now this is going to be the main class. Okay. I'll close this and we'll come over here in the coding editor. Now in the specification, let me store a few specification, like a few properties about car. So what I can say is I can say private string, and I can say make. So this will store the make of the car. Then I can say private string, and I can say model. Okay, this will store the model of the car. Okay, what I need to do is I'll generate getter setter like so. Okay, I will also get the toString created. Okay, like this. Okay, so this is also done. Okay, we have our specification class set. Now within car, what we are going to do is we have this car class dependent on specification. So we are going to simulate that scenario. We'll say specification. Okay. And now what we need to do is we will be having a, let's say, generate over here. And I can say, okay, I don't need to use generate. In fact, I can say public void display details. So we are displaying the details of the car. And how are we displaying the details? We are saying system.out.println. I'll print in car details like this. And I can say specification dot toString. Okay, I'm just getting string version of specification object here. Okay. Now what we need to do is we need to have a configuration created as well. So now to define the configuration, I'm going to open the project structure. I'm going to head over to resources and I'm going to create a new file. And this file is going to be a new application, a new XML file. Sorry. So I can call this as application. And since we are talking about constructor injection, I'll just make it explicit. Constructor injection.xml. Okay. We'll need some boilerplate code. So I'm just going to copy it from this particular file and I'm just going to move it over here. Okay. We're going to change a lot of stuff over here. All right. So this is like the bean tag. We leave it as it is. Okay. Here in the bean tag, we first create the bean of car specification. So I'll say specification, something like this. And then here I can say car dot, I can say constructor dot injection dot, and okay, let me see what is the path. Car dot example dot constructor dot injection. Okay. So let me copy this so that I don't make any mistake here. Okay. So I'll come over here and let me paste this over here. Dot, and you can see the specification appear. Be sure to have the right fully qualified class name over here. Okay. That is important. Now what I'm going to do is I'm going to set some properties. I can say make. What is the make? Let us say Toyota. Okay, you can have any favorite car make over here. Okay, doesn't matter. We are learning. Model is, let's say, Corolla. Okay, this is done. This bean is set. The ID is the car specification. So what we have done is we have defined the dependent bean over here. This is the dependent bean. Okay, so or this bean is needed by car class, I should say. Okay. So car needs this as a dependency. So we first define the dependency. Now we'll come over here. What I need to do is I will have bean over here, and then I'm going to have like the ID here. Okay. What is the ID? I can say my car. You can give this any sensible identifier over here. You can add class over here, and you can say car dot example dot, you can say constructor dot injection dot car. Okay. And then come over here, and now here things become important. Okay. So we have this bean. Okay. And this bean that we are newly creating now needs this as the dependency, right? So car needs specification as the dependency, right? Specification as the dependency. So what we need to do is over here, we need to add a tag, okay, for doing constructor injection. So you can see the list of tag over here. Okay. So here you will see one tag, which is constructor arg, which is constructor argument. Okay. Now this tag is used to define the arguments that are passed to the constructor when a bean is created. Okay. And what we can do is we can have this created over here like this. Okay. And you can say reference. What is the reference? Car specification. Just be sure that the ID matches exactly the ID that you have defined over here. Otherwise, like, it won't make sense, right? Now we are saying like pass this as the constructor argument, but we don't have the constructor defined over here, right? So what we can do is we can have a constructor. Sorry, I just pressed the wrong button. You can say constructor like so. Okay. Constructor is done. Okay. I think we have done the dependency as well, like the configuration over here as well. Now we need to head over to app.java. Okay. And what we need to do over here is we need to add public static void main. I need to say the application context as context, new class path application context, and I'll move this to the new line. Okay. And over here, I need to pass in the name like application. Okay, 1 second. So what is the name? Application. 1 second. So I'll just copy this name. That will be better. Also, I just feel 1 second. I just feel like instead of construction, it should be constructor. Okay, like this. And I'll say refactor. Come over here and add that over here. Okay. And you need to add the .xml. This is done. Okay. So yeah, I'm loading the XML. Okay. Now what I need to do is I can say car. Okay. I can say my car. Let's say my car is equal to context.getBean. I can say my car over here. Okay. This is the ID. Okay. And what I need to do is I can cast this. Okay. So there was one more option as well. If you see, okay, let me like hover on this. Okay. So one more option, you can even change the my car type to object. So I don't want to do that. Okay. I need to retain the object type. Okay. So I can have now my car dot display details, something like this. Okay. Let us see what is the output that we get with this. So I'll run this. Let us see. So you can see specification, which is make is Toyota and model is Corolla. How are we getting this? Okay. We are getting this with the help of this process called constructor injection, which we are doing over here. Okay. So we are creating a bean and then we are injecting it via the constructor. Okay. And how are we doing this? With the help of this particular tag in the XML. So what is happening is during instantiation, the Spring container is looking for this constructor here, and it is making sure that it is passing in the bean over here, which is of type specification. All right. So that's about constructor injection and how you can make it happen in your projects. So now it's time that we talk about the setter injection. So in constructor injection, we injected the dependency with the help of this constructor, and we made use of a configuration file over here. Okay. So what I'm going to do is I am going to create a new class. Okay. I'm not going to make use of same package, but I'll create a new class called car, okay, and it will exist in car.example.setter.injection, something like this. Okay, this is created, and in fact a lot of code will be similar, so let me just copy the constructor injection files into like the setter injection, okay, something like this. And now if I see over here, okay, here you see app, car, and specification. Okay, so you have a specification, you have car. Now this car is being provided the dependency with the help of a constructor. What I'm going to do is I'll remove this and I'll add a setter. Why a setter? Because of course we are talking about setter injection, so we need a setter. We'll get rid of constructor. Okay, rest everything remains same. I will duplicate this XML as well, and here I'll say application.setter.injection. Okay, something like this. Okay, now over here what I can do is, here if you take a look at the configuration, we are making use of constructor arg tag over here to inject the dependency using the constructor. What we can do is I'll get rid of this, and since we are making use of setter injection, okay, we can make use of property. So with the help of this property tag, you are instructing to make use of setter injection. Okay, and we are already using setter injection over here. Okay, so here these values are being initialized with the help of the setters that you have defined over here. So these setters that you have defined, this set make and set model, is being called because you have added these two property tags. So same goes for car class. You'll say name, okay, here, and what is the name of the property? So name of the property is specification. So you will add this over here. What is the reference? Okay, so, or what is the value, not reference over here. Okay, so value, we need to add this bean ID. Okay, like so, and you need to add the closing tag. Done. Okay, now let us come to app.java. Here, instead of loading this application constructor injection, I'm going to say setter injection.xml. Okay, let me run and see this. Okay, let us see what happens. So here we are getting an error. It says that it's not able to create this bean because there is no default constructor found in car. You can see this is a class. So, okay, and it is pointing us to constructor injection car. So there is a problem. Let me see what the problem is. Okay, so the problem is here when, so since we copied the files, we updated the property over here, but we did not change this fully qualified class name. So it should point to setter injection.car, right? Now it should be okay. And let us run and see what is the error that we get. Okay, if you scroll up over here. So the error says it is not able to create a bean defined over here in this XML. Okay, so there seems to be some issue in the XML. Let us check our configuration. Alright, so we changed setter over here, but we failed to change the setter over here. We are still referring to constructor over here. So if you're copying XML files, just be careful, okay, that you're changing everything and you're pointing to the right files. Alright, and one more thing I believe we need to change. Here we are having a value as that of property, but here we need to have that as reference, since we are referring this to another bean over here. Okay, so this will be ref. And now let me run this. Let us see. Okay, so it works perfectly fine now. You can see. And what is happening over here is we are making use of setter injection. So this is the setter. There is no constructor, as you can see. And we made use of property tag for the same. All right. So I hope this was useful, and I hope you have clarity about setter injection in Spring. So welcome back, and now it's challenge time. So we have come very far in understanding the Spring concepts and how things work. One of the examples that we took a look at was this loose coupling example, where we worked with database providers, like data providers. So one was the new database provider, then we had user database provider, and then we had a web service data provider. So these were the three implementations of user data provider, right? So this interface user data provider had three implementations, which were these. And then we made use of user manager, which had a dependency on user data provider. And we were manually passing this dependency using this constructor. Okay, so if you go to the loose coupling example over here, we were passing this dependency manually. So you can see this dependency, we were creating the instance of this, and then we were passing it over here. Okay, user data provider, you can see. Okay, web service data provider. So if you want the data from web service, we were instantiating manually and we were passing in the dependency. So what we need to do now is, the challenge right now is, you understand what is IOC, you understand what is like dependency injection, constructor injection, setter injection. So we need to implement IOC over here, inversion of control. Right now, we are managing the objects. Okay. Now we want to get Spring to manage the object. And of course, this is a Spring project. So if you have been following along, we have added the Spring dependencies as well. So we have Spring over here. And this example we wrote was before configuring Spring into our project. So we need to make use of Spring features now and get rid of managing the dependencies ourselves. Okay, because we have such an amazing tool at work. So why would we do the work, right? We should get the tool to do the work. So what I would recommend you all is to start implementing this. Okay, I'll give you a few hints over here. So we have this user data provider, which is being passed to user manager as a constructor. The implementation is being passed over here, right? So what you need to do is, you need to make use of something called as constructor injection. Okay, because we are making use of constructor over here. So this code won't change absolutely. You'll be just adding the XML file to inject the bean. Okay, first you will get the bean created for all the implementations. Okay, and then what you can do is, you can pass in the dependencies. All right, and with the help of that, okay, what will happen is, you will be able to inject the dependency into user manager. Okay, and then in this main file over here, you need to create the context, load the configuration, and directly request the IOC container for the beans that we have created. Okay, and we won't be instantiating the bean, but Spring IOC will help us with that. So just try to attempt this. Okay, pause the video right now, try attempting this, and then play the video again to watch the solution. I would be having the solution right now. Okay, but I want you to try out first. Remember, the goal is not to get the right answer here, but the goal is to go hands-on and to test ourselves. Okay, the more hands-on you go, it's okay if your answer is not correct or if you're not able to solve it, that's perfectly fine. It's understood. But the point is, you going hands-on will help you understand things, and that's really important. That's the goal of this exercise. Okay, not getting the right answer. Okay, so pause the video and try attempting this. Welcome back. I hope you all got a chance to attempt this. What I'm going to do is, I'm going to begin the implementation for the same. Okay, so what I need to do is, I'll go over here, and here in resources, I'll create a new XML file. Okay, so I'll say new XML file. I'll say application IOC, and this will be for loose coupling example, right? So I'll have this entire name over here. Okay, this is added. We'll need some boilerplate code. I'll copy this boilerplate code. I'll go over here. I'll paste it. Okay, so this is done. Now what we need to do is, we need to have the beans created. All right. So what I'll say is bean ID. Okay, and I'll just get rid of this. We don't need this. Okay, there is no need of property also to begin with. Okay, so this is simply the bean definition that I'm going to have. Okay, we can remove this. Okay, so I need a bean to be created. Now whose bean I'll create? I'll create the bean of the provider. So we have database provider, new database provider, and the web service data provider. So you can see web service data provider, user database provider, and new database provider. Okay, so what I'll say is, I'll say over here com dot loose dot coupling dot. Okay, am I referring to the right package? Com dot loose dot coupling. Okay, one second. So it's better that I replicate this package, right? So this is the code that we created for loose coupling example. Okay, so what I would do is, or what I would prefer doing is, I would like copy this entire thing. I'll go over here, I'll try to paste this, and I'll paste it to this directory. Okay, 1 second. So I'll copy this. Okay, where will I paste it? I'll say com.ioc, and I guess the coupling package will be automatically added. You can see it's added. Okay, so we just replicated this com.ioc.coupling. This is our new package where we are going to make the modification. So we have the original code intact. Okay, we are not touching the original code. So I'll say ioc.coupling and let's say we want to say database. Okay, so we'll get the user database provider. Okay, and we'll call this bean as, what are we calling this as? We'll say this as user data provider, like so. Okay, I'll hide this. This is done. Okay, this is the definition. I need to duplicate this. Okay, let me duplicate. So I'll copy this, come over here. This is another bean now. Okay, now instead of user data provider, what I need to do is user database provider is done. I need to have new database provider. Okay, and here instead of user data provider, I'll say new over here, like so. You need to give the right names and you need to make sure that you're referring to the right classes. Okay, now here coupling dot, I have web service data provider. Okay, and here I'm going to say web service. So I'll say web service data provider. So I'm having the bean name same as the class name, just the first letter is in small caps. Okay, that's the difference. Okay, easy to identify. So there are 3 implementations of user data provider, right? And we have all the 3 implementations being added here. Now, what we need to do over here is I need to create bean. Okay, now I'll create 3 beans over here. Why 3 beans? So I need to have 1 bean. So there are 3 implementations, right? So I'll have 3 beans of user manager. Okay, so let me go to user manager. So here in the user manager, let me close others. Okay, and let me open this. Okay, so here in the user manager, okay, I need the instance of user data provider. Now user data provider is an interface and it has 3 implementations, right? So if you take a look at the list of implementations, there are 3 implementations that it has, right? So what we need to do is we need to have 3 beans of user manager with each implementation, because during runtime we might need any of the implementation, right? So what you can do is come over here, you'll say bean, I'll say ID, and here we'll have a ID shortly, we'll have class also defined, and here I'll make use of constructor argument. Why constructor argument? Because we are having constructor in the user manager class. Okay, so here constructor arg, and I'm going to have reference over here. Okay, so this is the structure that I'm going to use. I'll copy this structure because we are going to replicate this 3 times. So here in place of ID, I'm simply going to say user manager. So we'll add user data provider. Okay, so user manager with user data provider, something like this. Okay, what is the class? Okay, so the class is com.ioc.coupling.user manager. This is the class. Okay, what is the reference over here? Okay, so reference is this. So user data provider. Okay, so I will be copying this shortly, but let me replicate this 3 times. Okay, this is replicated. Now I can copy this here and I can paste it over here. This is done. Okay, now I need to have another implementation, com.ioc.coupling. Let us say new database provider. Okay, and I'll say user manager with, instead of user data provider, I'll say new database provider, something like this. Okay, and in place of reference over here, I'll say with user data provider. Okay, not this one, but it's this one, new data provider. Okay, just be sure that you are mapping the right ones over here, otherwise it will be a mess. Okay, now here I can say com.ioc.coupling.user manager again. Okay, sorry, this one will be user manager here. This one won't be, because we are creating an instance of user manager. Okay, and we are passing in the constructor reference of new database provider. Okay, so this one also will be user manager, and here I can have what should be the name, web service. So user manager with web service provider. Okay, service provider, something like this, and here it will be web service data provider, something like this, right? So we have 3 beans created with 3 different implementations. Perfect. Now let us head over to app or loose coupling example over here. Okay, this was our main file. I can refactor this class here. I can rename it to IOC example. Okay, so I can say IOC example, refactor. Okay, this is also refactored, right? And yeah, this is done. So now if you come over here, what we need to do over here is we need to load the XML, and we need to get that XML to work. Okay, so first I'll start with application context is equal to new class path application context. So this is how we have loaded all the time. So if you go to any of the examples here, okay, this is how we have loaded all the time, and you can copy this code from here, or you can write it from scratch. Okay, up to you. Now over here we need to pass in the XML file. Okay, this will be the location of the configuration file. Okay, so to avoid any errors, I'm simply going to go over here, refactor, rename, and I'm going to copy this entire XML name, and I'm going to come over here and paste it. Okay, so far so good. We have this done. Now what we need to do is, here I'll say, okay, I don't need to create an object here, so I'll comment this. Okay, now if you come over here, we need the instance over here, right? So what I need to do is user manager with TP. So instead of creating object this way, I'll duplicate this line. Instead of creating the object this way, I'll say is equal to, okay, and I'll say context dot get bean. Okay, we need to get user manager with user database provider, right? So I'll come over here, user manager, okay, with user data provider. So this is the one, and I'll copy this name. I'll come over here, I'll paste it over here, okay, and I'll cast it. Done. Let us run and let us see whether it works. Let us see this. You can see this is working fine. We have only changed one implementation or one call over here. Okay, so we are not instantiating object, but we are getting it as a bean over here. You can see. Okay, and I can even move this to the new line so that you get a better visibility. Okay, it's a simple code. Here also we will like duplicate this. I will comment this like so. Okay, and here I'll copy this. Okay, I'll take this to the next line. Okay, and here I need a user manager with web service data provider. So user manager, this is new database provider, user manager with web service data provider. So I'll copy this and I'll come over here, I'll paste it. Okay, does this work fine? It should. Yes, it is. You can see. Okay, now I'll do the same with this. So here also I'll duplicate. I'll comment these two lines here. Okay, and here I'll let me copy this entire thing. Okay, and I'll head over to the new line and I'll paste it, something like this. Okay, and now here we need user manager with new database provider. So I'll just paste that over here. Okay, if you run this, it should work absolutely fine. You can see like how we are able to make use of a Spring container to get it to manage our objects. Okay, so I'm going to just remove this commented code over here. Okay, all the commented code. So, yep, like this, and this one as well. Okay, so we have achieved, and we have finished the challenge. So we were able to make use of Spring Container and Spring features to implement inversion of control. So now what is happening over here is Spring is managing all the objects for us, and we just need to request the objects. We don't need to manage them. Okay. So I hope this was useful, and I hope you were able to solve this by yourself. If you were not able to, that's absolutely fine. Like I said, the goal of this challenge was to get you a little bit hands-on and not expect the right answer. Getting hands-on is really important when you're learning to code. Remember. So I hope this was useful, and I hope you all enjoyed this example. So now it's time that we talk about auto-wiring and understand what it is and why is it needed. So far, what we have been doing is, with the help of XML, we have been, I won't say managing, we have been defining the dependencies, right? So earlier, we used to create the objects and manage the dependencies within the Java classes. But now what we are doing is we have a XML configuration where we tell what is dependent on what. So here, for example, you have this bean car specification, and this is added as a dependency for the bean with car class. Okay. So you are specifying the dependency over here. Okay. Now Spring Framework has this amazing feature called auto-wiring. Okay. And this is a feature that automatically resolves and injects dependencies between beans without requiring explicit wiring definitions in XML or even in Java configurations. Okay. So here we are having the wiring definitions. Like we are telling that, hey, this bean needs this dependency. Okay. But here, imagine this. So Spring knows that, hey, you have this car class. Okay. And it has this object of type specification. So it can also figure out, right, that, hey, this dependency is needed. So I should actually be providing this during runtime so that the application runs. And that is what the process of auto-wiring is. And this way of wiring dependencies based on predefined rules and the types of beans is known as auto-wiring. It's completely auto-wired. It's one step ahead than what we have been doing. Now, when you talk about auto-wiring, there are different types in which beans can be auto-wired. Okay. So first, understand this. For auto-wiring to work, you need to have two classes So two classes. Here I have two classes and one is dependent on other. So car is dependent on specification. Okay. And now auto-wiring can be implemented in three types. It can be implemented by type. So here, like the type of object is specification. The Spring, we won't inject. Spring would inject the bean based on its type. Okay. And that is what auto-wiring by type. Then we have auto-wiring by name. So here we have the object name, or the attribute name, I should say, the class member variable name. And then we also have the bean name, right, which we create over here, like defined using ID over here, right? So this can also be used to auto-wire. So this is known as auto-wiring by name. Then you have auto-wiring by constructor. So it will match the constructor arguments of bean. So here we have a constructor argument as specification. So it will use this constructor to inject beans, and that is known as auto-wiring by constructor. Okay. So there are three types. One is auto-wiring by type. So this is a type. Auto-wiring by name. This is a name. And auto-wiring by constructor. All right. So this is something that you need to understand. Now, auto-wiring simplifies a lot of stuff. Okay. It is one step ahead of what we have been doing. It brings in a lot of efficiency in development, wherein you don't have to manage specify the dependency. In fact, we are not managing. We are specifying the dependencies, and we are telling Spring Boot that this is how it has to be managed. But actually, if you take a look at the code speaks for itself, right? Spring can automatically take a look at the code and auto-wire things. Okay. So that is the benefit of auto-wiring. The disadvantage over here, I would say, is with XML configuration, you have good control. So you can specify the reference and all of that yourself, having full control in your hand. But when you pass on the control to Spring Framework, you lose a bit of control, okay, which has its pros and cons as well, okay. So that's auto-wiring. I hope the concept of auto-wiring is clear right now, and I hope this was useful. So now it's time that we talk about auto-wiring and we understand auto-wiring by name in a hands-on way. So auto-wiring, like we know, is a feature in Spring using which dependencies between the bean is resolved on the fly. Okay. And when you say auto-wiring by name, the dependency is resolved by name. All right. Let us see how this works. So we already have an example in place where we had done constructor injection. So here we had done constructor injection to get the dependency resolution. Okay. So here, if you take a look at this particular package here, we have class car, which needs the type of specification as a dependency over here. Okay. So car is dependent on specification, and specification is an independent class that stores the specifications of the class. Okay. How is specification injected into car class? It is injected via this constructor. Okay. And here, if you see in the constructor injection.xml, we had injected this using this particular tag. Okay. Which means we were telling Spring that, hey, this bean is dependent on this and this is how you are supposed to inject it. But what would happen with auto wiring is the dependencies would be figured out by Spring automatically. And since we are talking about auto wiring by name, we are going to see how name plays a crucial role here. Okay. So what I'm going to do is I'll create a new class over here. Okay. I'll say com.example.autowire.name. Okay. .car. So this is the class that I'm creating in com.example.autowire.name. Okay. And I'm having a very descriptive package name, a very long one, just to keep it very verbose. Okay. So later on, if we refer, we know that, hey, this package contains the files which show the example for auto wiring by name. Okay. I'm going to create this and the file would be created over here. Okay. Now what we need to do over here is we can type in the code manually, or what I can do is I can go to the constructor injection package and I can copy all of this. Okay. I can move all of this to this package and I'll say override for all. Okay. I'm getting this pop-up, add files to Git. So I have this version control system configured and that is why I'm getting these pop-ups. So I'll just say add over here. Okay. And what I also need is an XML file. So I'll just replicate this constructor injection file because that is the closest that we have over here. And I'll call this file as autowire by name. So we know, okay, this particular file has that particular config. Okay. And let me collapse everything now. No, actually I should close all the tabs here and I should open all these files here. Right? Because these are the files that we are going to work with to see this particular example. Okay. Now what we need to do over here is first thing, we need to load autowire by name over here. Okay. So I need to say autowire by name.xml. Okay. We are getting this particular bean over here and we are displaying the details. Fair enough. Now, if you come over here, okay, we need to make a little bit of configuration changes. So what we are doing here is we are creating this bean of car specification, and then we are like having this bean created, which is of car, and then we are mapping it with specification using the constructor injection. We don't want to use constructor injection right now, so I'll get rid of this. Okay. Also, I need to update these classes. So they are pointing to constructor injection package. I need to update them to car.example.autowire. Okay, so what is the package name? I forgot. com.example. Okay, so it's not car. That is why I was not getting suggestion. So it's com.example.autowire.name. Okay, this is the package name. So we have the fully qualified class name right now for the car as well as the specification. Okay. So we are done. Okay. They're pointing now to the right classes. Okay. Now what I need to do is here when we are creating the bean, I need to say that for this particular bean, so car bean is having the dependency on specification, right? And when I pressed space over here, so you can see, let me close the tag over here. And when I pressed space here, you can see there are so many properties that you can add, attributes. So I can select Autowire, and it has a lot of values that you can assign: by name, by constructor, by type. So since we are talking about by name, let us select by name over here. Okay. Now how by name would work is, it would go to car class. So since we are saying whatever dependencies car class needs, please auto-wire them by name. Okay, that is what this statement means. Okay, so what Spring is going to do is, it will go to car class. Okay, it will see, all right, it has one class that it needs, one class object. Okay, and since we have specified by name, it is going to look for specification over here. So it will take a look at the name, because we are saying by name, and it will try to find a matching bean by this particular name. Okay, it will try to find a matching bean by this particular name. So keep this in mind. And do we have a bean matching this particular name? We don't have, right? This bean is called as car specification and not specification here. So I'll take this name here and I'll paste it over here and I'll save it. Okay. And here, then what it will do is, in order to initialize this, it needs to initialize. It won't need a constructor. So constructor we had, because this is an example copied from Constructor injection, right? So we don't need a constructor because it won't be used. This initialization would be done by a setter. Okay. And we will add a setter for the same. Okay. So I can say setter and we'll add a setter, something like this. So let me show this to you in action. So I'll go over here. I'll say run. Okay. And you can see you got Toyota and model is Corolla. Okay. Now let me experiment with this code. Okay. So before even experimenting, let me explain this to you once again. Okay. So I'll give you a step-by-step explanation as to what is happening over here. So first of all, the configuration is looked up. Okay. So here you say, hey, load the configuration. Okay. So configuration is looked up. Spring says, okay, there is this bean that has to be created. Fine. I'll create this bean. These are the properties. I'll set the property. Okay. It sets the property using what? Setter. So in specification, it calls all the setters. Okay. You can even validate this. So you can say system.out.println setter called make. Okay. If you run this, you'll see setter being called, right? So those properties are being initialized with the help of setter. Okay. You can validate it by adding print statements anywhere you want. Okay. So this bean is done. All right. Now what happens? It looks for the second bean definition here. It says, all right, there is one more bean that I need to manage. This is the class definition. Okay. And I have to auto-wire it by name. Okay. So all the dependencies that this particular class needs, it has to auto-wire by name. And what it means is, the name of the bean should be same as the property name within car class. So it goes in the car class. It sees, okay, this specification that it needs, and the name is specification. How do I match it? So the developer has said by name. So I'll try to look for bean that matches this name. Do we have a bean that matches this name? Yes, we do have. So inject it over here. How it will inject? Okay. So since the car bean has the property name specification of type specification here, and auto wiring is configured to be by name, Spring will try to find the bean with that name specification and it will inject it. And when injecting, it will call the setter method. Okay, keep this in mind. So by name, when you try to use auto wiring by name, the injection happens with the help of setter. Okay, and this way it will be initialized and then the next step happens. Okay, so next step are defined over here. So we get the car object and then we call display details. Okay, now let me experiment with this code. So let me first comment the setter. We said that setter is being used over here, right? So what happens if I don't have a setter? You can see over here we got an exception that toString was called over here. Okay, so here if you see, we are calling display details, right? And display detail is converting the specification object to string, and specification is not initialized. Remember, we have commented the setter over here, right? So it's not initialized, so specification is null, and that is why we are getting this error, right? So setter is important. If you're getting null, you must have missed the setter. Okay. If you come over here, I also mentioned that when you say autowiring by name, the name should be equal to the attribute name or the class member name in the car class. Okay. So let's say what happens if I change the name. So if I add 1 over here. Okay. Now the name is not matching, right? This is specification 1 and this is specification. So if I run this, you'll see it is again null. So even though we have a setter, it is still null because it is not able to find the bean. So if the bean is not found, it is not being injected. Okay. So I'll remove this, I'll run this, and you'll see it runs. Now let us add one more scenario here. So let us say you have one more bean of the same class. Okay, I duplicate this statement. Now your bean names are same. Okay, if you run this, you can see we got such a big stack trace. Okay, so you cannot have one more bean with this particular name. Okay, so what I will do is I'll change this to 1 and I'll change the values also to 1. Okay. So if this bean is being picked up, we'll know the value will be printed as Toyota 1 and Corolla 1. Okay. So now if you run this, you should get Toyota and Corolla. Why? Because this is specification. If I make this as, if I make this as specification 1 over here. So let me rename this as specification 1. Okay. Specification 1 and specification 1. Okay. And let me run this now. What would happen? Okay, it's still picking so it did not make use of the second bean, and the reason is because I need to change the setter name as well. So it should be set specification 1, right? So if I run this, okay, you can see Toyota 1, Corolla 1. Okay, so what is happening is specification 1 has this particular setter and it has this particular class member, okay, which is being used over here in display details. So everything is specification 1, including the setter. So be sure to change the name of the setter as well. Okay, only then it will work. So you can see how this bean is now being picked up. Okay, so this validates our statement that when you say autowire by name, the name is being matched with the bean name. The name of the attribute that you have defined is being matched with the bean name, and whenever it finds the matching bean, it will make use of setter to initialize it. Okay, that is how autowiring works by name. So this is how this example will work. Okay, I'll now just revert, or I don't need to revert the XML. In fact, what I'll do is I'll just revert this particular part. Okay, so that it picks up the first bean itself. Okay. If I run this, it should work fine. Okay. So feel free to experiment more and understand this even more. Okay. How this is working. These things are really important and this will form the base going further. So now it's time that we talk about autowiring by type. Now, with autowiring by type, Spring will inject the bean based on its type. And if, let's say, you have two classes, and if one class depends on another class, then Spring will look for a bean that matches the type, and it will inject it into the class that needs it. Okay, let me demonstrate this. So we already have this car example, which is car in specification. So what I'll do is I'll copy these files straight away. Okay, I won't make code changes in this current files because we can refer it later then. I'll paste it in the Java folder and I'll paste it under I'll say example.autowire. I'll say type. Okay, since we are talking about type. Okay, so it won't be dot, it would be slash. Okay, it won't be dot, it would be slash. So just keep that in mind because you're copying it right now. And yeah, I'm done. I think I'll add this to my version control, which I have configured locally. Okay, so here you will see all the files coming over. Okay, autowiring by type. I also need to have a XML file in place. So I'll say autowire by name. Instead of name, I'll say type. Okay, so I just copied autowire by name and I pasted it at the same place. And it's asking me to create a copy and I just added type. Okay, there's a pop-up whether I want to add this file to my Git. I'll say add. Okay. So far so good. I'll just open all the files so that we can work on them. First thing, I'll make sure that I'm pointing to the right class in my Autowiring by type package. So I'll say type over here. Okay. I'll select type and then I'll change it across everywhere. Okay. Here as well. Okay. And here I'll then say, instead of name, I'll say like this. I'll say type, something like this. And yeah, we are done now. Okay. So what we need to do now over here, instead of by name, we need to say by type. So I'll say by over here and by type. Okay. Now what is happening is here we have two beans, right? And when you are saying by type, what Spring will do is it will go to car class. It will see, okay, it needs type of specification over here. And it will look up for the bean that is of type specification. And then it will inject that. Okay, it won't look for name and all. So here now the problem is we have two beans with specification. So there will be a confusion. So if I run this, okay, let me run this. If I run this, you'll see that we get a very long error. So you can see over here, error creating over here. No qualifying bean available of this particular type. Expected single matching bean but found two. Specification and specification 1. So it's clearly telling you that, hey, if I'm matching by type, I need a single bean of that particular type to be available. So for that, I need to comment this. Okay. And I'll run this again and now it should work without any hassles. Okay. So this is how autowiring by type works. So autowiring by type, always remember it looks for the type. And it also needs to find a single bean with that particular type. Name and all does not matter. So if I change this to specification 1, this is different from the class member name. If I run this, it will still give me the result. Okay, this was not true when I made use of type over here. Sorry, not type, but name over here. So if you say name over here, it won't work. Okay, it will give you null. That's the problem. Okay. So because name is not matching now, right? If you go over here, the name is not matching. It's specification 1. But the moment you say by type, so if I press Ctrl Z and if I change this to by type, and if I run this, you see it's working fine. So that's how autowiring by type works. Let us take a look at autowiring by constructor. So what I'm going to do is I'm going to duplicate the car class example over here. And I'm going to specify the path as com/example autowire and constructor. Okay. I'll add this to my version control and we have the files here. Okay. I also need to duplicate the XML so that I have it in place. Okay, constructor, something like this. Okay, so this is done. Okay, what I will do is I'll just open all the files that I need to work on. Okay, and I'll close this sidebar. So here now, first thing, I'll just make sure I point to the right package. Okay, so I'll make use of constructor everywhere, okay, because we are talking about autowire by constructor. And I also need to make sure I load the right XML. Okay, so I'll say constructor here. Okay, something like this. Yeah. So this is done. Now what we can do is we can run this and let us see the output. So you can see it runs right now, but we have not changed the autowire type. So I'll say, okay, if you take a look at the options, you have by name, by type, you have default as well as no. I'll specify constructor because we are talking about autowire by constructor. If I run this, I get null. Why I get null? Because I'm saying that I want to autowire by constructor, but I don't have a constructor within the car class. So if you go over here, I have a setter. Okay, I need to add a constructor. So using that constructor, the autowiring will be done. And this tells you that if you're trying to autowire by constructor, you need to have a constructor defined as well. And you can see over here, this works perfectly fine. Okay, setter actually is not needed in this case. Even if I comment this out, something like this, and if I run this, it will still work. You can see. So this is how auto wiring by Constructor works. Now, if I try to duplicate this or I don't need to duplicate, I will just uncomment this. If I simply uncomment this and if I try to run this, there are now 2 matching beans, right? So I can have specification here. Let me run this. You can see we get an error. Why we got an error? Because there are 2 matching beans, specification 1 and specification. So this also tells you that, hey, if you are like doing this sort of auto wiring by Constructor, you need to have only 1 matching bean. Okay. And if you run this again, it works. So this is how auto wiring by Constructor works. So let's begin talking about annotations in Java. So what are annotations? Now, annotations in Java provide a way to add metadata to your code. So it's a feature using which you specify some additional information about your code. And this additional information is known as metadata. Now, this metadata can be used by compiler, development tools, or any runtime environments, frameworks, libraries, and so on. Okay. So what are annotations? Simply put, you are telling more about the source code that you have written. Now, talking about history of annotations, I don't want to go into depth, but annotations were introduced as a feature in Java 5. So long back, and today they play a crucial role in modern Java development. Okay. So you can write some piece of code like classes, methods, variables. And then if you want to add some more information, or if you want to give some special instructions about what the code is and how they should be used, what they should do, then you can make use of annotations. Now, if this is a little bit confusing, then don't worry. Everything will be clear when we create and write our first annotation. Okay. So one point I would want to mention over here about annotation is that annotation is not the actual code that does the work. It is just some information that you are pointing out to whoever you want to, like framework or runtime environment and so on. Okay. You have already used annotation if you're coming from Java background. So if you're coming from Java background, you must have seen this annotation @override. Okay. So annotations start with @ symbol, and override is an annotation above the method to tell something to the Java compiler. So you are telling, by making use of this annotation, you are telling the Java compiler that, hey, I'm providing my own version of the method that is already defined in the parent class. And I know that this method exists in the superclass, but I want to do it my way in this class that I'm creating. And that is why you specify this override annotation. And this override annotation also helps you to make sure that you are actually overriding the method correctly. So if you make any mistake in the signature, you will immediately get an error that, hey, the signature does not match the one in the parent class. So here, override is not a piece of code. It's some information that you're specifying, like a metadata that you're specifying about the code that you are writing. Okay. Now in Spring, annotations are used extensively to simplify configuration and runtime behavior. Okay. So you will be using annotations a lot, and I'll talk about some of the commonly used Spring annotations. So for example, you have one annotation called component, and this annotation simply marks a Java class as a bean or a managed component. Okay. You also have something called as Autowired, using which Spring will auto-wire the dependency with the matching type. You have qualifier. So if there are multiple matching types, you can specify qualifier as to which bean should be matched over here. Value is used to inject property values into your beans. Repository is used to define the data repository. It's a specialized version of the component annotation that we see on the screen. You have service, which is also a specialization of component annotation, and it is used to indicate that this particular class is providing business services. Controller, it is used to create web controllers that will handle HTTP requests. You have request mapping. Okay. Then you have Spring Boot application. So these are the different annotations that exist in Spring. Okay. And we'll be making use of all of these annotations at some point in time. So if you're not clear of what this annotation means or what that annotation means, don't worry. We'll do everything hands-on. So for now, I just wanted to introduce you all to annotations and just give you a refresher. I hope you are clear on this concept. So now it's time that we talk about components and ComponentScan. So let's first begin talking about components. So what is a component? Now, component in Java refers to a class that is managed by Spring's IOC container. Now, Spring IOC container is Spring Inversion of Control container, and this is a container that manages the Spring beans. Okay, so components are building blocks of the Spring application, and they will have certain functionalities that they'll provide within the application that you're building. Now, you have been hearing about Bean all the time, right? And listening to component, you will be like confused. Okay, this is also managed by Spring IOC and Bean is also managed. So think of it this way, component is like a bean only, but it's specifically designed to be auto-detected and configured from class path scanning. Now, what does that mean? So scanning is something that you'll understand in some time. But for now, just understand that component is a special kind of a bean that is designed to be auto-detected. Okay. And it's a bean only. There is hardly any difference, but it will be auto-detected rather than we manually defining everything in the XML file, right? So that is what component is. Now, question is, how can you define components in Spring, right? You know how you can create beans, but how would you define components? So to create components, you will make use of XML, and you can even do so using annotation. So these are the two ways in which you can create components. Using XML, you can make use of this kind of a syntax, okay, where you are saying, I want to create a bean and this is a class, and this is something that we have done. But using annotations, you can make use of the component annotation just above the class definition or the declaration. And this particular annotation will mark the class as a Spring component. Okay, so this is how you simply mark a class as a component. And also make a note of the import statement at the top. This annotations you're getting from the org Spring Framework stereotype package. Now, what is component scanning? So component scanning is a feature that helps to automatically detect and register beans from predefined package. Okay, predefined package paths, I mean. So you will create components. All right. Now Spring needs to know where it needs to check for component and register itself. Okay. Because see, I told you that component is a bean that auto registers itself, right? Now, in order to tell Spring that, hey, I want you to scan this particular package specifically and look for all the components that I have declared over there and register them as a bean. So you need to explicitly tell Spring, and this explicit telling you can do with the help of component scanning. Okay. So it's a feature that helps you automatically detect and register bean from predefined package paths. Okay. And who will be defining these package paths? You will be defining as a developer. Okay. So you can enable component scanning in one of the packages, something like this. So you can say context component scan. You can make use of base package, and you can say base package is this. So within this particular package that you have specified, all the classes will be scanned along with the sub packages. So if there are classes in the sub package, they will also be scanned. Okay, everything will be scanned within this particular package, including sub packages, and they will be registered as beans. Okay, so this is about components and component scanning. I hope this was clear and useful. So now it's time that we start creating our own components and even understand how we can do component scanning. So what I'm going to do is in IntelliJ, I am going to head over and I'm going to create a new class. Okay. I'm going to create a class in, let's say, com.example.componentScan. Okay. And I'm going to name this class as employee, let's say. So we are taking a new example. Okay. It's asking me whether I want to add this file into Git. I'll say yes, I have it enabled. Okay. So I have this particular employee class. All right. Now what I would do is I'll have certain fields over here. So I'll say private integer employee ID, something like this. I can even have private instead of integer, I'll have string. I can say first name. Okay. Then I'll have last name. Okay. And then I can have salary. So what I will say is private and double, I'll say salary. Okay. Now what I want to do is I want to register this particular class as a bean. Okay. So one way is I have the XML definition. Okay. Like we have always done here in the resources folder. So let me also get an XML file. Okay. So let us call this XML something. Okay. So what I'm going to do is I'll call this as ComponentScan. So since we are talking about components, something like this. Okay. ComponentScan demo. Okay. And here we have defined bean this way. Okay. So whenever we define it this way, what happens is the bean is registered with this name, but I'm going to skip this particular definition here. Okay. I'll just comment this out. Done. And now what I can do over here is I can say, and now what I can do over here is after commenting, I can come back to employee and I can register this as component. So you can say component, you can see the suggestion, it's from org Spring Framework stereotype. So I'll get this. Okay. And we are done. Yeah, this is our bean here. And now what I can do is I can even add some getters and setters. So let me add some getters and setters over here. So I'll say getter and setter. We'll get getter and setter for all. And then in the end, I'll also get a toString over here. Okay. So let us overwrite toString. Okay. So we are done with this particular class. We have a component being registered. Now what I can do is let me create app.java here. Okay. All right. So this is app and this is going to have a main method. So we need a way to call our class that we have created. Okay. And I can just get the code from elsewhere. So let me open this app and let me copy this. Okay. And I'll come over here. I'll just paste it over here. Okay. So this is done. Now over here, we need to update this. So instead of Autowire by XML, okay, I can say component scan demo.xml. Okay, this is done. And over here, I need to get the employee. So I can say employee is equal to new. Sorry, not new. I have to say context.getBean. I can say employee like this. Okay. And we are done. I will have to add a semicolon. I need to cast it. So either I can cast it over here or I can even specify one more parameter. Okay. Employee.class. So this will also work if you don't want to do casting. You can just specify the class like this. And I can say employee dot toString. Okay. Something like this. Okay. All right. So this needs to go into system.out.println and I need to move this line here. Okay. We are done. Let us try running this and let us see what happens. Okay. All right. So I get an error. Makes sense. A silly syntax error that I made. Okay. All right. I get an error. Okay. So we are getting an error. It says no bean employee available. Okay. So this is interesting. And this is helping us understand the importance of component scan. So you saw that I defined the ComponentScan demo.xml. Okay. But I commented out the bean definition. I have added component over here. So this is a bean that needs to get registered. Okay. But I need to tell Spring which packages it needs to look out for. Okay. And depending on what I specify over here, it is going to scan those packages for all the component definition. So I need to tell over here context colon. Okay. I need to say, so right now I'm adding context and it's not working because I realized like this particular XMLNS. So this does not have context. So what you can do is you can Google for component scan XML here, something like this. Scroll down to the official Spring documentation. Here, if you scroll down a bit, you will see a XML format here. Okay. So this is how you can specify the component scanning. Okay. And here you can see this context is being added over here. Okay, this is what we want. So what I would do is I can copy this entirely here. Okay, and rest all we have. Okay, so I'll come over here, I'll paste this, and here you can see this syntax: context colon ComponentScan, and you have to specify base package. Now what is our base package? So base package is com.example.ComponentScan. Okay, so this is it. This is a package, right? We want everything to be scanned within this particular package, right? So this is the package. And what we are telling Spring is, hey, look for all the components within this package. So what Spring will do is it will start searching for all the components, and it will find this one, and it will register this as a bean. And let us see if this is true. So you can see this works absolutely fine. There are no issues as such. Okay. Of course, we are not initializing the values right now, which we'll be doing in some time. But over here, we are getting null, and all the default values. Like for integer, we are getting 0, and for double, we are getting 0.0, which is okay. But the point I'm trying to make over here is we have literally just added one annotation here. Just see the process. One annotation. Okay. And we have instructed Spring that, hey, scan these packages for components. Okay. Now, one more thing I would want to mention is here with this annotation, you can even specify the name with which you want this to be registered. Okay. So if I say employee, it will work. Okay. Why? Because we are fetching employee over here. Okay. And by default, what it will do is it will take the class name and it will remove this capital letter and it will convert it into small case and register it with that name. Okay. So by default also it's getting registered with the name employee. But if I add employee 1 and if I run this, it's not going to work. You can see no beaned name employee available. All right. You can see. And if you change this to employee 1, only then it will work in this case. You can see. So if you want to have any sort of custom name, you can of course do it with the help of this kind of like mention over here. Okay. So that's about the component and component scan. I hope this was useful and I hope you have some clarity as to how these things work. So we have been able to create component and we have been able to scan the component with the help of this XML. Now the thing is, whenever we run, we are not seeing any values. Now how do we inject any value into our properties that exist within the component? And if you want to do this with the help of annotation, the answer to your question is the value annotation. Okay, so here you can make use of value. You can see this annotation appear from org Spring Framework Beans Factory Annotation. Okay. And here it allows you to specify any value that you want to have. So this will be the default value. So I can say hello, for example, and I can run this. You can see hello is being initialized instead of null over here. Now you can do a lot more. Instead of just adding a string over here, you can add any sort of string. Okay. If you want to, you can add any sort of value, but if you want to have a system property, for example, so you can add that as well. So you can like copy this. Okay. So let's say I want to add my Java path. Okay. So you can say something like this, java.home. Okay. Now this will assign the system property into last name over here. You can see last name. This is my Java path home. Okay. And you can inject values like this. Okay. If you want to inject a expression, you can make use of something like this. You can say value, and within value, you can say hash, and you can specify any sort of expression. So 4 into 4, something like this. And wait a minute, let me align this a bit. Okay, so it's okay. So you can see if you run this, you should see 16 into salary. So it's a computed value that is coming in from here. So you can make use of value annotation, okay, to inject values into beans, and this can help you a lot with some initial values. Okay, I hope you're clear with the value annotation and I hope this was useful. So now it's time for us to transition from XML to annotations completely. Okay. So far, we have been making use of XML over here. Okay. So we have this XML file where we are telling Spring as to where it should scan for components. So this is the XML file. Okay. Here we are telling Spring that, hey, you need to scan for packages over here. Okay. And we need to get rid of this XML now and move to completely annotation based process. Okay. So what I'm going to do is we are going to come over here, and just to let you know, I've already created a new package com.example.componentscan.annotation, and I've duplicated the class over there. Okay. So that the earlier changes are intact and we don't touch them. Okay. So we'll be playing in this particular package now. What am I going to do is I am going to have the configuration provided via a class instead of an XML. Okay. So here we are providing the configuration from an XML. We'll create a class. Okay. Let me create a class over here, and we'll call that class as app_config. Okay. So I'll say app_config. Okay. This is a class created, and this will be the configuration class. So this class won't have any methods of field, because the purpose of this class is just to have the configuration. And how are we providing configuration? We are providing configuration using annotations. So I'm going to say @. You can see the number of annotations that appear, a lot of annotations. Now you can slowly type component and you will see ComponentScan over here. Just pick this up. Okay. Within bracket, you can specify a lot of things. So the moment you add bracket, you can see there are so many things, value, base packages, and so on. So we'll go for base. Okay. And I'll say base packages. Okay. How to get rid of this? This pop-up is not going. Okay. So it will be base packages, something like this. Okay. And here I'm going to say car.example.componentscan.annotation. So this is a new package that I've created. Okay. Which has the file. Right. So we have defined the annotation. Now what we need to do is we need to tell Spring that, hey, you need to refer to this class for all the configuration, and that we have to specify using configuration annotation. Okay. So this is one more annotation that enables you to specify that, hey, this class is a configuration class and you can load the configurations from here. Okay. So you can see we are adding 2 annotations over here, which is perfectly valid. And now we don't need this ComponentScan demo.xml. Okay. So I'll just close this. And what we are going to do is we are going to not make use of ComponentScan demo.xml. Okay. So we are going to update this thing over here. So I'll tell you how we are going to update now. Okay. Now the thing is, we made use of class path XML application context to get the type of context over here, which is of type application context. Now application context over here is an interface, as you can see, and it has different implementations. One of the implementation is class path XML application context, which allows you to load the configuration from the XML. But if you want to load the annotation based configuration, you have to make use of annotation. You can see config application context. Okay. And then here you need to specify the class. Okay. I'm going to get rid of this and I'm going to say app config dot class. We are done. Okay. And let us try running this, whether it runs fine. Okay. So we get an error. So the error says there is no bean named employee available. Okay. There must be some mistake that we are doing. We are trying to get employee properly. We are loading the app config properly. Let's come to app config. So here the package is com example, and here we have mentioned car example. Okay. This is a mistake. So make sure you add your packages correctly. I had by mistakenly put up car over here. It's com.example componentscan.annotation. Run this. So whenever you get bean not found or something like this, just check the package names and just check what is referring to where. Okay. So if you just take a look around, there might be some typo or mistake that you must have done. So even if you're typing this, I would recommend copying and not typing. So you have to just copy package from here and paste it. Okay. Don't type it. because you might make some mistakes like typos or something like that, and then you might get error and you might wonder why you're getting that. Okay, so just be careful about that. But as you can see over here, you can now see that we are making use of appconfig.java, which is annotation based configuration. Okay, and we are not making use of XML based configuration that we had earlier. So we have transitioned completely from XML to annotations, and you can see that over here. How did we do it? We did that with the help of this configuration class, which is appconfig, and we did that with the help of a implementation of application context, which is annotation config application context. Okay, so that's about how you can transition and eliminate XML completely. Welcome, and let us begin talking about Autowired Annotation, and let us understand why is it needed. So I'll just open up this particular project over here, okay, that we were working on. I'm going to need these classes like appconfig, and even the employee. So I'm going to copy these classes. I'm not going to make any changes over here, and I'm going to paste them in the root Java folder. And I won't be pasting them exactly in the root, but I'm going to paste it in /com and then /example and autowired /annotation. So we are talking about autowired annotation. Just make sure you don't conflict with autowire.constructor, autowire.name. Okay, I'll just say okay, and I'll say add, and you should have the classes over here. Okay, I'll close everything else and I'll just open these files. Okay, I'll close the sidebar. Now, what is Autowired Annotation? So Autowired Annotation is a kind of annotation that allows you to signify automatic dependency injection. Okay, so whenever you make use of this annotation, you are telling Spring to automatically inject dependencies into your Spring managed beans. Okay, so let me give you an example. So let us say there are two classes that are dependent on each other. So over here, we just have employee. Okay, we don't have a class that is dependent on employee or any class that employee is dependent on. Okay, what I will do is I'll add a new class over here. Okay, so let's say we have a manager, manager.java, simple. And what I'm going to do is I'm going to have employee over here. Okay, and I'm going to create a dependency employee, something like this. Okay, so I have this dependency. Now I want this dependency to be injected automatically. Okay, so what I can do is I have, let's say, let me add a constructor. So I have a constructor here, which is of type employee. Okay, what I can do is I can come over here, I can say autowired. You can see this autowired dependency being, autowired annotation being added. Okay, so you will add this over here and you can see it being imported and it being added over here. Okay, now what will happen is Spring will take a look at what this particular class needs. So it needs employee. So what it will do is it will automatically inject the bean of type employee. So if it has a bean that it is managing of type employee, okay, then it will automatically inject that. Okay, so this is what Autowired is going to do for you. Okay, and we can even have, let me generate toString for this. Okay, so I'm just generating toString for manager, and what I'm going to do is here I can simply print in the manager information as well. Okay, so let me do one thing. Let me also register manager as the component. So what I'll do, I'll come over here. I'll say component. Okay, this is a component. We come into app, and here we are getting the employee, which is good. I'll also get a manager. So manager is equal to, not new, context dot get bean. I'll say manager, comma, manager dot class. Okay, and here instead of employee dot toString, I can have manager dot toString. Let us run and see. Okay, we accidentally ran a wrong class, so we need to run this one from here. Okay. So we get an error. Okay. So bean name employee is expected. Okay. So one issue is we copied the source code here. Okay. 1 second. So we copied the source code from here, but we did not change the class name. So it has to be this class name. Sorry, not this class name. This is package name. I'm sorry. So we have to replace the package name here and then run it. And it should work absolutely fine. As you can see, like this is the employee and this employee itself is a manager. And this is a dependency that is being injected with the help of this Autowired annotation. You can see how magical this was. You just specified one annotation. You're telling Spring Boot, sorry, not Spring Boot. You're telling Spring Framework that, hey, Autowire the dependency here. And what Spring is doing is it's so smart that it will simply get the bean of that particular type and it will just inject it. Now, this kind of injection, you are making use of Constructor injection over here. Okay. So one question that you like student always ask me, okay, and you might also have, do you need a constructor over here? Okay. So the answer is you can remove the constructor. Okay. Let me remove and show it to you. So what I'll do is I'll just comment this out. Let's say we don't want constructor. Now the question is, if you run this, you'll get null over here. Okay. This won't have any value. You can see manager is null, but you can do things without constructor, which means you can specify this annotation even above the field. And if you run this, you'll see it's injected now, right? So what is happening over here is this was doing constructor injection and this is doing field injection. Okay. So you can even inject fields. So field injection is normally used when you have lots of fields that you want to be injected, right? And you want to do, you don't want to have a constructor, but you want to do it with the help of field injection. And it will reduce the boilerplate code and it will make your class look a little bit cleaner and concise. Okay. But normally constructor injection is what is recommended. Okay. Because it gives clarity as to what is being injected, where, and it helps, right? So normally constructor injection is preferred over that of the field injection as per the best practices. Okay. But as you can see, Autowired annotation is really helpful and you can see your beans being injected automatically with the help of, or I should say by Spring IOC container. Isn't this useful? So yes, it is. Okay. For me, it's really useful. So I hope this lecture was useful for you all and I hope you enjoyed learning about Autowired annotation. So in this particular video, I want to talk about qualifier annotation. So let me give you a scenario. You're working in a large project and normally in a large project, what would happen is you can have multiple beans created of the same type. Okay. Now, whenever you have multiple beans of the same type, let's say in our case, if you have multiple beans registered in Spring container with the same type employee, okay, then what would happen is if you make use of Autowired, Spring container is going to be a little bit confused and it might throw an error that, hey, there are two beans registered of type employee, which one you want to consider. So in that particular case, you have the liberty of making use of qualifier and also specifying the name of the bean. So here you can specify employee. So I want this, I want the type this with name this to be injected over here. And if I run this, okay, you should see the output normally. And if I change this to something else, you're going to get error. Okay. You can see no qualifying bean of this type available, right? So since we have given a name which does not exist, that is why we got this error. But qualifier is normally used if you have multiple beans registered with the same type, but different names. So in that case, you can make use of qualifier. I hope you're clear about what qualifier is and how you can make use of it. So it's time that we evaluate our progress and do a quick review as to what we have learned so far. So we started our journey by understanding the basics of web development. We understood what web is, what are web framework, how web works, and so on. Okay. Then we spoke about Spring Framework and we understood how Spring emerges as a powerful tool that can help us build robust Java applications. Okay. We discussed the need of Spring in modern Java development and how it addresses the challenges that are normally faced when building complex applications. And during this process, we understood concepts such as coupling. We understood what is tight coupling, loose coupling, and so on. We also spoke about configuration and we understood how with the help of Spring you can provide configurations. We spoke about concepts such as dependency injection and inversion of control, which is IOC. Okay. We also spoke about how you can make use of XML and annotations to provide configurations and configure different components as well. Okay. So this was a journey so far and we have come very far in this. Now it's time that we talk about a few things. So first thing that we understood over here with Spring Framework is that you need to do explicit bean configuration. Okay. Yes, explicit bean configuration is needed wherein you need to manually configure your beans, whether it's through XML file or annotations. Okay. Of course, you can do away with XML file. In XML file, you need to add the bean tag and all. But with component scaling, the configuration reduces a bit, wherein you just have to specify the location as to where the scanning needs to be done to get the component. But still, there is some configuration involved, right? You are actually doing it explicitly, right? Now, this can be verbose and complex for large applications, right? There is no embedded server so far in our application. Okay. So our application does not include an embedded server. So tomorrow, like if you want to deploy it on a local server and test it as to how your application is running or responding on server like Tomcat or Jetty, it can take a few steps that you need to do manually to set up the deployment, right, on a local server. Okay. So this is one thing. Another thing is component scanning. So like I said, you need to do explicit configuration to enable component scaling. And this can be cumbersome because if you have lots of packages and if the components grow in numbers in your application, you might make errors or mistakes. Okay. Boilerplate code. Okay. So we need to write boilerplate code still in our application to set up basic configurations. Okay. Like if you need to do a database setup, we will have to do some configuration over there. Okay. You will have to write code to authenticate your users. So authentication is very normal when it comes to Spring Boot. Okay. And if you want to authenticate your users, so authentication is very normal in today's web development. Okay. Every website that you see has authentication. Every website has security. Now, these are all standard features, right? Every web application needs them. Every web application needs a database, okay? But if you need to create a web application using Spring, you need to configure all of this manually, okay? So there is a lot of boilerplate code involved to implement security, to implement authentication, to implement standard things like database, okay? So that's what I mean by boilerplate code. So this is the review so far, and we'll understand how Spring Boot comes into picture and how it takes away all these hassles and how it simplifies the development of web applications in an easier, faster, and more efficient way. All right. So I hope this was useful. Let's start talking about what is Spring Boot. So Spring Boot by definition is an open source Java-based web framework which is used to create standalone production grade applications which are built on top of Spring and Java. So it's a Spring based web framework, okay, and it runs on Java. And also one thing to note over here that it's open source and freely available. Now, what is the benefit of using Spring Boot? Like, why would you use Spring Boot over Spring? And what is the advantage that Spring Boot gives you? So, here's the difference between Spring and Spring Boot. So, with Spring, there were lots of things that were involved in setting up, configuring, writing boilerplate code, and also deployment of the app. Okay. So of course, when it came to building apps before Spring, like before Spring was invented or created, there was lot of boilerplate code, and Spring reduced that to a lot more extent. Okay, so a lot of boilerplate code was eliminated with the help of Spring. But with Spring Boot, the boilerplate code was further eliminated. Okay, so with Spring Framework, you had a lot of things available readily, but still there was some configuration to be done. There were a lot of steps that were involved in setting up and also in the deployment of the app. For example, if you're building an application, a web-based application, you're building it on your local machine first, right? Because that is a development environment. Now, to test your application, you need to have a local server running on your system. So with Spring, you had to set up a local server wherein you deploy that app and you configure the app that you're building with that particular server. And you had to do this for every application you build. Of course, a lot of things were automated and pre-configured, but yes, there were some things that were left out. And that is where Spring Boot came in. So Spring Boot offered a set of pre-configured components and defaults, and it eliminated the need for a lot of boilerplate code that was involved in setting up a Spring application. It went a step further. So you can think of this as, so analogy that I can give you over here is of a Maggie. Okay, so if you're building or if you're cooking Maggie, let's say, okay, and how do you cook a Maggie? Like you have a sachet with a pack of noodles and you just put it in hot boiling water, you boil it for 2 minutes and you're done. So that is pre-configuration. Okay, it's pre-configured. So you didn't have to do anything. You just had to get a pot of hot boiling water and you had to tear the packet and empty the noodles into the boiling water, and that is it. You're done. So the packet had a lot inside, so it was pre-configured, okay, to be cooked this way. All right. So it reduced the effort at your end and you could enjoy your meal quickly. Okay. So this is one analogy that I could give you when it comes to Spring Boot. Spring Boot operates in a similar way. So you just get the source code, you create the Spring Boot application, okay, and you can run it with a single click. It's that fast. Okay. It's ready to be built. Okay. So you can think of Spring Boot as Spring Framework plus a lot of pre-built configuration plus embedded server. Okay. So Spring Boot is equal to, you have Spring Framework, pre-built configuration and embedded server. So for running the application, like I said, you need a server. Okay. And Spring Boot has that pre-configured, okay, and embedded within it. So when you create a Spring Boot project, you don't have to set up a server where you would be testing your application and running locally. It's all embedded. You have to just create the project, okay, write some source code for your application and run it, and it will run on the embedded server. Okay. Also, there is a lot of pre-configuration that goes, which we will talk about. Okay. So this is Spring Boot, okay, and it eliminates the need for a lot of boilerplate code like I mentioned right now. It levels up essentially the development that you are doing with Java and Spring. Okay, so if you're using Spring Boot, you are much more faster. You get to focus a lot on business logic rather than doing these daily tasks like embedded servers, and these are all manual things which can be taken care of. You as a developer can focus on the business logic, which is really, really important. Let's now talk about the components of Spring Boot. So the number one component is Spring Boot starters. So what are these Spring Boot starters? So these are a set of convenient dependencies, okay, that can be included into your application. Okay, like you can say these are ready to use ingredients. Okay, so for example, if you're building a web project or if you're building a REST API, you know you will need to create some REST endpoints. Okay, and for that you have a starter. If you're building a web application, you have a web starter, which signals that you're building a web application and all the configuration that is related to a web project is pre-configured and included. Okay, if you're building a database driven app, you have a starter for that. So whatever is needed for a web application that interacts with the database is pre-configured into that. So you have to just include that and it's done. So this is what Spring Boot starters are. It's a library or a shop, you can say, which has a lot of components ready to be included into your Spring Boot project to accelerate your development. The next step or the next component is auto configuration. Now, Spring Boot auto configuration attempts or it configures automatically your Spring application based on the dependencies that you have added. So if you have added, let's say, a dependency for database, so all the configuration that is needed for database is automatically taken care of. So Spring Boot determines that, hey, this particular application has database related dependencies. So guess what? It's going to use database. So I need to configure things that are needed for database, and it will take care of that. You don't need to do manually. Okay, you just need to set some properties like username, password, or the host where it can find the database and so on. But they are very minimal, and Spring Boot does the heavy lifting over here. So that's auto configuration. So based on like whatever dependencies that you have added in your application, it configures or auto configures things for you. Okay, you don't have to deal with the configuration manually. So this reduces a lot of hassle. Then you have Spring Boot Actuator. Okay, now this is one of the non-functional features. So if you're building a Spring Boot application, you would need a way to monitor that application. You would need to gather some metrics like how many requests are coming, is the application up and running. So all these kind of monitoring things, these won't be the requirements that your client is going to tell you. Nobody is going to tell you these requirements. From the developer standpoint, these are needed for you. Okay. So Spring Boot provides Spring Boot Actuator, which you can add to your project, and it will enable the production ready features like monitoring your application, metrics gathering, tracing your HTTP request, and so on. Okay. So that's Actuator. Then you have Embedded Server. So Spring Boot includes an embedded server like Apache, Tomcat, Jetty, and it allows you to run your application as a executable standalone jar file. Okay, and this eliminates the need of you deploying your application on a separate server and testing it. Okay, so it simplifies the process. Then you have Spring Boot DevTools. So DevTools is a set of development tool that enhance the productivity during application development. So for example, if you make some changes, you might want a automatic application restart or redeployment, like live reload of static resources and so on. You might need some better logging or enhanced logging for faster development. So all of this is provided by Spring Boot DevTools, and you can include it into your project. Let us talk about the advantages of Spring Boot. So number one advantage is it's standalone. Now what I mean by standalone is it can be started using a command java-jar, and it does not need to be deployed on a separate web server. Okay, and it allows you to get quickly started, offering rapid application development. Okay, then it provides you with starter code. Okay, now like we discussed, starter projects enable you to get started quickly. It takes care of configuration and dependencies that are predefined, okay, and that are needed for every web application. It needs less configuration, okay, which means like since the configuration is taken care of by Spring Boot itself, there is very less need or no need to do configurations manually. And because of all this, it enables a company to reduce the cost and the application development time, and it helps them to go to market really faster. All right. So these are some of the advantages, and because of these advantages, a lot of developers love Spring Boot. And some of the reasons are it's Java based, which is one of the most popular programming languages out there, and it's fast and easy. Yes, it enables faster development and it's easy to use. Comes with an embedded server. It has various plugins, and a lot of boilerplate code and configuration is avoided. All right. So that's Spring Boot for you. Thank you. let's talk about Spring Boot architecture. So Spring Boot has a layered architecture wherein one layer will communicate with the other layer. And there are a few layers or a few tiers that exist in a typical Spring Boot web application. Following are the different tiers. We have presentation layer, we have service layer, and then we have data access layer. Let's talk about each one of them individually. So what is presentation layer? So presentation layer presents the data and the application features to the user. This is like the front end view, and this layer is the layer wherein all the controller classes exist. Okay, so what does controllers do? So controller accepts the request from the user, validates the inputs that the user has given, and passes it to the next layer, which is the service layer. So like I said, presentation layer does the job of presenting data and information to the user. Then we have the service layer, wherein the business logic resides in the application. Now, things such as evaluations, decision making, processing of data, all of this is done at this particular layer. This layer also does the job of interacting with both presentation and the data access layer. So this layer sits in between and does the job of communicating with both the layers, and they are frequently being called by presentation layer, and they will call the data access layer frequently. Now, what is data access layer? So data access layer is a layer where all the repository classes reside, and these repository classes are responsible for interacting with the databases, like performing the operations to read, retrieve, save data. And underlying databases can be any database, like it can be relational database or like NoSQL databases, but it is a job of data access layer to access the data and interact with the database lying under it. Okay, so this is how a typical Spring Boot architecture looks like. So these are the three different layers in which the application exists. Now let us take an example. Let's say we are building a library management system. So we will have a browser from where the user will be interacting with the application, since it's a web-based application. So this is our application, and user will be sending a request, and that request will be handled or received by the controller. Okay, so user interacts with the controller. Controller, it will take a look at the request and it will forward it to the service layer. Now, service layer classes interact with the repository classes, and repository in turn interact with the database. Now, service layer is the layer that will be responsible for all the logic that is related to our business, which is a business logic. So that will reside in the service layer. Controller and repository will do the job of interacting with the user and interacting with the database respectively. Then once the data has been fetched from the database by the repository layer, okay, what repository layer will do is it will pass the data to the service, and eventually the data will flow to controller and user will see it in his or her browser. So this is a flow in which a typical Spring Boot application works. The request comes through the controller from the user, then service, repository, and then it travels reverse back to the controller. All right. So this is a typical architecture of a Spring Boot application. So that's about this class. I shall see you all soon. Thank you. So let us start talking about Spring Initializer and create a Spring Boot project. So what is Spring Initializer? So I'm here on this website, start.spring.io. Now, this is a website for Spring Initializer, which is a tool that enables you to generate or create a Spring Boot project. So if you're using free version of IntelliJ IDEA, which is the community version, that particular version does not have the ability to create a Spring Boot project. Okay, so you can create a Spring Boot project using IntelliJ if you're using the professional version of IntelliJ. But for free version, it does not have that ability. So for that, you need to make use of a free tool which is openly available over here on start.spring.io. Now this particular website asks few questions about your Spring Boot project, and when you hit generate, it will generate the complete project structure which you can then import in your IntelliJ IDEA. Okay, and you can start coding over there. So this is a really handy website. You should bookmark this website because you will need this website every now and then if you are working consistently with Spring Boot, and provided you don't have the professional version of IntelliJ. So what I would say is you should head over to this website, Spring Initializer, which is here, start.spring.io. You need to select the project. So here it will ask you a few questions like, what sort of project are you creating? So I'm creating a Maven project. So these are different build tools that exist. So I'll use Maven for proceeding with this project. Okay, you can use Gradle if you wish to, but I'll choose Maven. Now language, of course, will keep Java selected. And here it is asking you for the Spring Boot version. So here there are different versions of Spring Boot that are available. Okay, and you can choose any one of them. Now here you will see some versions that are labeled as snapshot over here. So you can see 3.2.0 snapshot. Okay. Now using the snapshot version of Spring Boot is generally not recommended for production environments. And the reason is snapshot means pre-release versions. Okay. Which means that these are still under development and they have been opened up for preview. And they might be incomplete, they might have bugs and other issues. Okay, so they are intended for testing development purposes if you wish to try out some new versions of Spring Boot. Okay, but snapshot version is generally not recommended. So I'll be selecting this version, which is a non-snapshot version. You have other version too, which is 3.0.8, but I'll choose the latest one. Now, another thing is when you see this lecture or this website, when you visit this, you might see a different version, like different numbers over here. Okay. Now that is perfectly fine. You can choose whichever is latest available because these versions keeps on changing as Spring Boot keeps on pushing new versions out there. Okay. So don't worry about the changing version numbers over here. Okay. So you can select the Spring Boot version starting with 3. Now 3 indicates you're using Spring Boot 3 version. Okay, so just make sure you're selecting the version that starts with 3. Okay, so once you've selected the version, here this particular tool will ask you for some project related information. Okay, now it's asking you for group. Now what is group? So group is nothing but the package name of the project. Okay, and this is usually the reverse of the domain name. So the default one here is com.example. So I'll say com.embarkx. Okay. So this is a website that I have. And then you have artifact. Now artifact is nothing but the name of the project. So the project name I can say as first spring here. Okay. You can enter any name that you wish to. Okay. So this artifact name and this name will also get updated over here. Okay. Now description is the description of the project. So you can say first project for Spring Boot. Okay, and you can see the complete package name over here. Okay, so this package name is automatically generated based on the information that you have given over here. Okay, so this is about the project metadata. Now there are a couple of fields more that have been pending. So here you can see packaging. So applications can be packaged as jar file or war file. So I'll keep jar as selected. Okay. And here it's asking you which version of Java you wish to use. So I'll keep Java 17 version selected, which is the long-term support version or the LTS version that is available. If you have some other version of Java that you wish to use, you can change it over here. That is perfectly fine. Okay. So this is about the configuration over here, the project configuration. Now on the right hand side, you see the dependencies. All right. Now if you click on add, you will see some dependencies that exist. Okay. So you can see like Spring Boot DevTools, Lombok, Spring Boot Web. So if you're building a web application, you need to select the Spring Web, and what this will do is this will include everything like RESTful applications, like things needed for Spring MVC and an Apache Tomcat, as well as the embedded container inside. So whatever is needed for you to build a web application, all of that will be included if you select this particular part. So you can scroll through and take a look at different dependencies that exist over here. So there are different categorizations, like you have web, then here you have developer tools, then here you can see template engines. This is Timeleaf. Okay, so if you are like writing some Java templates which are server side and you want to display HTML into the browser, so you can use Timeleaf. So the dependency will be included. You have security related aspects and so on. So you can scroll through, you can see JDBC. Okay, so if you select this and this, like everything related to the database will be configured. Okay, and you can take a look at the different kinds of databases that you can use over here. Okay, you can see MySQL driver, PostgreSQL, Oracle, and so on. Okay, you have NoSQL options as well, which is MongoDB, Redis, and so on. Okay, so there is a lot. You can just go through this list. Okay, so this is about the dependencies. So what we are going to do is we are going to search for web, since we are building the web application. Okay, now if you scroll up, this is what will be added. Okay, Spring Web here. Okay, and then you can click on Explore. So if you click on Explore, it will show you the project files that it will be creating for you. Okay, so you can take a look at the structure here. You can see pom.xml. You can see this is the entire structure. You can just take a look. Okay, so you can either copy, download, or I'll say close over here. Okay, and also one more thing I wanted to talk about is, so not this one, but this one over here. So this is a mode, like if you prefer a different mode. Okay, this is like, I don't know if it's useful for you, but you can, like, if you wish to have a dark mode, you can use this. All right. Then after doing this, you need to hit generate. So when you say generate, this entire project structure will get downloaded onto your system. So just hit generate and save this particular file on a particular location wherein you will be creating the Spring Boot project. All right. So that's about Spring Initializer for you. So just make sure you have downloaded the project structure over here from the Spring Initializer website and you have saved it to the desired location. So I have saved the file over here at this location of my choice. Now what I'm going to do is I am going to unzip it over here. So I'm going to say extract here, and this is going to extract and give me all the files within this particular zip file in this particular folder called First Spring. And this is what my project name was. Now we need to start using this project into IntelliJ. And for that, we need to import this project into IntelliJ. So what I need to do is I need to head over to IntelliJ. So when you open IntelliJ for the first time, you will see this welcome screen. And if you have created any projects earlier, you should see a list of recent projects over here. So you can say open over here. So I'll click on open. You can navigate to the location of your choice where you have this project saved. So I have this project saved over here. You can see First Spring. I'll select this. I'll say OK. Now it will ask you whether you trust this particular project, because what is going to happen is IntelliJ is going to run the source code that exists in this particular folder when importing. So it's asking you if you trust this particular project and whether it has been downloaded from the valid source. So yes, we trust this project. So I'm going to say trust projects in courses Spring Boot. So I'll trust all the projects that I have over here and I import in future. Okay. Alternatively, you can preview in safe mode if you don't trust it, but I'll say trust the project. And what is going to happen is it is going to open this particular window here. Okay. And it is going to load the entire project. So here I see a welcome screen where it's welcoming me to IntelliJ's new version 2023. Okay. it's giving me some tour over here. Okay. And here it also has some tutorial, like on the right side, some customizations. And here there is some processing that is happening, you can see. So it's updating this particular repository. So it is fetching, in short, all the dependencies. So if you click on this, it will say updating Maven dependencies. So I'll tell you what this means in a while, but what happened here is we had specified all the dependencies when we created the project. Like we specified web, Spring Web, and you can see the dependency here. So this was the dependency that we specified. Now to get this dependency onto your project, there has to be some download that needs to happen. And that is what the download that was happening here at the bottom. Now you have some customization options over here, like you can customize it to dark mode. Okay. So, okay, so Windows is blocking some features over here. So I'll say allow. I trust IntelliJ. Okay, so you can change it to dark mode. Dark mode is brilliant. You can keep the system mode. Okay. You have an option to have a compact design or a clean one. You can choose whatever you want. I'll keep this to light mode. Okay. And I'll just say finish setup. Now you have some updates over here, okay, as to what's new in IntelliJ 2023. So you can go through this, okay. But let's explore the project structure over here, okay. So you can see the entire project structure on the left-hand side over here, okay. Now you can see some folder, like you can see the SRC folder. So this is a folder where your source code resides, okay. So you have main. And under main, you have the Java folder. So this is a folder where you can see like all your Java files coming up. Okay. And you will have this folder here, this file here, which is the application file. This is by default created. Okay. And you have this package name, which you had specified on the Spring Initializer website. Okay. So this is the Java source code. This is where all your Java source code will reside. Now, if you expand resources, you will see static folder and templates folder and a properties folder. So resources folder is where all your HTML or like user-facing code will reside. Okay. Then you have something called as test, and here is where all your test cases will come. Okay. So you can define test cases under this test folder. And then you have pom.xml. So you can see this pom.xml. This is one of the important files when it comes to Spring Boot. And within this file, it's an XML file. And within this file, all the dependencies of your Spring Boot project have been specified. So you can see all the configuration things over here. So you can see this is Spring Boot version that we chose on the Spring Initializer. Okay. This is the group ID, the artifact, the name of the project, the description, which version of Java we are using, and the dependency that we had selected. So this is a starter web. So when we said Spring Web on Spring Initializer website, this is the dependency that was added. And it's a starter project, as you can see. And what is starter project? So it has a lot of pre-built configuration for a specific purpose. So since we have specified the purpose as web, so everything that is needed for a web application is included in this dependency. Okay. Now you also have over here on the left hand side a folder, which is a huge folder, and the folder says external libraries. Now this is a folder which has all the libraries that are needed for the project. Okay. And if you scroll through, you can take a look at the different libraries that exist. Okay. So this is about the project structure. Now let us talk about this file over here, which is first Spring application. Okay, so this file has some source code in it. All right. And you can notice this annotation over here, which starts with the @ sign. Now, what does this annotation mean? Okay. So this annotation specifies that this particular application is a Spring Boot application. Okay. Now, if you go to this class which defines this annotation, so if I press and hold Control on Windows, or if you're on Mac, you can hold Command. And if you hover mouse on this, you'll see it being converted into link. And if you click on this, you will see that it's an interface. Okay. And this is a class. And you will also notice that this class has 3 more annotations. Okay. Which is a Spring Boot configuration. So this is one of the annotations. Then you have enable auto configuration, and then you have ComponentScan. Okay. So Spring Boot configuration tells that this is a configuration file. Enable auto configuration tells that you need to enable auto configuration for this particular project, wherein the configuration should be done automatically. And then you have ComponentScan, which allows you to scan for packages that exist. All right. Okay. So these are the 3 main annotations within Spring Boot application. And that is what we have specified outside over here. So I'll close all of these class files here. Okay. Now, if you go to pom.xml over here, okay, if you scroll up, you will see this Spring Boot starter parent. Now, this is one of the projects that is by default included in our application. And this particular project provides the default configuration for our application. Okay. And it inherits the dependency management from Spring Boot dependencies. All right. So that's all we need to know about this boilerplate code that has been generated by the Spring Initializer website. All right. So that's about this class. I shall see you all soon. Thank you. Let us talk about dependencies in Spring Boot. So dependencies refer to the external libraries or modules that your application would need to function properly. Okay. And Spring Boot makes use of Maven or Gradle build systems to manage the dependencies. So if you remember, when creating the project, we had selected Maven over here. Okay. So this project is created using the Maven build dependency, and we have a pom.xml file over here. Now this is a file that manages all the dependencies that are needed by our project. Now if you want to add more dependencies, you need to add the tags over here. So this is a tag dependencies which tells that all the dependencies are to be specified over here. This is one dependency and this is another one. Now, Spring Boot provides a wide range of starter dependencies, which are curated collection of commonly used and commonly needed by developers for a specific purposes. Now, these starter dependencies makes your life easier as a developer, and by including this, you can reduce a lot of boilerplate code. And you don't have to manage these individual dependencies manually. You need to make use of pom.xml file. For example, when you say, like, I need the Spring Boot starter web dependency, everything that is needed for a web application to function is included. Okay. Now, apart from this Spring specific dependency, you can also include like third-party dependencies that your application might need. And this could include some database connectors, some certain frameworks that you might need, or some libraries that you might need to do caching, or some other functionality that you might require. Okay. But by making use of this pom.xml file and specifying the dependencies here, you can easily save time and effort. Okay. So I'll show you, you can go to like maven.org. So since we are using Maven, I'll say search Maven. Okay. So you will see this link over here, search.maven.org. Now this is a link for Maven Central, and it says, if I zoom in, it says official search by maintainers of Maven Central repository. So you can discover different Java packages and you can even publish your own. So I'll go to this Maven Central over here. And you see the welcome screen over here. I'll say close. Okay. Now what you can do is you can search over here. So I'll say Spring Boot Dev Tools. So this is a simple search that I have performed, and you get to see all the search results over here. Now you can see over here Spring Boot Dev Tools. Okay. And you can see the different information like the latest version, when the latest version is published, licenses, and all of that. You can click on this and you have this tag over here. Okay, so if you're using Apache Maven, you can like copy this and you can paste it in your project. Okay, you can even change this to Gradle, or if you're using any other build tool system, you can switch it to that. Okay, and you also have a Maven pom.xml file. You can see over here. This is an example file that you can take. But if you just need to add it to a Spring Boot project, you can just copy this and add it to pom.xml under the dependencies tag. Now you can go over here and choose the versions as well. You can take a look at the version. Okay, so if you need a specific version, you can go and check that out. So I will go to 3.0.0 and it will open up the page for that. So this is the version and you can see the version number over here, which is specified. Okay, so this is about the Maven search repository. Okay, now if I go back here, so here on the home page, you will see like some of the most popular packages that have been consumed by developers in last 90 days, some of the namespaces and so on. So you can like just play around with this if you wish to. Okay, and you can like just explore this a bit. Okay, now you will also see some dependencies over here. So this is the official website of Spring Initializer, and you're seeing some dependencies that you can add over here. And whatever you add over here, so I added Docker Compose, you will see the pom.xml being generated over here, like for that. Okay, now what is the difference in getting the dependency from Spring Initializer and Maven Central? So Spring Initializer provides a curated list of commonly used Spring Boot dependencies that cover a wide range of use cases. Okay, however, it may not have every single dependency out there that exists within the Spring ecosystem. So there will be scenarios wherein you might want something and that does not exist on Spring Initializer. Okay, so you could go for Maven Central then, or you can visit the official website of the provider for that as to how you can include it. Okay, but there will be several reasons as to why that dependency is not included on Spring Initializer. Okay, and some of the reasons that I could think of is the number one is it's a custom or a lesser known dependency. Okay, so Spring Initializer focuses on what is popular and what is commonly being used in the Spring community. So if a dependency is relatively new, niche, or it's less commonly used, then it may not be included over here in this particular list. Okay, also start.spring.io, like the Spring Initializer website, includes the latest stable versions of the dependency. Okay, so if a specific version of the dependency is not considered stable, then it may not be included in this list. Okay, and also this particular website is maintained by the Spring team and the community. Okay, so they gather a lot of feedback from the community, and based on the community feedback, they make sure the dependencies are available. So these are some of the factors as to why you might not find all the dependencies over here. But if you don't find anything over here, nothing to worry. You can like head over to Maven Central and search for whatever you are looking for. Or like I said, you can go to the provider's website. All right. So that's about dependencies in Spring Boot. So now is the time to start creating our first API. So we'll create a very basic API and we'll understand how things work with Spring Boot. And this will be a RESTful API endpoint. All right. And for that, we are going to need a controller. So I'm going to go to the project structure. I'm going to scroll up, collapse everything. And here I'll go and I'll say new. I'll say new Java class and I'll call this as hello controller. And I'll press enter. Now, if you have Git configured, you will see this pop-up. And if you don't have, you might not see this pop-up. So I have Git configured on my local machine, and that is why it's asking me to add this file to Git. So I'll say don't ask again and add. Okay. Now here in this controller file, I'll start writing some code. Okay. And I've called it hello controller because we are going to just create a simple hello world API. All right. I'm going to first say @REST controller. So you can see this auto suggest, and this is the annotation, which means that we are ready to use Spring MVC to handle web requests. Alright, so we need to specify this annotation if you're building a REST API. And now we are going to create a GET request. So I'm going to say public, I'm going to define a method, I'm going to say string hello. So it's a very simple API, and I'm going to return hello world. You can return anything you wish to, but I'm returning a simple string. And now here we need to, so we have this method here. Now how do we map this to the URL? So we can map this using annotations. So we have defined this as a controller using annotation. We will use another annotation, and you will say @ and I'll say get, since this is a get mapping. So I'll say get mapping. Okay. And as a parameter, I'll specify hello, like so. Okay. So what we have done is, if any request comes on our domain with /hello, so domain name /hello, we will be invoking this method, or Spring Boot would be invoking this particular method and executing the logic that we have written inside. All right. Now let's take a look at REST controller. So REST controller annotation is a specialized version of controller annotation. So you have this annotation as well, controller, okay, which you can see, right? But I'll delete this, and I'll delete the import as well. We don't need the import. But REST controller annotation is a specialized version of controller, and it combines two annotations, controller and response body. And if you wish to see, you can hover on this and press Control or Command. So if you're on Windows, you will press Control. On Mac, you will press Command. And I'll go into this annotation, and you will see you have controller and response body annotation here. So there are other annotations as well, but these are two main ones. Okay. And this indicates that this class is responsible for handling HTTP request and return the response in the form of a RESTful representation. Okay. So that is what this specifies. And we have specified this annotation, which means that we have informed Spring Boot that this is what we are doing over here. And then we have this get mapping annotation with which we defined a get mapping. All right. Now what I will do is I will run this particular application. So I'll go to first spring application.java, and I'll say run over here. So this will run the Spring Boot application. Okay. You can see some processing happening over here. Okay. And you will see this message here. Tomcat started on port 8080. All right. So on your local machine, this application has been deployed on the Tomcat web server, which is now available on port 8080. So what you need to do is we will switch over to our web browser. So here in the web browser, I'll say localhost 8080. So of course, we'll get an error over here. So we get an error, white label error page, and this is a default error page that Spring Boot provides. And it says that there is no mapping defined for this particular URL, which is correct. So we have defined the mapping for /hello. So we need to access that. And you can see over here, we have the first Spring Boot application working up and running in our browser. All right. So what we did, we literally just wrote some small piece of code, a very basic method, and we have the output in the browser. All right. So that's how you can create a Hello World API using Spring Boot. Let us understand how our API worked. So when we executed our application, okay, we have kept our application running so far. So if you want to keep accessing your application from the browser, you need to keep the application running and don't stop the server from here. So this is how you can stop the server, but don't stop if you wish to keep accessing the application. Now, if you scroll up here on the console, the number one thing, when you start the application, you will see this Spring banner that appears printed on the screen. Okay, and this is the first thing that you would notice, and this is a Spring ASCII art banner. That is what it's called. And you will also see the Spring Boot version being printed. Now, after you scroll down, you will see that our application is starting over here, and it indicates that the application is being started. Now, if you scroll back, you will see the environmental variables are being set over here. Okay, so here we don't have any active profile. Okay, and it's using the default profile over here. That is what it says. Now, what I mean by profile is you can set variables like environmental variables in application.properties file. You can define some properties over here. Okay, so we have not defined anything and we have not done anything over there. So it's picking up the default one. So that is a default property file that we have, and that is being picked up, and that's empty. All right, so environmental variables have been set. Now, after environmental variables have been set, Tomcat server is being started. So you can see over here, Tomcat is initialized with port 8080. Okay. Now, if you scroll down further after the initialization of Tomcat, you will see like servlet engine and everything is being initialized. Okay. And then the Tomcat was started on port 8080. All right. So this indicates that our application was ready to access. Okay. And then we went over to the browser and typed in the URL to access the API that we have created. Now, what happened when you tried to access the API? So when you typed in this URL over here in the browser, like localhost 8080/hello, the request was prepared, and this is a GET request that is being prepared from the web browser, and it was being sent to this particular port number on this particular URL. And you have the Tomcat listening over there. Okay, you have all your web application listening over there. And once the request was sent, the request was accessed by the controller over here. So if you come over here, you can see that we had defined this controller, and this is what intercepted the request, and it processed and executed the method over here and returned the response. So this was the entire controller action that happened over here. So if I disable this, if I hide this, so you can see this controller came into picture and it served the request that was being fired right from the browser. Okay, and the response was sent. Now, when sending the response, this particular string was packaged into a HTTP response and it was shown onto the browser. All right. So this is what the entire process that happened. Okay. Now, there is a significant amount of to and fro that happened, and it happened within a fraction of seconds. Okay. Now, imagine if you have more layers defined, like if you have, this is a controller. Let's say if you have service and data access layer defined. So this all happens within a second. All right. So that's about how our application was executed. Let's talk a bit about how Spring Boot auto configuration works. So when you ran the Spring Boot application, you saw that there was a Tomcat server automatically set up. So this is one of the magics of auto configuration, and this magic is being done by Spring Boot auto configuration feature. So this was automatically configured, set up for you, and your application was deployed without you doing anything. We just created the project and imported it, and we wrote a simple controller function. Okay. The next thing I want to talk about is this dispatcher servlet that you see over here. So it said initializing servlet, dispatcher servlet. So dispatcher servlet is at the heart of any Spring MVC application, and it routes incoming requests to the appropriate controller methods. Okay. Now Spring Boot takes care of configuring this dispatcher servlet for you. It auto configures this servlet and it saves the effort of setting it up yourself. Okay. The next thing is the REST controller annotation. So REST controller annotation at the class level tells Spring Boot that this particular class is a controller, and it knows that it is a controller and it should handle the HTTP request. Therefore, it creates a bean for this. Okay. So A bean is nothing but an object that is being managed by Spring. Okay. So bean is created for this particular class in the application context, and it is being mapped to the controller. Okay. So this is all handled by Spring Boot. You just have to specify this annotation and tell Spring Boot that, hey, I will be defining all the endpoints in this particular file. Then we defined the get mapping annotation. So here in the controller class, Spring Boot auto configuration detects that get mapping annotation is specified for this particular URL, and it automatically executes or maps this particular method whenever you call this particular URL. And that is what we saw in action. Okay. So another thing that Spring Boot does for us is default error mapping. So if you access any endpoint other than what you have specified, so like we tried to access the root URL here. So you got this error page. Now this is by default generated error page, and this is pre-configured for you. Okay. It's a simple page. Now if you want to have a custom page, you can definitely modify this. Okay. But this is also one of the magic of Spring Boot auto configuration. All right. So this is about Spring Boot auto configuration and how Spring Boot makes your life easy. Let us start talking about application properties. So in Spring Boot project, we saw this file application.properties, which exists under resources folder. Okay. Now this properties file is used to do configuration in Spring Boot. So you get a pre-configured application with Spring Boot, which you can then customize by using this particular file and specifying the key value pairs. Now, what are the key value pairs that you can specify over here? So for that, you will head over to the browser and you can search for application properties Spring Boot. So I can say application properties Spring Boot. Now you will see this first link over here, which is the official link that I have opened. And this depicts the common application properties that you can make use of. Okay. Now you can see this is supposed to be specified in application properties or application.yaml. So .properties is one format, and then there is another format called YAML format. So if you wish to use YAML format, you are free to use, but we will stick to .properties. So here are the properties that you can take a look at, and this is the categorization of the properties on the left hand side. Okay, so now you can scroll down, and if you scroll down a bit, if I say Control F, I'll say server dot. So if I select server properties, you can see this particular property here, server.port. So this is a property that is used to specify the server port. So when you executed the Spring Boot application, it was by default accessible on 8080 port. Now, for some reasons, if you wish to customize the port, you can do that by specifying this particular property. Now let me show this to you. So I'll head over to our ID and I'll say server.port is equal to 9090. Okay. And I'll hit save. And now let me rerun the application. So I'll stop and rerun. Now if you check the console logs over here, you can see it's running on 9090. Okay. And if you go to the browser on 8080, if you refresh, you won't see anything. So it's like site cannot be reached. And if you enter 9090, like over here, you will see this error appear over here. Okay. And you can go to hello and you will see the endpoint working perfectly fine. So this way you can customize the defaults that you have got using this particular application.properties. Okay. So you can go over here and you can specify this. So I have some properties pre-written over here. So these are some of the properties that enable you to specify or configure a data source connection or a database connection. So you can say, so this is an example for configuring a database connection for MySQL database. Okay. And suppose you have a Spring Data JPA application which interacts with the database. So you can say the database URL is this, username is this, password is this, and you're specifying DDL auto update. Now what this means is you are telling Spring Boot to connect to this database, okay? And this last property is telling Spring Boot to automatically create or update the database schema as needed, okay? So with update, if there are any changes, it will simply update and create. Now, one important thing to note over here is that properties defined in the application.properties file can also be overridden by command line arguments. Okay, so you can run your application by command line, Spring Boot application. So since we are using an ID, we are not doing that, but you can specify the argument as server.port is equal to 7070 while running. And this will make sure on command line the 9090 is overridden and it runs on 7070 instead, even though you have specified 9090 in your application.properties. So this way you can make use of application.properties file, okay, to like configure some pre-existing configuration that has been given to you by default by Spring Boot. Okay, so this is about application.properties. Let us talk about how you can create a post request. So the first thing, I will remove this server.port property and I'll let my application run on the default server. Okay. Then I'll switch over to hello controller. So this is where we will be defining the post request. So we have a get request. Now post request is another type of request with which you can send some more information. Okay. So we have an annotation @get mapping to define a get mapping. Now what will it be for post? It will be post mapping, like so. And we will keep the URL same. So I'll say hello, like so. Now here I'll define the method. I'll say public, I'll say string, and I'll say hello post. So this is the method that will handle the post request. Okay. And here I'll return something. So I'll say hello. And let us return the name over here. Okay. And I'll add an exclamation at the end, like so. Now we are returning the name of the user or whatever is passed with this post request. Now where does this name come from? So we are getting an error right now that name is not defined. So we need to give this name as an input to this particular method. And this name should be accepted from this particular post request. So for that, I'm going to add an annotation over here. I'm going to say request body. So from the request body, give me string name here, like so. Okay. So in get, we did not have any parameters because get is just a method, like get is just a request call. Okay. But in post, you can send some data along with the request. Okay. So what we are saying is we are saying request body, and this request body annotation is used to indicate the request body that should be bound to the method parameter name. Okay. So with this, we are done defining the post mapping over here. Okay. Now what we can do is I'll rerun the application. But the question is, how do we access this using the browser? So we cannot access or we cannot execute a post request from the browser. And for that, we need a special tool, and a tool like POSTMAN could help us do a post request to our application. All right. So far we have created the post request and we have returned the response. Now it's time that we should see it in action. So after defining the post mapping, we need to now figure out a way to execute this. So it's not possible to execute this from the browser like we did for get mapping. because we need to pass some additional information with the request. And there are some special tools that enable you to execute post queries. So for that, we are going to head over to the browser and I'm going to search for POSTMAN. Now, POSTMAN is a tool that enables you to work with APIs. So I'll go to POSTMAN API platform and you can read and learn more about this particular tool. Okay. Or what I'm going to do is I am going to straight away download POSTMAN. Okay, so I don't find the download link over here. Okay, so you have to go to product and you can say get started for free and you will be taken to this page where you can download POSTMAN. Now it will automatically detect your OS, and since I'm on Windows, it's telling me to download for Windows 64-bit, or you can even try it on web if you don't want to install it onto your system. And this is what it will look like, the interface. Okay. So what I'm going to do is I'm just going to download this particular tool for my Windows machine. So as you can see, it's being downloaded. Okay. And it's been done. Now what I can do is I'll double click on this and I'll get this installed onto my system. Okay. So I believe we downloaded the portable version. Okay. So it didn't install, but it just directly launched and I'm going to add it to my taskbar as favorites. Okay. So you can hit download button over here. Okay. And download the respective version for your operating system and get it installed. The installation steps are very, very easy. Like it's just like any other software with no complexity. Once this is installed, so I already have this installed onto my system. So once you launch this for the first time, you will see an interface like this. Okay. Now you can see on the left hand side, you have this pane which talks about history. And this gives you the history of all the requests that you have executed. On the right hand side, you have this pane to execute a request. And along with the request, you can pass in additional parameters, authorization information, headers, body, and so on. So a lot of information you can send along with requests. And this particular tool is just for working with the APIs. So what I'm going to do is I'm going to head over to 8080. I'll copy this URL and we need to write a post query. So I'll paste this URL here. I have get selected over here and I'll say send. So you can even run the get request. As you can see the output. I'll just zoom in a bit. So the output is hello world and this is the exact output that you were getting from the browser. Switch this to post. Okay. And now here in body, you need to add some body. So I'll select body. Okay. The reason I'm selecting body is we need to send the request body along with the request. So I need to add a body. So I'll go to body. Under none, I'll say raw. And I can specify anything over here. So I can specify hello Spring Boot. Like so. And I'll keep text selected and I'll say send. And you will see hello Spring Boot. And you can see 200 OK over here. So after execution, the default status code that you get after successful response is 200 OK. Okay. And you can see the time 16 milliseconds and this is the data. Okay. So here you can see the history appearing as well. Okay. So even if you fire get query, so if I fire a get query, you can see the status code as 200. Okay. So the status code for both was 200. Okay. All right. And you can see the response generated as well. So you can make use of POSTMAN, okay, to play around with different API queries or different API requests, not queries. All right. And POSTMAN is pretty handy and it is being used widely. All right. So that's about how you can work with post requests with POSTMAN. Thank you. Hello everybody, welcome to this class. So in this lecture, we are going to do some setup related work with Postman. Of course, we have installed Postman. We are calling the APIs. It's working well. But there is some additional setup that I believe needs to be done. And if you do it, it would be beneficial for you. So what is happening right now is we are seeing this history tab and all the requests that we have created over here. Now, the thing is, we are not saving these requests. Okay, so if you close this, it is coming in the history format. Okay, so if I close all the tabs, it's coming over here in the history form. And if you delete Postman or anything happens, you have essentially deleted all these requests that you have created. And you might want to reuse these requests later on or whenever you are testing something. Okay, so what we can do is we can save these requests. Okay, now what I would recommend is you can say add to collection over here. Okay, you can see this button over here. Now, what is this concept of collection over here? So in Postman, you can save a request within collection. So collection is nothing but like a group of all the API requests within Postman. So within this collection, you can have like 10 API requests that have been saved by you, for example. Okay, and you can categorize API requests that you are saving in the form of collections. But you cannot add anything to collection right now. You need to create an account. So I would recommend you create an account over here. Okay, you can either click on this, add collection, or you can say sign in if you already have an account, or you can say create an account from here. Okay, so it will take me to the browser over here, and I can put in my email. So I'll say embarkxofficial@gmail.com, or instead I can just sign up using Google. Okay, so I'll just copy this email so that I don't have to type in again, and I'll say sign up with Google. I'll use another account. Okay, I'll add embarkx and I'll just sign up over here. So I've entered my password, and so basically you will be prompted with this particular pop-up here wherein you would be asked to accept the license. You can read through the license if you wish to, but I'll say accept. Okay, and we'll wait for the redirect and it will show you this pop-up now. So do you want to open this application? So I'll say open Postman. And once you open this, okay, so you will notice that you will be logged in. So this is taking a bit of time. Okay, so it's saying welcome to Postman and tell us a bit about yourself. So it is now onboarding us to this particular application. So now I'll say my name as embarkx official. I'll just keep it embarkx, and my role is I am, let's say, a full stack developer. I'll get started. Okay, and I'll say got it. Okay, now we'll have a history tab over here. So suddenly you will see we didn't have all these tabs. Okay, and now you can see we have tabs like collection. Okay, we have tabs like environments over here on the left hand side. You have history as well. All right, and what you can do is you can go to history. Okay, we have just added this particular request here, and you can see the save button enabled over here now after you logged in. Okay, so you can definitely save this, and it will ask you where you want to save this request. Okay, so it's telling you that you don't have any collections, and collections let you group related requests. So if you have multiple API requests that you are doing that are for a particular application, you can group them together. Okay, using a collection. All right. Now you can say create a collection over here because I don't have a collection, and I can name my collection. So I can say job application over here. I'll say create. Okay, and the save button is enabled now. Okay, I'll say save. So you can see this has now been saved to the collection. So this was the post request. I'll just close this. Okay, this is another post request. And I can go to the history and I can simply save the get request as well. Okay, here is a get request. So I'll save this get request and I'll save it to the collection. The collection is selected now by default. You can add a description as well if you wish to, okay, but I won't. So I'll just get this saved, okay. I'll save this hello application as well. So these API requests, okay, and I'll change this. I'll create a new collection and I'll say hello world app, like so. This is saved, and I'll save the get request as well. You can save everything you need, okay. And if you go to collections now, collections tab, you will see. So if I right click over here on the API request tab, I can close all the tabs, okay. Now over here under collection, you will see these collections here, okay, which have been created. So these are like folder, and this does a really good job of organizing all the APIs, okay. So you can click on this, you can have this saved, okay. You can modify this and you can save it again. You can create a copy of this, okay. So I can go over here as well, click on 3 dots, duplicate this, okay. You can duplicate this as well. So all these are the possibilities with Postman, and you should leverage these possibilities, okay. So if something happens to Postman and if you have not signed up and if you have not saved the API request, you have to create the API request again, okay. You need to write the JSON again. It takes time, okay, but this is much more easier, and we have this functionality, and you can leverage this by doing a simple free sign up. All right. So this is about Postman in how you can save the API requests. So we have come very far with our application, and we are learning a lot of things slowly. All right. So I wanted to highlight and I want to talk about JSON response. Okay. So over here right now we are getting a response as hello world. Okay. If you pass something over here in the post request, you see hello Spring Boot depending on what you have passed in. All right. Now the thing is, when you're designing APIs and when you're working on real world projects, you would be working with objects, right? So Java is a object oriented programming language like we know, and Spring Boot is based on Java. So underlying technology that we are using is Java. So it is all going to be classes and objects. Now, when you're designing APIs in real world, you would be returning the JSON response. So JSON is the standard, JSON and XML, but JSON is used frequently, and JSON response is what you will be returning to whoever wants to consume. Okay. And that is what the standard is. Now over here, what we are returning is a plain text or a string, I should say. It's hello world. How do I get JSON response over here? Okay. So we need a way wherein we have objects, classes, and we would be translating those objects and classes into JSON response with the help of the API. Okay. So let's see how we can do that. So I'll come over here to our code base, and here we have this controller setup. Now what I'm going to do is I'm going to add a class that is going to store the message. Okay, so it's going to be a very simple class which is also going to store the message, and it is going to help us understand how we work with classes and objects when building APIs. So I'll come over here, okay, and here I will create a new class, let's say, and this class so we can call this class as, let's say, hello response. Okay, it's going to be a very simple class, okay, like I said. And here let me add so what I'm going to do is here I'm going to add a parameter or a class member, I should say, not parameter, I'm sorry about that. So I'll say private string, and I'm going to say message here, okay, and I'm going to generate the corresponding getters and setters. Okay, so I'm going to go over here and I'll auto generate the getters and setters. So we have this particular class which is managing the message. Now what I'll do is here in the controller, instead of directly returning the string, okay, what I can do is I can return the object of hello response. Okay, and how will I do that? So I can say over here, so let me cut this. Okay, I'll cut this. I'll say new hello. You can see hello response here. Okay, and within hello response, I'll pass in hello world over here. Okay, and you can see this is being passed. Now here we don't have a constructor. So what I will do is I'll get a suggestion here, create a constructor. So the constructor is created. Okay, so it did not set the values automatically. So what I will do is I will come to this class. I'll say generate constructor with this one parameter, and this is it. All right. Now you can see here. Okay. So now we are getting another error that this is returning string, but we are returning hello response. So we need to change the return type over here. This is done. Okay. Now I can rerun this code. Let us see what the output looks like. Okay. So you can see the application is started. Coming back to the Postman, if I trigger a get request, you should see a JSON response here. Okay. So this structure is the JSON structure. If you want, you can even head over to the browser and you can say validate JSON, and you'll get a lot of validators. Okay. So you can go to any of the validators. They will validate whether whatever you have, whatever structure you have is valid JSON. So I pasted this, clicked on validate, and it says it's a valid JSON. Okay. So this is a JSON response that our API has returned. Okay. Now talking about the other API that we have, the post request, it is returning this, right? So I'll copy this. I'll come over here. Okay. Let's minimize this. Here I'm going to say new hello response, and I'll pass this entire piece of string as the parameter for this. Okay. Okay. Something like this. Okay. And this is again going to give me error. It will say make hello post return this instead of string. And I'll say yes to that. Now if I rerun, okay, you should have a JSON response here as well. So if I send this, you should see message is JSON response. Okay. You can see here message, and this message, what is this message? This is coming in from hello response. So here, if you go, here you have this message. Okay. And it is, what it is doing is it is converting the object of type hello response into JSON object. So let me explain this as to how this conversion happened automatically. Okay. We did not do anything. We are just returning the object of this type, right? And the conversion into JSON happened automatically. So if you go to a REST controller here, okay, REST controller has this annotation response body, okay, which means that the data that is being returned by each method returned directly to the response body, which means that the data returned by each method over here is written directly to the response body in the appropriate format. Okay. And the conversion is internally handled by Spring, and it makes use of something called as message converters. Okay. So there's a concept of message converters, which handles the conversion of values into JSON automatically. Okay. And this conversion that happened right now is being handled by something called as Jackson library. Okay. So there is no import statement for the same, but if you go to like the project structure and if you click on external libraries, okay, if you scroll up and down here, you should see Jackson. You can see some libraries having Jackson in the name. And also if you go to like the run logs over here, and if you search for Jackson, you should see over here Jackson everywhere. Okay. So this is a library that is in use. Okay. And this is handling the conversion from the object to that of JSON. Okay. So what it's doing is Jackson serializes the Java objects to JSON. So here we return the object and it is doing the job of serialization. How does it do it? It does so by calling the getters on the object for all properties. Okay. So if you see over here, we are defining the getters. Okay. So we have getter. So it is going to serialize that particular property. Now this also tells us that if we don't have a getter for this property, that property will be ultimately skipped from the response. Okay. So this is something that you need to keep in mind. Okay. And this Jackson library is something that we have not added. Okay. How did it get added? So I'll tell you that as well. So if you go to pom.xml over here, okay, and if you scroll down here, we have this dependency, Spring Boot, starter, web. So this starter normally includes all the dependencies that is required for building and developing web application, including the JSON handling through Jackson. Okay. So it's coming in because of this line that we have added over here. Okay. So this is how the JSON response will work. And this is how you can like get the object converted or serialized into JSON. Okay. So I hope this was useful and I hope you have a clarity of this particular concept here. So let us now begin talking about path variables. So what is path variable? So whenever you are designing a GET request or a GET endpoint, there will be scenarios wherein you might want to pass some variables within the URL itself. Okay. And this variable will add to the dynamicity of the URL. Let me explain what I mean over here. So I'll just duplicate this endpoint here. Okay. And here I'll call this as hello param. And here I can have a dynamic parameter. And let's say based on what this variable is, okay, I will change my response. Okay. So let's say I can pass in name. And this is a syntax as to how you can pass in a dynamic path variable into a URL, okay, with the help of Spring Boot. Okay. So if you come over here, okay, we have this hello API up and running. If you pass in /name, it is not going to work, right? Okay. And this is not working because we have not handled this dynamic part here. Okay. So I wish to handle this. So what I will do is I have this thing over here. Okay. I'll tell Spring Boot that, hey, this part of the URL is dynamic. Okay. And whatever is being passed over here should be given to me with the variable name called name. Okay. Because name is the variable name that we have put up over here. Okay. And what I can do is whatever user is passing, I can get it over here. I can get it path variable. I can say string and I can say name over here. Something like this. Okay. And what I can do is I can even print that over here. So I can say hello, and instead of this, you can have, so I can say here, and let me get rid of this. Okay. Here I can say name like so. Okay. Now let me run this. So let me run this and let me show you. Okay. So you can see the app is running, and now where we were getting an error, if I refresh, you'll see like I'm getting hello name over here. Okay. So I've passed in name over here. If I say hello John, it'll give me hello John. So whatever I'm passing over here, I'm getting that as the response. Okay. And we are doing this with the help of a dynamic variable in the URL that catches that particular variable in the method with the help of the annotation path variable. Okay. So we are making use of this annotation. Okay. Now what is path variable? So if you come over here, this path variable is a annotation that is being used in Spring MVC to handle the template variables in the request URL. Okay. So it will bind the method parameter to the URI template variable over here. Okay. And this is useful if URL often contains parameters and there might be some dynamic elements into the URL. Okay. So that is what we are doing. Now, talking about the use case as to why you want to make this thing as dynamic. Okay. So there are several use cases. You might have an API wherein you might want users / and you might want to pass in the user ID over here. Okay. Something like this, user ID. Okay. Like this. So you might want to pass in /users/1, and that will give you the first user. Okay. So you must have seen endpoints like this if you have been doing development. If you head over to Google and if you go to any blog, so I'm here on Amazon blog, okay, business.amazon.in. And if you see any article, it will have the slug over here. Okay. Let me switch over to some other article. So if I go to this article, okay, differences over here. You can see the URL remains same, just this part changes. Okay, URL is absolutely same. You can see. If I switch over to another blog, let me do that here. You can see this part changes. Okay. So in blogs, you must have seen this concept of dynamic URLs where a part of URL is dynamic. So that is being handled, or that can be handled with the help of path variables, as you can see. Okay. So you might be wanting to have these kind of URLs like to make your application SEO friendly. So in blogs, this can make your article SEO friendly, right? Like this is anyone searches for e-commerce business ideas can get this as a search result in Google. Okay. So these are some use cases, and I wanted to bring this up and explain this concept to you all. This concept of like having path variables. Okay. So I hope you have some clarity. Also, I want to mention, like after this variable over here, you can even have one more part in the URL. So I can say show for example. Okay, and if you come over here, let me run this. So once this is running, if you refresh this, this will give you an error now because it is expecting show over here. Okay, so you can see. So is show dynamic? No, it's not. Only John is dynamic. So if I change this to Michael, something like this, you will get that as a response. If I change this to Tom, you'll get that as a response. Okay, so you can see you can have a variable in between two fixed parts. Okay, so these are two fixed parts, and in between you have this template which is telling that this part is dynamic. So that is also possible. Okay, I just wanted to showcase this to you because this is important, and when designing URLs, you will often come across this particular thing here. All right, and just be sure to have this variable name like in the URL and this name as same. Okay, so if you make this as name1, it won't work for you as expected. Okay, so this and this in the URL has to be same so that it can map to each other. Okay, so yeah, that's about path variables when it comes to creating dynamic URLs with the help of Spring Boot. Now it's time that we set up our project. All right. And to set up the project, we are going to head over to our favorite website, which is our favorite website, people, when learning Spring Boot. It's, of course, start.spring.io. Okay, so this is the Spring Initializer. Just remember this domain name. You will need this a lot. Okay, and you can even search for Spring Initializer on Google and you should land over here. Okay, make sure you select Maven over here, Java, and just don't select the snapshot versions over here. You can select the normal version. Also, by the time when you're watching this video, there is a possibility like you might see a new version up. Okay, so don't worry. Things don't change, but if they change, I will update the video. So don't worry about that. Just select the version that is available because whenever I come on the website, I frequently see new versions up and running. Okay. I'll change the group. Okay, so this will be the package name of the project. So I'll have eCommerce artifact. This will be the name of the project. So I'm going to have SB and I can say ecom. This can be like the name of the project, and SB stands for Spring Boot, and then ecom is eCommerce. All right. Description. So we can see over here, you can add any description if you want. Okay, this is not mandatory. Of course, Spring Boot eCommerce project, something like this. Okay, and package name, I'll just change it. I don't want it to be SB-ecom. I can say ecom.project, something like this. All right. I'll select jar. You can select the Java version as 17 or 21. That's perfectly fine. Add the dependency. Okay, and here we are going to add this particular dependency. We are going to add web because this is going to be web application, which will have RESTful and Spring MVC. We are going to make use of all of that. We'll need Apache Tomcat as well as default container. You can head over to explore and take a look at the structure here. Okay. Alternatively, you can even download it from this page. So from here, you can simply say generate, or you can even download it from here. Okay, so I'll just say generate. I'll get this downloaded on the location of my choice. Okay, wherever I'm going to code, whichever folder location. Okay, and then we need to open that particular folder in IntelliJ. Okay, so I'll just hit generate. So I have it downloaded in the location of my choice. I'm going to right click on this and I'm going to unzip it over here, extract here. Okay, so you should see this folder here. Now you can come over here in IntelliJ. Okay, this is a welcome screen and these are all the projects that I've been working on. You can say open from here. Navigate to the folder where you have downloaded. Okay, and within the folder, you can select the pom.xml. Okay, and you can say okay. So pom.xml is a project file. Would you like to open the project? Yes, we want to open the project and not just the file, right? So we'll get the project open. It is asking me, do you trust the project over here? Okay, so I trust all the projects in this folder. I'm just checking this. Okay, you can either uncheck this and say trust the project. You can even preview this. Okay, up to you. I'll say trust the project. It opens up and there will be some processing on the right-hand side bottom here. Okay, which is fine. We'll wait until it resolves all the dependencies. Okay, and done. Our project is up and running. We'll wait for a while until it downloads like everything, like Maven, all the Maven dependencies. Okay, and it's done, I guess, and we are up and running with our application. So now it's time that we structure our thoughts and understand what we are going to begin with. Okay, so I'll show you this diagram over here. This is what we are going to begin implementing. Okay, so you can see here we have a browser that is making a request to the application. Okay, so the request is flowing through the browser. So it can be anything, whether a browser, a mobile app, or any other client that wants to make use of our services. Okay, so this is our application, and within our application you can see there are controllers and there is a service. So in fact there is one controller only as of now in this diagram. So this is the category controller and we have the category service. So whenever a request comes from browser or any client to our application, controller is the one that will be intercepting the request, and then that request will be forwarded to the service. And then the response goes back to the browser, and this all is hosted on the server. Yes, ideally we will be having database and a lot more services. We will have a repository as well. But for now, we'll begin very small. We'll take baby steps. We'll understand how things are working and we'll learn in the process by building. Remember, hands-on learning is the best learning that you can have. Okay. And just to give you a hawk-eye view of what the entire application will look like, this is what it will look like. So we are going to have a client requesting our services, and we have the controller layer. Then we have the service layer, and then we have the repository layer. So controller layer, you can see there are so many controllers. We have product, order, category, cart, auth, address. And these respective controllers will be intercepting the respective endpoints for their module. And then based on what the request is, the service layer is going to be called, and the respective methods in the service layer will be called for the corresponding module. Okay. Service layer is where our business logic will reside. Controller is where the request will be intercepted. Okay. Service layer will do some business logic and then it will talk to the repository layer if needed, if it wants to interact with the database. And repository layer is the layer which will do the talking to the database, as you can see over here. And database is where our data is being stored. And then from database, we get the response back to the repository, and then from the repository to the service, and then from service to the controller. And then controller returns the response to whoever is requesting. So that is the entire flow of our application. But as you can see, we have just picked up the category controller and category service and not the rest of the things. Okay. So we'll go granular, we'll start building, we'll learn a lot of things during this entire process. And then eventually you will have a hands-on experience of doing all of these concepts. Okay. So category module, like I said, is what we are going to build, as opposed to like taking a look at the entire application at once. Okay. So this is what we are going to do. And if you take a look at the category module, these are the APIs that we need. Okay. So I have API name, endpoint, method, purpose, request body, request parameters, and even response that it's supposed to return. Okay. So API name is just the name of the API. It is for our reference. Okay. What the API is supposed to do. We have the endpoint. So this is the endpoint that the API is going to have. So you can see /API/admin/category. Now this will be prepended with the domain name. Okay, wherever you are going to host your application. Let's say if you are hosting it on localhost. So localhost :8080/API/admin/category. If you're hosting it on example.com, it's going to be example.com/API/admin/category. Okay, that is the endpoint part. Then you have the methods. You have post methods, get method, put method, and delete method. Okay, and you have the purpose. So you have create a new category. Okay, these are all the purpose for the respective endpoints. And then you have the request body. So this is what is supposed to go in the request body, and this is what is supposed to go in the request parameter. And then you have the response. Okay. So response is what the caller gets back, or what the application is supposed to return, right? So let's begin talking about creating category first. So when we create a category, we need to call this particular endpoint. Okay. And it's a kind of a post request that we will be doing, because we are creating a new resource over there. Okay. In the database, of course. And then the purpose of this is to get new categories being created. Okay. What is the request body? So request body will have the corresponding category object. Now this category object is the object that we wish to create, or it will have the details of the new category that is supposed to be created. There are no request parameter, and the response is category DTO. Now what is a DTO? Okay, we are not aware of DTO as a concept, so we have not discussed yet, but don't worry. DTO is something that you'll learn a bit later. Okay, so this is not something that we are going to implement immediately. Okay, this is something that we'll implement in the later stages when we talk about these concepts. So concepts like DTO, okay, concepts like pagination. So you can see these request parameter like page number, page size, sort by, sort order. Okay, so normally what happens is whenever you have APIs, and if the API is returning a lot of data, let's say like category, this category API, and if that category is returning like thousands of category, you don't want all 1,000 at once, right? You will need 10 at a time. Then in the next call, you need 11 to 20. So you might also want data to be sorted in a certain way by a certain field. So all of that details we are taking care of over here. But this is the concept of pagination and sorting, which we'll talk about later. But for now, I'm just giving you an overview of what the APIs will look like in its final state. Okay. So coming back to DTO here, this is going to be the response. Okay. For now, we are going to just return a success message, and we might even give the status code. Okay. So that's what the create category API is going to do. Then we have the get category. Now get category has this endpoint API/public/categories. Okay. The method is get, of course, because we are trying to get a resource right from the database. The purpose is, yes, to retrieve the list of categories. Request body, there is no request body needed, right? Because we are just telling the application, hey, dump all the categories that you got. Okay. Request parameters, yes, we have 4 parameters: page number, page size. So page number, page size is for paginating the request. If you're not aware of pagination as a concept, don't worry. Okay, I'll be covering all of that. But for now, just to give you a idea of what it is, if you go on Amazon or any website, and if you search for something, okay, so let's say on Amazon you search for a product, you have those page numbers at the bottom, like page 1, page 2. Let's take Google search itself. If you search for something, you have like page 1, page 2 result, page 3 result. So that is what is pagination. You have paginated the result, which means converted the results into pages. So if Google query is returning you 600,000 results, it is not going to dump all 600,000 results on single page, right? It's going to have pages. So that is what this thing will handle. Okay. And if categories go large, then we need to have this. So you can specify page number. So which page number are you requesting? What is the page size? Do you want page size to be 10 or 20 results? You can pass that. How do you want results to be sorted? Whether there is a sorting order, ascending, descending, all of that. Okay. Category response is a custom response that we'll be making. Okay. We won't be having this initially, but we'll add this later on when we talk about DTOs and payloads. All right. Then we have update category. Of course, update category, like the name says, it is for updating the category. So you need a category ID over here to tell that, hey, I need to update this category. Put request, and it's a put request, of course, because we are updating a resource. It is for updating an existing category. So remember, this category should exist. And of course, request parameter is category ID. You can make out from here the endpoint, and the response is category DTO. Okay. Delete category is all about deleting. You again need a ID, category ID. The request type is delete, and it will delete an existing category. Okay. And like endpoint says, the request parameter is category ID and the response is category DTO. Now this part of response over here, That is something we'll be talking about a bit later. So these DTOs and payload, like I said, we'll introduce later. Okay, so don't worry about that. But this is just the final state as to how our category API will look like. Okay. For now, since we are not aware of the concept of DTO and payload, I won't be overwhelming you all. I will be just having a string and this status code that I'll written. All right. So that's about the overview of the API. Now let me talk about something. If you notice these APIs, these endpoints over here, okay, you'll notice /API /admin/category. So you have this admin in between. /API /public/categories. Okay, so either you have admin or either you have public. Okay, now what does this mean over here? Okay, so this is a convention that we are following over here. Okay, in the URLs that we are designing. Okay, so you need to understand this, why I'm doing this, and what is the need of this. Okay, because if you're building production grade applications, okay, you will be seeing this, you will be doing this. Okay, and this is good practice. And I just don't want you to like show you that, hey, this is the API and just design it. Okay, no. I want you to understand why this admin I have inserted over here, so that next time you're building your own thing, you understand what is admin, why public, and so on. Okay. So admin and public in URLs are a convention that we are using in API endpoints. And this is a strategic design choice that we have done. And this is helping us in organizing the API from the security perspective. So understand this. There will be few endpoints that you want only the user who is admin in your application to handle or to call. Okay. So let's say I'm a user, I'm Faisal, and I wish to, let's say, delete a category. Now this particular thing, let's say we are building a multi-user application. So there is not a single user, like Faisal is not a single user. There are multiple users. Okay. There are tens and hundreds of users. I don't want everybody to be calling this, right? Because if everybody starts deleting a category and managing categories, it's going to be a mess. I just want people with certain access levels to manage categories, right? Everybody can get the categories. You can get the categories. You can see what categories exist in our application. Okay. That's not a private data, right? But modifying categories, I don't want anyone to modify. I just want admins to modify. So that is what I'm doing over here. Okay. So I'm clarifying the intended audience and how this API is supposed to be used by whom in the URL structure itself. Okay. And when you say /admin over here, okay, it is signaling that this particular endpoint is for administrative purpose and should be restricted to authorized users such as system administrator or users with specific roles. Okay. So from the security perspective of our application, I'm designing the URL paths, and this setup helps me set up security rules and any sort of access, like restricted access, if I wish to have later on in our application. Okay. So later on, it won't be a mess. I'll know while looking at this endpoint that, hey, this is like for admins. This is also restricted API. Public. Okay. This is public API. There's nothing sensitive over here. Okay. So the security of the application, the design for security is done in the API design itself. Okay. And this is really important. I'll tell you people, this might not look a big thing right now, but later on, let's say if your application grows and you have several modules, several endpoints, okay, there are several developers, like hundreds of developers working on a single app, designing endpoints, it will be a mess. Okay. If there are no conventions, it will be a mess. Okay. So these all things like are really important, because even when designing security, okay, you can have these checks. Like if the API URL includes admin, it means that the authentication is needed. So all these kind of checks you can then later on add. Okay, if you want to do a specific sort of logging for admin users or for endpoints that are restricted only for specific roles, so you can include checks over there. Okay, so all of these things can be done then later on if your application grows. So that is something that you need to understand what I'm doing over here. Okay, /admin. You will say that, hey, the API endpoint is long. Okay, I can easily trim it. I can remove /API and /admin. And I can just keep category. Why are you not doing that? So localhost :8080 /category, that can be the endpoint for creating category, right? That can be, of course. But why have I added slash API? Why have I added slash admin? Okay, slash category I have to add because I need to have all the category related requests on slash category so that I know that this request is for category, right? But why do I have slash API? Slash API because you can see all the APIs are having slash API. They're beginning with slash API. Why? Because if you go to slash API, then you are talking to the API. That is what the structure is. Okay. Some people or some application also have subdomains. So APIs dot domain name slash something like that. Okay. But by design, we are going with slash API. So slash API means we are accessing the API. Okay. And slash admin slash public means these are the rules. And then slash afterwards is the module. So it will be category, it can be product, whatever you're designing. Okay. So just understand this design, and then later on we are passing whatever parameter this API needs. Okay. So that is the design structure, or that is how I'm designing my endpoints. And it's really important you understand. This is not something that I woke up and I said, okay, let's do create category as slash API slash admin slash category. That looks good. It's not like that. There is a thought process. Okay. So when designing URLs, just keep this in mind. So I know this is getting a little bit long, but I want to spend some time and get this thing clear, because what I've done is I have seen developers, they just come up with like the endpoint of their choice. Okay. It should not be that way. I've seen the people doing this. There has to be a thought process. It has to be organized from day one. Okay. Later on you're organizing. Okay. It will be a mess. You can do that, but it will be rework and it will be an issue. Okay. If imagine now these APIs are being consumed in front end, and if you change it later on, like if you start adding, if you don't add slash API slash admin, and later on you say, hey, domain name slash, then if you enter domain name and slash, I wish to have, so let's say you design a API with domain name slash category. There is no API and admin. And then later on, let's say you want to put a page, domain name slash category. They both will have the same URL. You can't have two things on a single URL, right? So it's best to have design decisions right from day one, because then later on if you change and if this API is being consumed in the front end, there are so many changes to be done, right? So yeah, I just want to spend some time on this because this I feel like is important that you understand. And all the APIs that we design will be this way only with this thought. All right. So that's about this. And I hope you have clarity about the category controller, like the category module essentially as to what we are going to build. And I hope you have clarity on the different decisions that we took. So I hope this was useful. Welcome, and now it's time that we begin working with the category module. All right. So what we are going to do is we are going to fetch all the categories. So this is what we'll be doing. We have browser, controller, and service, accepting the response and then sending the response back, and everything is hosted on a server. So I'll come over here quickly, and I have our Spring Boot project also set up. Okay. So if I head over to Java, and if I run this particular project, okay, let us see what the default thing is. Okay, the project setup is perfect. Okay, there is no issue as such, but we need to start working on the controller. So we will be creating a controller for fetching all the categories. Okay. And of course, we will also need a model. Okay. And what I mean by model is something that is going to represent the category. Okay. So I have eCommerce project over here. Okay. What I'm going to do is under this, I'm going to have this file, and I'm going to call this as category controller. Something like this. Okay. And I'm going to have this within controller package. Okay, so I'm going to say controller dot category controller. Okay, something like this, and let us see what happens. So you can see this particular class was created in eCommerce project controller. Okay, so this is the package where we are going to have all the controllers of our application. Okay, we also need a model. So what I will do is I'll go over here, I'll say new, and I'll say model dot controller, something like this. Sorry, not controller, it's category, like this. Okay, So this is going to be the class, okay, that is going to represent the category. Now what we would do is we would, let me hide this a bit, okay. So now over here, I'm going to set the attributes of category. So I'm going to say private, long, and I'm going to have category ID over here, okay, something like this. And I'm going to say private string, and I'm going to say category name. So we are going to have ID and name that will represent the category that we are creating in our application. And I'm going to generate some boilerplate code. I'm going to generate, let's say, getters and setters here. And I'm even going to generate the constructor like so. Okay, so constructor with both these parameters. Okay, so this is done. Now I'll come back to category controller. Okay, and in category controller, I am going to have a mapping that is going to return all the categories. Okay, so first thing, I need to mark this with REST controller. Okay, now once we have added this particular annotation, what I need to do is I would be creating a list. Okay, so I'll say private list, and I'll say category. Okay, and this is going to be a list of categories, and I'm going to say new array list. Okay, something like this. All right, and now I need a method, so I'm going to say not private, I'm going to say public, and I'm going to say list of category, and this is going to get all categories. Okay, like so. And what I'm going to do over here is return all the categories like so. Okay, so this is our method, and I'm going to map this particular method to a endpoint, and that endpoint is going to be get mapping, and I'm going to say here slash categories, something like this. Okay, so when you access slash categories, you're going to be given the list of all the categories. In fact, the URL that we should have is slash public slash categories. Okay, and I also need to have API over here. Okay, so this is what the endpoint that we need to design. Okay, so once we have the endpoint set, what I would do is let me restart this application. Okay, so once the application restarts, let us go over here. So I'll just copy this endpoint. I'll come over here. I'll create a new collection. Okay, a blank collection. And I can call this collection as Spring Boot eCommerce like this. And I'll have a request over here. I'll paste the URL over here, something like this. Okay, and then I'll call this as get categories. So you can name it whatever you want. Okay, but I'm keeping it a little bit descriptive. Okay, let's close this and let me hit a send request. Okay, so you can see we are getting the valid response, and this endpoint is working perfectly fine. So what we are doing over here is we have a model, category, a controller, which is intercepting all the API hits to this particular endpoint over here. Okay, and model is of course how our category is structured in our application, like what all information we are storing about the category is being managed through this model. All right, and in the end, like this is what the information that we'll be mapping to the database. This is something that you will see later, but this is about getting all the categories that exist in our application. And yes, of course, we have made use of list, which is okay for now. Okay, we'll slowly transition into something better. So I hope this was useful. So we have a GET request up and running, and the GET request is returning us no results. Okay, so we need a way to add categories into our APIs so that we have them saved. And a way to get that done is with the help of a post mapping. So first I'll begin creating a method over here. I'll say public string, and I'll say create category over here. Okay, so this is going to be our method, and I'm going to have a request body over here. Okay, and this request body is going to come in with the request, and it is going to be an object of type category. Okay, and I'm going to simply return over here category added successfully. Is category added yet? No, we need to add, and we need to write the code for that. So where are we adding categories? We are adding categories into this list. We are managing all the data right now in the list. I'm going to say categories add category, something like this. And here I'm going to say post mapping. Okay, something like this. All right, and this is going to be the same endpoint that we have over here, like so. Okay, so this is what the post request is going to look like, and let me run this and let us see how this works. Okay, so you can see the application is up and running. Let me duplicate this. Okay, I'll duplicate, and this is the create a new category. Okay, so I'll say create new category, something like this. Okay, and instead of get, this is a post. Okay, the URL has not come because we did not save the request. Okay, so be sure to save over here. And this is a post request, so we need a body over here. Okay, and this is going to be raw JSON that we are going to add. So now here we need a JSON, and I'm going to just have the JSON here. So I'm going to say, like, open curly brace. I'm going to have, let's say, name. So let us see. Okay, so we don't have a response yet. Okay, so this is going to be name. So it has to be variable name here. Okay, so it's category name and category ID. Okay, so category name colon, and I'm going to add, let's say, travel. Let's say that is our category, one of the categories. I'm going to have category ID. Okay, something like this, and I can have ID as 1, for example. Okay, this is JSON. And if you have any issues getting JSON created, so what you can do is you can head over to browser and you can search for JSON validator, something like this. You'll see this link, jsonlint.com. Go over here, and there's a fantastic tool to validate if your JSON is correct. Okay, so you can see JSON is valid. Okay, if there are any issues, like I miss anything, any sort of syntax error, you will immediately get an error. Okay, so this is done. I'll save this and I'll trigger this. So you can see category added successfully. And now let us get the category. You can see the category is being returned. You can see this is the new category that we have just added. Okay, so what we have done is, with the help of a post mapping, we have been able to create new categories into our API. And why did we make use of post? Because we wish to create new resources on the server. And we have a method which is helping us create that, but this has to be a post request because we also need to send like a request body over there. Okay, and post helps you do that. Okay, so I hope this was useful. This is how you can create the endpoint to get your categories created. Alright, right now we have everything being managed in the controller. So we have a controller where we are getting all the categories, and within the controller itself we are saving the category. An entire logic of getting and saving the categories is in the controller. There's no concept of service yet. Okay, now whenever you are building Spring Boot applications, it's best to have all the business logic in the service layer. So these are different layers where you have controller, and then you have service layer where all the business logic will reside. And controller should only be restricted to handling and routing requests. So it can handle the request, it will get the request, it will intercept it, and then depending on what the request is, it will call and it will work with corresponding service methods and classes. Okay, so what should we do now? All right, let's head over to our application and let us get started with the service layer. So what I'm going to do is, here I will need a service layer first of all. So for service layer, I'm going to have a package first. Okay, so here I'll say new Java class. I'll say service dot category service. So I'm creating a service subpackage within project. So com.ecommerce.project.service.category service. Okay. And I'll say enter. Okay. I'll add this to my version control system. Now the thing is here, I did one mistake. Instead of class, this should be an interface. Okay. I want this to be an interface. I can even have this as class, but why am I having a interface? Let me tell you that as well. So I'm making use of an interface to promote loose coupling and modularity in my code base. Okay. So what I'm going to do is I'm going to have an interface that is going to have the declaration of all the methods that I want to have. And then I'm going to have a category service implementation class that is going to implement this interface. And it is going to implement all the methods that exist in this interface as well. Okay. Why am I doing so? Like I said, I want to promote loose coupling, okay, and modularity in my code base. So having separate interface for service and a separate implementation of that service is beneficial in the longer run. Okay. So what I'm going to do is here, I'm going to have a couple of methods. Now, if you come over to category controller, here we have two mappings. One is to get all the categories and another one is to add all the categories. And we are managing this in a list, which is also residing here in the controller, right? So what I'm going to do is I'm going to come to service and I'm going to say, I want to have the logic of getting all the category. Okay. I want to get all categories like so. And this logic should reside in this method. Also, I'm going to say void create category. Okay, something like this. And I wish to have the logic of creating category also in the service class. I don't want to have anything. So controller should be like very minimal code. Okay. So this interface is done. Now what I will do is here in the service package, I'm going to create a class. Okay. And this is going to be a category service implementation class, IMPL. Okay. And this particular class, what it's going to do is it is going to implement, of course, the interface that we just created. The moment we implement the interface, you see all red marks. Interesting. I'll implement all the methods here. Okay. And we need to have the logic over here. Okay. Now, what we are doing is we are managing the list of categories here in the controller. I don't want to do that. Okay. I wish to have this logic instead over here in the service. So I'm going to cut this and I'm going to move this line of code over here like so. Okay. Now over here, I'm just going to return the list and I'm going to return categories here. And when creating category, I should add the category like this. Okay. I should add the category here. Okay. Like so. So the category is done. And what we can do is we can like get rid of this code. Okay. But we need to update this code, right? So what I would do is here, I need to call the service method that we have, like the corresponding service method, which I can make use of within the controller. Okay. And for that, I'm going to need an object of category service. So I'm going to say private category service and I'll say category. So it's category service like this. Okay. And I can have a constructor here, something like this. Okay. And here I'm going to say category service dot get all categories. Okay. And here I'm going to say category service dot create category. Okay. And this is how it will be. Okay. So the controller is set, the service is set, and the service implementation is also set. Okay. And let me run this and let us see how this works. So technically the logic should not change. Everything should work as expected. Okay. This is interesting now. Okay. See, we got an error. So we got an error here. What we are doing over here. So here I have created an object of service, right? And I've created a constructor. So I'm expecting Spring to inject this on the runtime, right? And for Spring to inject, it has to manage this, right? But if you go to service over here, is it managing? It's just a normal class, people. So I have not yet added any sort of annotation that tells Spring that, hey, you are supposed to manage this. Okay, I have not added any sort of annotation. So what I need to do is I need to come over here to the implementation class and I need to add a annotation called service, since this is service, right? And what this will tell is, this will tell Spring that, hey, you need to manage this particular component as a bean and you need to inject it over here. Okay, so during runtime, this automatically will be injected. And now if I run this, let us see this. It's working fine. And without this annotation, if you see the error message, let me run this without annotation. Okay. So if you see the error message over here, consider defining a bean of category service type. Okay. And it could not be found. And that is why it threw an error. Okay. The moment I add this annotation, the error is gone. So remember always to have this annotation like controller, service. These all annotations are important. Okay. So this is done. The application is up and running. Now coming back to our application, if you try to get all the categories, there's nothing. If you try to create a category, the category is created. 200 okay you are getting. And now if you come to get all categories, you should see the category that you have created being added. Okay. This is only one category that we are working with. You can save as many categories as you want and see the output over here. Okay. So if you come back to the code base here, okay, here the dependency is being injected in the controller, right? The service dependency. So what is happening is, this is the type of an interface, right? And this is not being marked as a service. Instead, its implementation is being marked as a service. So what happens is, during runtime, a type of category service is being injected over here. Okay. Now we are doing a constructor injection over here. If you want, you can get rid of this. So get rid of this like this, and you can make use of field injection over here. Something like this. Okay. And if you run this, this should also work absolutely fine. There are no issues as such. Okay. So if you come over here, if you try to get all the categories, it should work. Create the categories, it should work. Okay. And if you try to get the category again, it will give the result as expected. Okay. So yeah, this is about service layer, and I hope this was useful. In this particular video, we moved all the source code and logic that we have. So this logic is very simple right now. Okay. Very simple. We are just adding and retrieving categories, but this can go really complex and you can't manage all of this in controller. It's not a good practice. You should have all the business logic in service layer. And that is exactly what we did over here. So I hope this was useful. So now it's time that we take a look at a problem that we have in our application. And after seeing the problem, let's take that problem as a challenge and try to solve it by ourselves. Okay. So here I'm trying to get all the categories. Okay. I'm getting all the categories, and here I'm trying to create a category. So now let us say what happens if I don't pass in the ID. Okay. So let me add this and let me say send. You can see category got added successfully. Let me see what got added without a category. So you can see without category ID, we have this category added, but the category ID is null. Okay. You cannot have an application having unique identifier being inserted as null, right? So normally what happens is IDs are unique. Like if you have been into software development, if you are storing some data, then the ID field that you have in your application has to be unique value, right? For every data point you have. So here we have two categories and both of them should have unique IDs. Okay. Now the problem over here is why we have this as null, because of course we don't have validations yet, which is okay. But also another problem I have here is we are asking our user to enter the category ID. Okay. Normally category IDs, not category ID, IDs in general for any entity. Like if you are storing products, then product will have an ID. If you're storing orders, orders will have an ID. If you're storing users, users will have an ID, right? You need IDs to identify a unique data point, right? And normally whenever you are designing application, IDs are never taken as an input from user. Okay. So when creating something in your database or something in your application, we are creating a category here. You are not supposed to ask IDs. So the question is, if you're not asking for IDs, how are IDs being managed? So answer to this is IDs should be managed within the application itself. So you should have some logic wherein you should generate unique IDs, and whenever new category is being created, you should assign a new ID to that particular category. So coming to the challenge part, this is the challenge for you all. So what you can do is you can pause the video right now and head over to IntelliJ, and here in service, we are having a logic to save category, right? Now, before saving category, please add a way wherein the ID is auto-generated and it is saved within this list. So right now we don't have a database, but we'll make use of this list to generate unique IDs. Okay. So pause the video right now, attempt this challenge and get back, play the video and watch the solution. Welcome back. I hope you all had a chance to attempt this challenge. Let me head over to IntelliJ and here in the category service implementation. So what I'm going to do is I'm going to first create a variable which is of type long, and I'm going to say next ID. So this is going to keep a track of IDs. Okay. And what I would do is here, it's going to be a very simple solution, people. It's going to be category. Okay, so since this is a category that is being added, I'm going to say category dot set category ID. Okay, and I'm going to say next ID plus plus. Okay, so what I'm doing here is I have a variable first, which is private and it is keeping track of IDs. And then I'm setting the ID over here this way. I'm setting manually within the application, and ID is always incremented. Okay, so it will never overlap. And even if user is sending the ID over here, so let's say even if I send the ID over here, then too, this value will be overridden. You can see this value that user is sending will be overridden within the code or within the service class. Okay, and if you don't send, it does not matter. It will anyways be set. Okay. So let us test this. So what I'm going to do is I'm going to rerun our application. Okay. Application is up and running. You can see here. Okay. I'll come over here and let us set category ID as 10. Okay. And let me send this. Category is added successfully. If you come over here, if you try to get the category, you see 1 as the category ID. Okay. Let me skip category ID. Let us see what happens. It should ideally work fine. So I'll add the category. I'll try to get the category here. You can see category ID is 2 and category name is travel. So indeed, this is working absolutely fine. So we are managing IDs by ourselves rather than relying on the user to send us the right IDs. And this is one of the practice, whichever things like you need. So here we need a unique identifier for every data point, right? So unique identifier, you cannot trust user to give you a unique identifier every time he creates a resource or something in your database or application. So right now we are not making use of database, but in your application, if anything is being created, don't rely on user. Instead, have the logic to generate it automatically. Okay. So that's about how you can manage IDs in your application. So now we have been able to get all our categories and also add new categories if we wish to. Now it's time that we go further with the controller and add the delete category API over here. Okay, so we are going to add a new endpoint which is going to handle the deletion. Okay, so what we are going to do is I am going to first create a method. So I'm going to say public, and this should be like delete category. So I will be just deleting the category and returning the string. Okay, so I'll say delete category, and here I'll say long category ID like so. And okay, so this is delete category, and here instead of long category ID, so what we need to do is let us accept something from the URL. Okay, so I'll say delete mapping like so, and here I will have to define the endpoint. So I'll say API slash, this deletion is also admin, and I'll say categories slash, and I'll specify the category ID over here. Okay, so I'll say category ID. Okay, now here this is coming in as a path variable, right? So I need to specify path variable over here. Okay, like so. Okay, so what this will do is, since we have this dynamic value in the URL, it will map this particular parameter to this particular value over here. Okay, whatever is being passed. Okay, and here what I will do is I'll say string, I'll get the status, and here I'll say category service dot delete category, like so. Okay, and here I'll pass the category ID because service will need the category ID of the category that we wish to delete. All right, and then I'll return the status. Okay, now what I need to do is, we are getting a red mark over here. We need to create this method here. Okay, and the moment we create this method here in the interface, okay, it will be added in the interface, but in the service implementation, we'll get an error that you need to implement. So I'll implement this method. Okay, and you can see over here, we have this template for writing the logic of the method ready. All right, now what we need to do is, we have access to the ID of the category that we wish to delete. All right, so we have this list, and with the help of ID, we are going to get that particular category deleted. So what I'm going to do is, I'm going to say category, and I can say category is equal to categories. Now I can make use of this concept of streams in Java. Okay, so I'm going to convert this list into a stream. Okay, then I'm going to filter. So I can apply a filter, and I'm going to make use of this. This is like a little bit of functional programming over here. I'm going to say equals, and I'm going to say category ID. Okay, so we are checking for every category whether the category ID matches the category ID that we have received as the input. Okay, and then when we receive first over here, okay, so this is here, and then over here I need to say dot find first. So the first match that we get, that is something that we need to get. Okay, so what we are doing over here is, we are making use of the concept of streams and functional programming. So here we have converted the list into stream. Then we are filtering the list, or I should say stream over here, because list is converted into stream. So this filter is being applied on the stream that is being converted. And here for every category, I am like checking if the category ID equals the given category ID over here. And if it matches, then we get the first match, and we just take it and assign it to the category object over here. Okay, and then what we will do is, we will come down over here. We'll say categories. Okay, we need to make use of categories, which is the list, and we'll say remove, and I'll say category. So the reason we did this, or we got the category, is because we are making use of remove method on the list. Okay, and for remove method to work, we need the category object. So we are making use of this over here to find the category that the user wants to delete, because the user is only passing in the category ID, right? And then we return over here. So what do we return? We return a message. So we can say category with category ID, like this, and I'll say category ID. We'll add the category ID, in fact. Okay, over here, category ID, and I'll add deleted successfully, like so. Okay, and I'll add a space here. Okay, so this is done. We can rerun the application and we can get this tested. Okay, so we need to have this API over here. Okay, this is the endpoint. So if you scroll down, this is the endpoint. Okay, so I'll copy this and I'll come over here. We can do a duplicate of, let's say, this get over here, and here I'll say delete category, like so. And then here we'll do delete. And here I will paste the copied URL like so. Okay. Just make sure you copy it correctly, and then you can specify 1, 2, whatever you want, like whatever ID you wish to. All right. I'll hit save and I'll get this API saved, like endpoint saved. All right. Now let us get all the categories. We won't have any categories. Okay. We can create a category. So I create one category. If you try to get that category, you will get like category ID 1 and category name is travel. Okay. Let's try deleting this. So I'm passing in the ID as 1. And let me send this request. So it says category with category ID 1 is deleted successfully. Okay. So what I can do is let me check if it's deleted. Yes, it is. Let me create a new one. And let me check its ID. So the ID is 2. And you can see the category with ID 1 was deleted. All right. So I hope you have some clarity about how the deletion is being handled over here. Now here we might have a small problem. Okay, and let me tell you the problem. So here in delete, if I say category 11, like delete the category 11, and if I send this, you see we get an error. Okay, that's the problem. So because this particular category does not exist, right? So we get an error. How do we handle this? Okay, so ideally we should have a message that is returned over here. Instead of this message, we have a message returned if the category is not found. Okay. So what I would do is, here we are getting this category. We are finding the first and we are getting this category. I need to add one more method over here. I can say or else. So if this is not found, I'll say null. Okay. So what this will do is, now if the category is found, then it will return that category. If it's not found, then it will return null. Okay. And here I'll add a simple if check. I'll say if category is equal to null. Okay. Then what do we do? Return category not found, right? I'll say category not found, something like this. All right. Let us test this and let us see whether this is okay. All right. So let me rerun this. It runs. Let me create a new category. It's added. Let me get all the categories. It's there. Let me try to delete a category with 11. Okay. With ID 11. If I try to send this, you can see category not found. Okay. How does this work? This worked because of the check that we just added. Now, if I say category 1, it's deleted. Okay. Try to get all the categories, you can see there is no category. And if you try to create a new category now, you will get the ID as 2. You can see. So indeed, this is working. Just to reiterate on the logic that we applied over here. So here what we did is we want the category object that user wants us to delete. But user is only passing the category ID. So with the help of ID, we make use of the concept of Java streams. And we filter the list and we try to match by comparing every object's ID with the ID that we have got as the input. Okay. We find the first element and we assign it to category object. If the first element is not found, or if nothing is found, we say or else and return null. So if there is no category found, category object is null. Now, if category object is null, we return category not found and the function ends over here. This method ends over here. If this is not true, then we remove that category and we return this message. So this is a simple validation that we added just to prevent some unwanted errors. Okay, I hope this is making sense now. All right. So that's about the deletion process of the category, and I hope this was useful. So now let us talk about the response codes that we have been getting. All right. So we have implemented the delete functionality where we are able to delete the category. All right. Now the response code, if you see on the deletion, we are getting 200 OK. Okay. But if I try to delete a category that does not exist, so let me try to do that. You will see category not found, but the response is still 200 OK. Well, do you think something is wrong over here? Okay, the status code should have been
404 like not found, status code should not be 200 okay, right? So this is a problem right now that we have in our API. Okay, so what is happening is, even though the response is saying that it's not found or something like that, we don't have that being reflected in the status codes. Okay, and we need to make sure that the status code reflect as to what has happened. All right, so this is where I want to introduce you all to the ResponseEntity class. Okay, now ResponseEntity class is a wrapper in Spring that represents the entire HTTP response. Okay, so if you take a look at the response over here that we are getting, we have this message, we have headers, then we have status codes. So ResponseEntity in Java can represent the entire response over here. Okay, and you have the ability over there to customize the status codes, customize the response, and so on. So you are in control over there. Here you are not in control. We did not return 200 okay, but by default it's displaying 200 okay. We are just displaying the message. So we are not controlling the HTTP status codes right now, but we should control that, right? So what I would do is I would switch over here, all right, and I would head over to the service here. And when we are deleting the service, what we can do is, if the category is not found, what I can do is I can simply call an exception, or I can raise an exception, not call an exception, I can raise an exception, right? So here I can take this on the new line. Okay, so we are saying or else null. Okay, so I can say or else, you can see or else get, or else throw. So I'll say or else throw, and here we'll need a parameter. So we'll throw an exception. All right. So I'll say new response status exception. Okay. And here I'll also pass two parameters over here. Okay. So one is the status code and another one is the message. So if you hover over here, you can head over to the class. You can see like there are different implementations or the constructors available. So you can even specify the status code. You can specify the status code or the string. Now the string is the message. Okay, so we'll make use of this one. So what we'll do over here is I'll say here, I'll want to say not found. Okay. Now you'll get an error if you try to write something like this. So I want to pass 404 not found. Okay, that should be the status code. But you cannot access not found like this. You will have to make use of HTTP status class. Okay. And within HTTP status, let me take you to HTTP status. So this is a class. Sorry, this is not a class. It's an enum. I'm sorry about that. Okay. So it's an enum over here that is defined, and it represents the standard HTTP status code. It's enumeration. Okay. So it provides a set of constants that we need over here. So you can see over here, there are so many constants created. Okay. So this is for 201, 203, accepted 202. Okay. If you scroll down, you'll see 305, temporary redirect 307. So these are all the status code. 401, unauthorized. 404, not found. Okay, so we are making use of this. There are so many constants being defined over here. I'll just close this. Okay, so this particular thing like HTTP status is needed, and it solves a lot of problem. Like it brings in a standardization of status code. It enables us to make use of these status codes in our code like this. Okay, so this is much more verbose. Anyone reading this particular code will know, okay, I'm trying to throw a not found exception like 404. All right. And now the second parameter I'll pass in, I can say resource not found. Okay. So since the resource we were trying to access has not been found, we are throwing this as an exception. And now this check is not needed actually. All right, because we are directly throwing an exception, we are not assigning a null or something. All right, and let me run this. Let us see the output. We'll do one more enhancement, but for now, let us see the output of this. Okay, so here I have delete category. Let us try to delete a category that does not exist. You should see the error over here, not found, and you can see over here, this is a path. Okay, and you can see here we have the 404 not found message. All right. Now this exception was thrown, okay, but what is happening is we are not displaying the message over here, okay, and we can handle this in a better way. All right. So what we can do is we are getting 404 not found, that is being handled. So what we can do is we can come to controller. Okay. And since this line of code is generating the exception, so what I would do is I would say try. Let's put this in try catch. Okay. There's one way of handling it. And we'll say catch. And I'll say response status exception. Okay. So you can see this exception over here. And I'll say E over here. And here, what I can do is I'll make use of response entity, like I said. Okay. Now, response entity allows you to wrap the response and get better control over it. Okay. So I can say new. And I'll say response entity. Okay. Something like this. Okay. And here I'll pass in two things. I'll say e.getReason, like so. Okay, this is the reason that we get, and I'll say e.getStatusCode. All right, so this is something that I'm going to pass in over here. Okay, I'm getting an error. Okay, so the reason I'm getting error is because this is returning string, but I'm returning response entity now. So I'll have to specify response entity over here now. All right, so this is what it will return. But the problem is now the internal thing, like this return thing over here, this is returning status. Okay, so what we need to do is I will do some modification over here. And here I'll say return, and instead of status, I'll say new response entity, something like this. And I'll pass in the status. So this is a status that the message that I'm getting from the service. And then I'm going to say HTTP OK, HTTP status dot OK, like so. All right. So this looks good now, and let us restart and let us see how this works. All right. Ideally, it should give us the result over here that we are expecting. Let me do a send over here. You can see over here, if the category is not found, you get this, that is resource not found, and you're getting 404 over here. How are you getting 404? You're getting this from here because of this line. Okay. So we are wrapping the response that we are getting, and we are sending in the status code over here. So we are getting the status code over here from this exception object, and we are just passing it to the response entity object. Okay. And same goes for the creation part. So if not creation, deletion. So if I create a category, and if I try to delete a category with ID 1, you can see it works perfectly fine. So deletion and the validation part are perfectly handled now with status codes. I should mention that with status codes. So handling this with status codes is really important. Okay. With string, you can handle easily. Okay. You can just return the string. But now what we are doing is we are having a grip, a proper grip over the status codes. Now, if you would ask this question, like why are we using response status exception? So response status exception within the service method, like we are making use over here, is a way to handle HTTP specific exceptions directly. Okay. And you can communicate the exception with message and meaningful status codes. So if you want to communicate something to the client with a proper message along with the status codes, you should make use of this. So we are making use of this, and I've shown you the demonstration for the same. So that's about response entity class and how you can make use of response entity to get a better grip or better control over the response message and even the status codes. Because like I said, even status codes are really important. So now that we are making use of response entity for deleting the category, let's propagate these changes across all the endpoints. Okay. Now, before doing that, I would like to talk a couple of more things about response entity. So here we have made use of this syntax, right? This is one syntax. Okay. So what I'll do is I'll show you a couple of more ways of how you can make use of response entity. So let's say this code over here. Okay. You can even say response entity, return response entity dot status, or instead of status, I'll say okay here. Okay, so since you want to return okay, you can say okay. If you want to return let's say bad request, you have bad request over here. If you want to return created, if you want to return not found, you can use this. So there are different methods which you can use. Okay, so if you want to return not found, you can use this, you can see. So I'll say okay, and instead of passing HTTP okay over here, I'll just get rid of this. Okay, and here, okay, so this is giving us error. Why is it giving us error? It's string, right? Okay, so it's giving us error because this won't go in as object. Okay, so this is a static reference. You say ResponseEntity.OK and just pass in the status. This is one way of doing things. Okay, and also show you one more way over here. So okay, so what I'll do is I'll say new response entity. We don't need new again over here. I'll just remove this. Okay, response entity dot status. Okay, so I'll say dot status over here. So you can see you can pass in the status and HTTP status code over here. Okay, so I'll just simply say status. Okay, and I'll pass in the status code. Okay, so what I can do is I can say HTTP okay. Okay, and then I can say dot body and I can say status over here, something like this. Okay, this is also valid and it will work perfectly fine. So we are saying response entity dot status, and then we are passing in the status over here, like whatever status we get, and then within the body we are passing in this message, the message that we want to display. All right, so these are multiple ways of doing the same thing. So if you just happen to learn more about this, if you Google this response entity, you might see code written in different ways. Okay, but this one that I wrote in the beginning, this is the most common one. All right, so this is done. Now let's head over to other endpoints. Now over here, I'll just say return new response entity over here. I'll say category added successfully. And here I can say HTTP status. And for this, I can simply say created over here. Okay, created because this is like we are creating something, like we are creating a resource, right? We will get an error that this is not matching the return type. Okay, so what I can do is I can take a look at more actions and okay, so we need to change the return type over here. So I'll say response entity and I'll say string like this. Okay, all right, this is done. If you come over here, we have one more API over here where we are getting all the categories. So what I'll do is I'll say extract to a variable. So we have this variable where I'll assign this category. Okay, and here what I can say is again I'll use the same syntax. I'll say response entity here and I'll pass in the categories and I'll say HTTP status dot okay. All right, so now this brings in everything in sync. Okay, and here I can say response entity list, and here I can bring in response entity list, and here I can add this. Okay, this is done. So all the APIs are now in sync. I'll restart the server and let's check if everything works fine. All right, so we come over here. I'll say create a new category first. It creates the category. Make a note over here, 201 created. Okay, this is something that we have added custom. Get all categories, you get 200 okay, and you can delete the category, you'll get 200 okay. You can look for category that does not exist and you will get 404 not found. All right, so I hope this is useful and I hope you have understood as to why we bought everything in sync. Okay, it's good like if you have this controller in sync and all the endpoints should be in sync. All right, so I hope this was useful. So now it's time that we talk about updating the category. We have the endpoints for creating, getting all the category and even deleting. All right, so let's go over here. And what we need to do is we'll begin by writing in a method first. Okay, so I'm going to say public, and of course now we are going to make use of response entity. I'll return a string. I'll say update category. Okay, and I'll pass in the request body. Okay, so we will have the updated request body come in the request, and I'll say category over here. Okay, something like this. So this will resemble like the create category. Okay, and I'll just copy this here, and instead of post mapping we will have put mapping, because we are like updating the category, right? And I'm going to do over here is I'm going to have a try catch block. All right, and then we are going to catch, and we are going to say response status exception E, and I'm going to have a similar code over here, right, which I've written over here like so. Okay, and then over here, let me like get this part here. Okay, and I'll paste it over here. So instead of delete category, I'll say update category. Yes, this method is not there yet. We need to create the method. Okay, and I'll pass in the category object over here. Okay, and this will give us category. So once the category is saved, it is giving us the category as the response. Okay, so I'll say saved category, something like this. Okay, now what we need to do is I will remove this here. Okay, and I'll get rid of this as well. Okay, we don't need this. I'll just remove this, and here I'll say like response entity category with category ID saved. Okay, we can even craft this message in the service, but I'm just crafting it over here. Okay, now the thing over here is we are updating the category, right? So here, if you see this table, we remember that this was the endpoint. Okay, so we need to change the endpoint a little bit, and here we have the request body as this, but we also need the request parameter. Okay, so what I will do is I'll come over here. Okay, here after categories I'll have categories. Okay, something like this, and I'll also accept the category ID. Okay, so this will be category ID, something like this, and here I'll say path variable. I'll say long category ID. Okay, like so. All right, let me move this to a new line so that we get a better view. Okay, you can see over here. All right, and if you scroll down, update category, we are passing in the category. We'll also give the category ID since we have it. Okay, like so, and here I'll say this category ID is been updated, and I'm passing in the HTTP status. Okay, so yeah, this looks okay for now. Is there anything that we are missing? Not right now. Let us now go ahead and create this method. Okay, and what I'll do is in the service implementation, I'll get this implemented. All right, we have this implemented now, and what I need to do is I will have some code over here to update the category. All right, so first of all, I'll say categories dot stream, and I need to find the category first, right? So I need to find the category in the way that we have done over here. Okay, so let me get this code over here. Let me copy this so that we can save a little bit of typing, and we'll come over here, category, and I'll say, so over here what we need to do is find first, and this can also give us null over here, right? Or wait a minute, so I'll just remove this. We don't need this here. Okay, so now we can either do find first dot get over here. Okay, and this will give us the category. Okay, but the thing over here is with get, it will give us the category, but I don't want the category. I'll get the optional over here. So if you take a look at the find first method over here, it is returning optional. Okay, so what I will do is I'll change this type to optional, and I'll say category, and I'll say optional category, something like this. Okay, and I'll remove this over here. Okay, so we have an optional of category, which will have a category if category is returned by this, or if it does not have the category found, it will give us null over here. Okay, and we can have if, and I can say over here optional category dot is present, like so. Okay, and I'll say category over here, and I'll say existing category, So we have the existing category over here from the optional object. Okay, so I'll say optional category dot, I'll say get. Okay, remember we can make use of get over here as well in the end. But if the category is not found, we get an error. So rather than throwing an exception, I'm just getting the optional and I'm evaluating if the optional is present. Like, is there any value in the optional? Okay. If there is any value in the optional, what I will do is I'll say existing category. Okay. Existing category dot set category name. And I'm saying category that we have received as the input. I'll say category dot get category name. So this is the category that user has given us with the updated details. Okay. And then after update, I'll say existing category dot, or I won't say existing category dot, I'll just return existing category, something like this. Okay. So I hope this makes sense. So now since we are done with the update of the category, I need to add else condition. Like, what happens if the optional is not present? So if the optional is not present, what we can do is we can simply throw this exception over here, right? I can just copy this and here I can simply say throw, and I can like say this thing over here. Okay, so resource not found, or I can say category not found, something like this. Okay, so this is another way of doing things rather than doing this part over here. So here we separated things into if else because we wish to like have the update part here in the if statement. Okay, but you can even go ahead with this way where we do or else throw. Okay, and then you update the category if the category is over here and if there is no exception. Okay, that is also another way of doing things. But yeah, I'm just showing you multiple ways of doing the same things. Depending on your requirement, you can choose the one. Okay. Now, there is something that we are missing. We are missing a semicolon over here, and I should also get rid of this null over here. Okay, this is not needed. So I'll start this. Okay, let us run this application. The application is up and running. I'll come over here. I'll create a new category. I'll try to get all the categories. We have this category created. Now let me create the put mapping. So I'll duplicate this because put request is similar to the get, sorry, not get, the post request. I'll say category /1 over here. Okay, that's the structure. Within body, I'll say travel, update it here. And remember to update the request type to put. This is important. If you keep it to post, you get an error. Okay, because this URL does not accept post request. It needs a put, right? That is what we have defined. So if I send this, you see category with category ID 1. Okay, this message needs to be changed. You should say updated category with category ID 1, but that's fine. I'll also rename this update category. Okay, and I'll save it. If you come over here to get all categories, and if you try to get, you'll see that the category name is updated. All right, so it's working absolutely fine, and I hope you have been able to follow. Let us now talk about the request mapping annotation. So what is request mapping annotation? Where all can you use it, and what are the use cases? So that is what we are going to discuss. So if you take a look at our controller class, okay, I'll show you a pattern right now. Okay, so every endpoint that you're seeing has a part common in it, right? So you are seeing over here /API/public categories, API public categories, API admin categories, and category ID. So this visibility is changing, like public, or whether it's admin, this is changing, but the API part is constant across, right? And this thing is getting repeated across all endpoints, right? So what you can do is you might want to have a controller class, and at the class level, you can have a definition where you mention that, hey, all the mappings that I have defined in this particular controller class begins with /API. Okay, and then you can skip the /API part in the definition at the method level. Okay, that is something that you can do with the help of request mapping. Okay, so that is one use case, and that is when you use request mapping at the class level. Okay, so you can use request mapping one at class level for this particular purpose. Another use case of making use of request mapping is to specify the mapping over here, endpoint, or defining it. Okay, let me give you an example. So here I have a get mapping annotation used. Okay, instead of get mapping, post mapping, delete mapping, you can use request mapping for all. So I can say @request mapping here. Okay, and here I need to say value. What is the value? So it will take two parameters. One is value and other one is method over here. Okay, method will say that it is get. So I'll say request. Okay, request method over here. You can see request method has a lot of options. So let me type in request method completely dot, and now you can see get, delete, put, post. So whatever we are defining, we can specify over here. So this is a get request. I'll say get, and what is the value? So value is this, right? So I'll take this value and I'll paste it over here simply, and we are done. So this is equivalent to this thing over here. Okay. So instead of this, we can even make use of this, and let us test this, whether this works fine. Or what we can do is let us replicate this across a couple of endpoints over here. Okay. So we'll get a better sense, I'll say. So here you can add this, and let me comment this post mapping over here. Okay. And you can say here request mapping dot post, something like this. And here the API is same. Okay. So the endpoint is same. Right. So let me run this and let us see how this behaves. Okay. So you can see the application is running successfully. I'll come over here to create a new category. I'll say the category is added. You can see it's successful, and getting all the category also works normally. Okay. There is no issue as such. So this is an alternative. Request mapping is an alternative, and you can use it with methods instead of having the specific request mapping annotations. Okay, so these are the specific annotations depending on the request. Okay, so that is what you can do. So yeah, this is one use case where you're using request mapping at the method level. Now I was talking about the class level. So at the class level, what you can do over here is, okay, here I can simply say request mapping. Okay, and here I can have a definition like this. I can say API. Now what this tells is all the endpoints in this particular class over here, whatever is defined, start with /API. Okay, so instead of having /API everywhere, you can just get rid of that part like so. Okay, I can just get rid of that part like this. All right, and this makes your class or the endpoint definition look a little bit cleaner. Okay, and let me run this. So it will run the same way. Okay, what we have done is we have the definition at the controller level. Okay, it's running, and here you can see getting all the categories, it's giving empty, creating all the categories, it's working fine, and you can see. So everything is working fine. Okay, but this is one more way of doing things. Okay, so if you have a controller, okay, and if you want to set a specific URL pattern to a particular controller, then this particular mapping is helpful. Okay, so what this enables developers to do is they enable developer to set a URL pattern that controller will handle. Okay, so this is useful in teams. So I'll tell you, like if you're working in a team or if you have multiple people working on a same controller, what would happen is you might have developers defining URL their own way. So you as a developer can set a request mapping at the controller level. Okay, and the rest of the people can have the definitions over here for the respective endpoints that they're working on. So yeah, that's request mapping, and you can see over here there are two ways of doing the same thing. So I'll just revert to the old way as to we were making use of these specific annotations. Okay, so I'll just switch to that. Okay, so that's about request mapping, and I hope this was useful.
Hey there, welcome to this class where we are going to talk about data and databases. So think about this. Imagine you have tons of files and documents in your room and you want to keep track of all of them. Well, one way is you dump all of them into a pile on your desk, and if you wish to find any data about a specific piece of information,
you will have to scan through each and every file and each and every folder. Well, this is not realistic and also not efficient. So what's the solution? Solution is to use something called as database. So you can think of database that can organize information and data for you. So what is data? So data is anything that you need to store that can be referenced later on. And database can help you organize a large amount of information. Now let us assume that we are building an application wherein we are populating the list of jobs and displaying it to our users. But how do we manage the list of jobs that are being displayed to the users? So one way is we can hardcode all the jobs in our source code, which is not at all scalable, or you could use something called as a database. So database here stores all the job information that your application needs. And whenever anyone from a computer or a mobile phone tries to access your application will fetch the data from the database and share it with the user, whoever is accessing. Now, whenever a new job is added to your application, the job is saved into the database and it is not stored in the application. So you can think of database as something that exists behind the scenes and it stores all the data that your application needs and it also organizes it. Now, any modern website you visit has persistent and dynamic information that is being shown. For example, if you visit Amazon and let's say if seller adds a new product or if seller changes the price, so users searching will see the new product or the new price immediately. If you post a review on a product, other users will start seeing that review posted by you. And this is because the information is persistent and completely dynamic. Now this happens because the information is being stored in the database like we are seeing here on the screen with our job application. So database is a place where data related to your users or product is stored, and databases are typically used to store and maintain the state of your application. Now, if you're using Facebook, you upload your profile picture, right? And then you log out. Now, if you come back to Facebook after a couple of days, you are going to see your photo is still there on your profile. Now here, Facebook stores the photo into the database so that it can show it to your friends. And this information is persistent, which means that it does not go away if you go away. It is being stored in the application forever unless and until you delete it. So that's databases for you. Now, if we have to define the database, so database is a place where data related to your users and products is stored. Now, what are the types of databases? So there are two types. One is relational, and then you have non-relational database. So what is a relational database? So relational databases have a structure similar to that of an Excel spreadsheet. So here I have an Excel which is showing me the data around car rentals. So you can see over here, I have rental ID, car make, model, period, and price. Now this information is structured, and you can see over here, we have rows as well as we have columns. So these are columns, and then we have rows as well. And this information is called as being stored in the form of tables. So here the data is structured, and the structure of the database is known as schema. So this is about relational database. Now, there is something called as non-relational databases as well. Okay. So what does non-relational database mean? So non-relational database is completely opposite of relational database. So relational database have a structure, but non-relational database does not have a structure. And they are often called as NoSQL databases. Okay. So they don't have a tabular structure, but they store data in a different format, which is known as a JSON format, wherein you have key value pairs where the information is stored in them. So that's about the introduction to data, databases, and the types of databases that exist in the market today. Hey there. So welcome back. Let us get started by talking about DBMS. Now DBMS stands for Database Management System. So we have a database wherein our data is being stored. Now we need someone to create, maintain and control the access to the database. And that is where DBMS, which is a software known as Database Management System, comes into picture. So what is DBMS? So you can think of DBMS as an interface between the user and the database. It makes it easier for us to interact with the database. So it's just an interface that sits between us, the user, and the database. Now, DBMS serves a lot of critical purposes like data abstraction, efficiency. It provides a way to add security and even enable us to do backup and recovery of our databases. So DBMS provides with all these functions. Now, there are different DBMS softwares that are available in market. The number one is MySQL. So this is an open source DBMS, which is Database Management System. And this is easy to use and great for many applications out there. Then we have Oracle database, which is again a relational database, and it is being used in large systems and high demand environments. Typically, it is being used by enterprise customers or enterprise companies. Then we have SQL Server, and the company behind SQL Server is Microsoft. So company behind Oracle database is Oracle, and SQL Server, it's Microsoft. So it's a relational database management solution that is also being used by many enterprise customers out there. And these enterprise companies use SQL Server to store and manage their data. Then you have MongoDB. So MongoDB is not a relational database management system, but instead it's a NoSQL database management system. So it works with NoSQL databases and it is great for handling large amounts of unstructured data if you have in your company. So this is MongoDB, and then you have Cassandra. Now this is again a NoSQL database that is designed for handling the large amounts of data, and it is known to provide high availability with no single point of failure. So these are the different database management systems that exist in the market, and they are categorized into relational as well as non-relational databases, and they have different companies behind them. Now let us talk about the types of database management system. So the number one type is Relational Database Management System, which is also known as RDBMS. And then you have NoSQL Database Management System. So Relational Database Management System will work with the relational databases, wherein the data is stored in a structured format like rows and columns, and data is also organized into tables. And there will be relationships between different tables based on the common fields and so on. And common examples of this type of DBMS is MySQL, Oracle, and SQL Server. Then we have a NoSQL database management system which works with NoSQL databases, which means that here the data in the database is not stored in the structured format. So there's literally no structure, and the data is typically being stored in a JSON-like format, okay? And you will have data being represented as key value pairs over there, okay? So the popular database management system that work with NoSQL database are Cassandra and MongoDB. So these are widely used, and they are typically used in environments where you are not sure of the kind of structure that your data is going to have, okay? So these are the different types of DBMS that exist in market. So that's about DBMS, and I shall see you all soon. Hey there, welcome to this class, and let us start talking about the relational database concepts. So there are few terminologies that exist when we talk about relational databases, and they are table, column, and a row. So let us start talking about what each one means. So what is a table? So a table in a database management system or a database is used to store a data in the same way as a kitchen table is used to keep food and drinks, right? So that's a good analogy over here. And a database table is a structure that organizes data in a structured and an organized way. And it will consist of rows and columns, much like a spreadsheet. So this is a table, and you can see over here we have column 1, column 2, column 3, and column 4. And along with columns, we also have rows, wherein we have row 1, then we have row 2. And here we will have all the data that will be stored. Now this is structured over here, and this is known as a row, tuple, or a record. So there are multiple terminologies to refer to a row. So it may also be referred as tuple or a record. And then you have columns like this. Okay. So let us take a look at this example over here, wherein we are storing the car rental information. Okay. So you can see over here, we have the rental ID, car make, model, period, and the price. So here you will see you have columns which is used to store a particular information about a particular rental. For example, this particular column here is being used to store car make. This is being used to store car model. So column is representing a property of a rental. And these columns may have different data types. So for example, this will be a number, this will be a string of characters, this will be again characters, and rental period can even be date or it can be an integer. And rental price over here is also a number because it is representing a currency. So there will be situations wherein you might also want to store dates in the databases. For example, order date, or when was the last order date of a user. So all of that could be stored in the form of the dates. And here then you have a row, tuple, or a record over here, which represents a specific rental information. So for example, this highlight over here is for the rental 3, as you can see, and this entire record over here or the entire row is representing a single rental information. So to summarize, row represents a single rental information and column will represent a specific characteristic of any given rental. Now let us take a look at this column over here, which is rental ID. So this rental ID is a key or a unique identifier for every rental that exists in this particular table. Now the question is, why do we need a unique identifier? So like its name says, unique identifier is used to uniquely identify any given rental at any given point of time. Now there might be several operations that you might want to do. So you might want to fetch the rental, or you might want to fetch this particular rental over here, let's say. So the rental with ID 2. Now, how are you uniquely going to identify this rental given that rental ID does not exist? Okay, so let's say rental ID does not exist and you wish to get this particular rental over here. So one way is you could filter the table or the database with the car make as Jaguar. But there is possibility like this car make could be duplicate and it could be spread across different rentals. So you might not be able to uniquely find out this rental information. And hence to identify every record, you need a unique identifier. For example, let's take an example of an e-commerce store and you have an customer information. So you have a table wherein the customer information is being stored. And let's say you have a customer named John and John wants to update his city. Now to update his city, you will have to first find a record of John in the database and then update the corresponding city to that particular record. Now the question here is, how are you uniquely going to identify that this particular record represents John in the database? And for that, you might want to use the name, okay, but John is a very common name and there is a possibility that you might have multiple people with the same name as that of John. And you might even end up updating city of a wrong person out there, okay, or a wrong customer. And this is where primary keys are helpful. So with the help of primary key, you can uniquely identify a record in the database. So this unique identifier in the world of databases is known as a primary key. Now every table in the RDBMS should have a primary key. So these are the different terminologies in database management system, and I hope you all enjoyed it. Hey there, welcome to this class. So let us start talking about SQL. So you have all the data that is being stored now in the database. Now the question is, how would you actually access or retrieve the data from the database? And this is where SQL comes into picture. So SQL is used to query the database and retrieve the data that you have already stored. So SQL is a language that is used to talk to the database. So you can define SQL as structured query language, which is used to manage, update, and retrieve the data from the database. Now SQL is a programming language that is specifically designed for managing, updating, and manipulating relational databases. And it was developed in early 1970s at IBM, and it is being used by data analysts and even programmers to access the data that have been stored in database. Now SQL in relational databases is used to perform a wide array of tasks which can be categorized into a few major types. Now like I said, data from the database is retrieved with the help of SQL queries. So whenever you write a SQL command, it is known as a query. So with the help of a SQL query, you talk to the database to help it understand what you want, and the database will revert to you with the relevant data. So that is what an SQL query is. Now there are different types of SQL queries, and there are a few broad categories that we should be aware of. The number one category or the number one type is DQL or data query language. And this is probably what you think of when you hear SQL, like fetching data from the database. So data query language is used to query the database to retrieve the relevant information. So it is used for retrieval purpose, and it consists of select statement, which is one of the types of statements that exist in the SQL language. Then you have DML. Now DML stands for Data Manipulation Language, and this allows you to modify the data in your underlying tables. And you can make use of different statements within DML. Then you have DDL, which stands for Data Definition Language, and as its name suggests, it is used for defining the structure of your database. Then you have DCL, which is Data Control Language, which is used to control the access of data and the database. So it is used to essentially grant and revoke permissions. So TCL stands for Transaction Control Language, which is used to maintain the consistency of the database and manage transactions. So these are the different types of SQL queries that exist. And like I said, queries are nothing but the command that you write to retrieve the relevant information that you want from the database. So that's about SQL and everything you need to know. Hey there, welcome to this class. So let us begin installing MySQL on our Windows machine. So I'm going to head over to my browser and I'm going to head over to google.com. And here I'm going to search for MySQL. And you will see this first website appear over here, which is mysql.com. So this is the official website for this particular software. So I'm going to click on this particular website and you will be taken to this website over here. So this is a logo that you should see. So you can go through the official website and the details over here. You can read more about who are the customers that are using MySQL and so on. But since we are here to download, I'm going to click on downloads over here. And if you scroll down here, you will see different download options over here. So I'm going to say MySQL Community GPL Downloads. And I'm going to select this. Now, once you select this, you will be again presented with multiple options over here. So I'll just select MySQL Installer for Windows. So I'll click on this and you should see this page over here, which talks about the installer version. It talks about the version here, like the drop down, and the operating system. So I'll just keep these selections over here. Now, if you scroll down over here, you will see these two options. So this is Windows x86 32-bit, and this is also a similar one. But the difference is over here. So this says MySQL Web Community, and this says MySQL Installer Community. Now, what is the difference over here? So Web Community version is the online installer, and you need to download to connect to the online server over here with this version. But this is an offline installer. Okay, so I'll go ahead and I'll download this version over here. Now, when you click on download, you will be shown this particular page over here, which is asking you to log in or sign up for a free account. So I don't want to do that. So I'm just going to say no thanks, just start my download. You can alternatively create an account or sign up over here. Now I just said no thanks, just start my download, and I have downloaded the installer over here. It is saved on my desktop. Now to begin the installation, I'm going to double click on this. So this is going to show you such window over here, and it is going to say please wait. And you might see this pop up over here, which is asking you if you want this app to make changes onto your device. So I trust this app, so I'll say yes. And this is going to ask again, so I'll say yes over here. So here now you are going to be presented with the choose a setup type screen, wherein you are being asked to choose the setup type. So you can either install the server only, so this is just going to install the MySQL server, or you can have the client only. So you can have the client only version wherein you can install these three components like MySQL shell, router, and the workbench. So shell is nothing but the interactive command line interface using which you can query the database. You can have a router, like this is like a router daemon for your database, or you can have MySQL workbench. So this is like a graphical user interface using which you can connect to the database. So with this setup, you install these three components, and with full, you install quite a few components like MySQL server, MySQL shell, MySQL router, workbench, and so on. Okay, but what we are going to do is we are going to say custom, and we are going to go next. And now here we will be asked to choose the products over here. So I'm going to click on MySQL server here. Okay, and I'm going to get the MySQL server. I'm going to install MySQL workbench over here. So let me expand this a bit. And I'll install MySQL shell over here. So MySQL server is nothing but the SQL database that we are installing. So this is the MySQL database server that will be installed on our system. MySQL shell is nothing but the command line interface using which you can connect to the database and write SQL queries right from within the command line. Okay. And MySQL workbench is the graphical user interface using which you can connect to the database. So I'll say next over here. You'll see these three components. Okay, they are ready to install. Okay, if you just don't want these three components and if you want everything to be installed, you can just choose full option on the choose setup type screen. So that is also perfectly fine. Okay, but I have chosen only these three components because this is what we are going to need. and I'll say execute. Now the moment you say execute, you will see the progress happening over here. Okay, and you will see the status like complete. It's saying installing, and this is ready to install. So we will wait for a while until this process completes. So the installation for these three components have been successful and complete, as you can see over here. Now we'll click next, and you will see that we now need to do the product configuration. And you can see over here, MySQL server is ready to configure. So I'll say next over here, and you will see this configuration screen appear over here. So here we are going to select the config type as development computer. You can click on this and see the different options that you have over here along with their descriptions. But we will have the development computer selected over here. TCP/IP is the protocol that we will have checked. So this is by default checked, and we have the default port number as well on which our server will be running. So we'll keep this as it is and we'll say next. Now on the next screen, you are going to be asked to select the authentication method over here. So we'll just select the first option over here and I'll say next. Now here you will be asked to mention the MySQL root password. Okay, now root is like an admin account that you have in the database. So you need to choose a strong password over here. So I'll enter the password of my choice. So I'll say, so you can enter the passwords of your choice and just make sure that they match with each other and they are strong. Okay, so you will see this password strength indicator appear over here. Okay, so my passwords are strong and they match with each other. Then I'll say next over here. Now on the next screen, it will ask you to configure the Windows service to start the server. So I'll keep the default setup over here. And what this means is that MySQL server is being configured on my system as a service. And the service name is MySQL 80. And it will start the MySQL server at system startup. So if you're unchecking this, just make sure you go to services and start the service manually. Okay, and I'll say standard system account over here. So I'm just keeping the default selected over here and I'll say next. Now over here, it is asking for some permission files over here. So I'll say next, and it will ask me to apply the configuration on the next steps. So if you are okay with everything, you can say execute over here. And once you say execute, it will start executing these steps. So these are the steps that you are seeing on the screen. So it will start writing the configuration file, update the Windows firewall rules, and so on. Okay, it will initialize the database, start the server, and so on. Okay. Now, if for any reason on this particular screen, you said start the MySQL server at the system startup, and if you unchecked this, so if you uncheck this, you need to start the service manually. And for that, you need to go to start and you need to search for services. And here in the Windows services, you need to search for SQL, like MySQL over here. So right now it's not coming over here because I have not yet installed the service. But once you install it, it will appear over here. Okay, and you need to right click and say start. Okay, so I'll just close this. I'll go next, next. And I'll say execute over here. So this will take some time depending on your system performance. So we'll wait for a while and the configuration operation has been completed. So you can see everything is ticked in green and it's all done. Okay. Now I can say finish over here. And you can see the product configuration. We will now walk through a configuration wizard for each of the following products. So I'll say next again over here. Okay. So on this particular screen, it's telling you installation complete. Okay. And it's showing you two options here, which are by default checked. Okay. So I'll say finish over here and you will see this shell prompt open over here. And also this application opens up, which is MySQL Workbench. So this thing over here, this command line is the shell prompt using which you can write SQL queries. And this is something that we have installed. So you can see the path over here is C, program files, MySQL, MySQL shell 8.0, bin, and MySQL sh. So this is a path where this particular file resides. Okay. So I'll just say quit over here, like close it. And you can see this particular interface that opens up, and this is MySQL Workbench. So we have installed MySQL database onto our system along with MySQL Workbench. So MySQL database is a database server, and to connect to the database server, so it does not have a interface. So we need a separate software which is also provided by MySQL, and it is known as MySQL Workbench. So we will be making use of this particular software, and you can read the description here. Okay. So we'll be making use of this software to connect and work with our database. Now, MySQL is installed on our system as a service. And to confirm that, you can go to services. In start, you can search for services. You can go to M over here, the letter M. And here you will see MySQL 80. And this is running, and this is automatic. So startup type over here is automatic. So during installation, if you have specified that you don't want MySQL to start automatically on system start, you will have to come over here and right click and say start over here. So right now it's started for me, so I don't have the start option, but you will have to come over here and do the start. So I'll close this. Okay. And this is MySQL Workbench. So I'll go full screen with this. Okay. And you will have this software installed. So you can search for MySQL. So you will see MySQL Workbench, MySQL Shell. Okay, so there are different MySQL related tools that we have installed. So we will be making use of MySQL Workbench going forward to connect, work with the database, and also to write the SQL queries. Okay, so now you can see over here, you have an option here which says MySQL Connections is showing you like all the connections that exist onto this particular software. So here you are seeing one default connection, okay, which already exists. You can click on this and it will ask you for the password. And you can see over here, it is connecting to the service, which is localhost:3306, which is where we have installed the database. It says user is root. And password, it is asking to enter the password over here. Okay. So if you close this and if you right click on this and say edit connection, you can see all the information about this connection over here. So the connection name is local instance MySQL 80, which is what you see over here. And the connection method, host name, port, username, and the password that you are entering over here. Okay. So I'll say close over here. You can even add new connections by clicking on this plus icon over here, and it will open like setup new connection wizard. All right. So this is about connections. So I'll just click on this default one and I'll log in using the root user. So here we need to enter the password that you had set when installing the MySQL database. So I'll enter the password. So the password is entered and I'll say OK. So the moment you say OK, you're going to be connected to the system over here. Okay. And you can see over here, like this is the screen that you get after logging in. So with this, we have successfully configured MySQL Server, MySQL Workbench, and MySQL Shell onto our system, and we are ready to write database queries. All right. So that's about the installation process, and I shall see you all soon. Thank you. Hey there, welcome back. So let us take a look at how you can install MySQL on your Mac machine. So here I am in the browser on Google, and you need to search for MySQL over here. The moment you search, you are going to be presented with a list of options with this first website over here, which is mysql.com. Now this is the link to the official website, and you can go over to this website. You will see this official logo of MySQL coming in over here. Okay. So you can go through this website. You can read more about MySQL database here. You can also take a look at like who are the customers who use MySQL today. Okay, you will have all the information appear over here. Okay, but since we are here for installation, I'm just going to head over to downloads, and I'm going to just scroll down a bit. Now here, if you scroll down, you're going to see this option here, MySQL Community GPL Downloads. So I'll just click on this link over here, and you will again see a lot of download options over here. So these are the different tools that MySQL has to offer. Okay, you have Workbench, Shell, Router, Community Server. So what we'll do is we'll click on MySQL Community Server, and you will be shown this particular page where you will see macOS is by default selected under operating system. Okay, so if it's not selected, you can just click on this and select the operating system macOS, and you can have the latest version selected over here. Okay, so now here you can select the different OS version over here. So you have options like macOS 13 ARM or macOS 13 x86. So ARM is for Apple-based chips. So if you have your Mac machine which makes use of Apple-based chips like M1, M2, and so on, you can select this option. Or if you are using a Mac that is making use of Intel-based chips, you can select this x86 option over here. Okay, so based on that, the filter will change. Okay, you can see, and you can also select all, and you can see the different versions that are available over here. So you have ARM version, x86, and then for these two architecture, you have different types of installers. Like you have DMG archive, you have compressed tar archive, and tar files. Okay, so since I'm on x86, I'm just going to download the DMG version by clicking on download over here. Now, the moment you click on download, you will be asked to log in or sign up over here. Okay, so I don't want to do that. You can optionally create an account and stay updated with all the information that MySQL has for you. But I would just say no thanks, start my download, and it will begin the download. And I have already downloaded this particular software here, so I'm not going to download again. I'm just going to go to my downloads, and you can see this download happen over here. Okay, so in order to begin the installation now, you need to double click on the installer, and it will begin the installation process. So installing MySQL is pretty simple, like it's just like any other software, but there are some options that you need to select, which we'll take a look now. So once you click on the DMG download, you will see this page open, which will have .package files, and if you click on that, you will see the installer open up, and it will ask for permission. This package will run a program to determine if software can be installed. So you can say allow, because we've downloaded this from a trusted source on our system. Okay, so you can say allow, and you will have a series of steps that you can go through that you can see here on the left hand side, like the introduction, license, destination, and so on. So I'll go ahead. Okay, you have the license agreement, which you can go through if you wish to. I'll just scroll down and I'll say continue. You can optionally read this, and here again we are getting an agree pop-up, which I'll say yes. Now it will show you the installation type over here. So it is doing a standard install on my computer, and it is taking this much of space, and I can click install and go ahead. Okay, I can even change the install location by clicking on this button. So you can see different options over here, like install for all users on this computer, install for me only, or install on a specific disk. Okay, so I'll keep this selected here, and I'll say continue. You can even customize the installation by clicking on the customize button over here. Okay, so you can see we have MySQL Server, preference pane, and launch HD support by default added over here, like checked. Okay, now I'll say go back. Okay, we'll have standard installation only. Okay, so I'll say install. Now it will start preparing for installation, and it will ask for your system password. So you can enter the system password over here, and you can say install the software and give this a little bit of time. It will start writing the files onto your system. Now in the next step, it is going to ask you to configure MySQL server. Okay, so you can use a strong password encryption, or you can use a legacy password encryption. So out of these two options, I'll keep this default selection over here, use the strong password encryption, and I'll go ahead next. Now here it will ask you to enter the password for the root user. Now root user is like an admin user in MySQL, and I'll give this a password. So I'll enter the password of my choice over here, and just be sure to have at least 8 characters and follow the rules that they have mentioned over here. I'll say finish, and it will perform some initial setup, and again it will ask for my system password. So I'll just enter that over here. Okay, and I'll say okay. So you will see some progress happening over here for a while, and it will perform the initial database setup. So we'll wait for a while until this is complete. So the installation is successful now. As you can see, I have the thank you message up here. So I'll just say close, and this will simply close and move the installer to the bin. Okay, and we are done with the installation for MySQL. Now, once we are done with the installation of MySQL, we need to install a user interface to connect to MySQL server. So right now what we have done is we have installed MySQL server. It does not have an interface, and we need a tool to connect to our database. So we'll get back to the browser. I'll go back over here, and this is our downloads page, and I'll go back again. So here on the downloads page, like MySQL community downloads, we have an option here, MySQL Workbench. So we'll click on this, and we'll have my macOS selected, and I'll select the OS version. So ARM again is for macOS chips, and x86 is for Intel. So depending on what you have, you can choose. Now I am on Intel chip, so I'll just select x86, and I'll just download this. Now to save time, I have already downloaded this installer. So you can see the installer here in my downloads, and what I would do is I would just double click on this one, and I would open this DMG file. Now the installation for MySQL Workbench is pretty straightforward, like any other Mac software. We need to just drag drop this into the applications folder. And once we do that, we will have MySQL Workbench app into our macOS. So I believe it has been copied. Let me go to application and sort by date modified. Okay, it's not yet copied. So how the copy worked is I had to select this MySQL Workbench, drag it to the application folder. And if you drag over here, the application folder will open up, and then you can leave it over here. Okay, so this is how I was able to do it, and I'll just stop this one. Okay, because I'm already copying this. So it's about 5 seconds remaining now, and I believe it's copied. Okay, so you can see MySQL Workbench appear over here. So I'll just double click on this software, and I have it in my application, and let us take a look at the interface of MySQL Workbench. So it will prompt you whether you wish to open it, since you have downloaded this from the internet. So I'll say open, and I'll wait for it to open. So you will see this interface, something like this, and you can read the description here. So MySQL Workbench is an official graphic user interface tool for MySQL. Okay, so this is provided to us by MySQL itself, and it allows you to design, create, and browse our database. And you'll see one connection already created over here. So how it works is, since this is a client which you can use to connect to the server, we have to create connections. So you have a connection here already created. If you click on this, you will be prompted for the password. I'll say cancel. And you can even right click and edit the connection. So the moment you edit, you will see different information like host name, the port number, the username, and the default schema here. Okay. And you can even test the connection. So I can say test and it'll prompt for the password. And I can just enter the password that I have entered when I had installed MySQL. So that is something you need to remember. I'll say OK. And you will see a connection warning. I'll say continue anyway. And you should see successfully made an SQL connection, which means that the password was correct and all the other details are correct. Okay, so I can either connect this way or I can even create a new connection. So you can say, you can enter the connection name, you can enter the IP over here, the port, the username with which you are connecting and connect. Okay, so this is about the interface. And if you click on this, since I have already entered my password, it is asking me whether you wish to continue anyway. I'll say continue, and you will be prompted for password, which you have to enter. And then you will be taken to this page, which is the main page of MySQL editor. Okay. So this is the MySQL home page, or the main page, I should say, where you will start writing queries. All right. So that's about how you can install and set up MySQL and MySQL Workbench on your Mac machine. Hey there, welcome to this class. So let us understand how you can install MySQL onto your Ubuntu or Linux operating system. So what we are going to do is we are going to have two components installed. So the number one component is MySQL Server, and then we have MySQL Workbench. So you can head over to Firefox and you can search for MySQL over here on Google. So I'll say MySQL, and you will be taken to this official website. Now here is where you can read more about MySQL if you wish to. You can see different companies that are using MySQL over here. Now there are multiple products that this particular company has. So you can see we have the Enterprise Edition, Standard Edition, but we are going to use MySQL Community Edition. So if you go to download, from here you can download the files that you need over here. Okay, so you can select the MySQL Community Server and you can download the files for Linux. But we are not going to follow this approach. We are going to head over to our terminal and install it via command line. So we are going to have MySQL Server. So this is the server which has the database up and running, and this is where our data is going to be stored. And then we need a graphical user interface to connect to the database and do the queries. So yes, MySQL Community Server comes with a shell, which is nothing but a terminal using which you can query the database. But using shell is not that interactive. So we will be making use of a graphical user interface called MySQL Workbench. Now MySQL Workbench is an interface that allows you to define connections and connect to your databases. We are going to see this shortly, and let us begin with the installation process. So what I'm going to do is I'm going to minimize this and I'm going to head over to my terminal. Now in terminal, I'm going to run this command sudo apt update. So first I'm going to update the packages that I have, and I'm going to be prompted for the password which I will enter, and I'll press enter over here. So this will do the updates or anything that is pending on your system. So it will update the packages. So we'll wait for a while until this updates. So the update process is completed, and there will be a possibility that there will be no updates for your system, which is perfectly fine. I had few updates and the updates were implemented. So I'm going to clear the screen and I'm going to write the command now to install the MySQL server. So I'm going to say sudo apt install. I'm going to say MySQL -server, like so. And I'll press enter. Now it will ask you whether you want to continue. So I'll say yes, and I'll press enter again. Now, depending on your internet connectivity and your system performance, it will take some time to process, okay? And we'll wait until it installs everything. So the installation process was completed and you won't see any errors usually, okay? So now we need to check the status of MySQL. Now MySQL is installed as a service and we need to say sudo systemctl and you need to say status MySQL.service. So this will give you the status of MySQL, and if you run this, you will see some stuff being printed and you will see this active status, which is mentioning that it's active and running. Okay, and you can see this is the process and you'll see different information like the memory and CPU information over here. Okay, so I'll just press Ctrl C and I'll exit this. So MySQL is running, but for some reason, if it's not running for you, then you can go to the previous command and instead of status, you can say start. So you should say sudo systemctl start MySQL.service. And this command will start the MySQL service that has been installed on your system. Now, after getting our service to start, it's time to log in to MySQL shell. Now, what is MySQL shell? So MySQL shell is an interactive terminal from where you can connect and query the database. So I'm going to say clear over here. So to access the shell, you're going to say sudo MySQL over here and press enter. Now once you do that, you will see some information being printed. So it talks about the connection ID, the server information, and it is giving you the server version over here. And it talks about some registered trademarks. And then you have some information as to how you can get the help. Okay, so this means that you have successfully logged in and you are able to access MySQL shell. Now, after connecting to the database, your database might have different databases inside it. Okay, so you can just say show databases and it will give you the list of all the databases that exist in MySQL. So you can see over here, these are the default ones like information schema, MySQL, performance schema, and sys. All right. Now, after we are done with this, we need to exit the shell. So we can say exit over here and we have exited and returned to the normal prompt. So I'll clear this. Now, after installing and accessing MySQL shell, we need to do some security related configuration. So we need to say sudo MySQL _secure _installation like so. And I'll press enter. So it will print some messages over here. So it will say securing the MySQL server deployment, connecting to MySQL using a blank password. And it's talking about validate password component. And it says that this component can be used to test passwords and improve the security. It checks for the strength of password and allows users to set only those passwords which are secure enough. Okay, so it is telling you whether you would want to validate the password using this particular component. So ideally in production mode, you should say yes. But since I'm doing a local installation and this is for development and learning purpose, and we are not going to store any secure information over here, like any sensitive information. So I'm just going to say no over here. Now it is asking me, like by default, MySQL installation has an anonymous users, allowing anyone to log into MySQL without having to have a user account created for them. And this is intended only for testing and to make the installation a bit smoother. So you should remove them before moving to production. Okay. So do you want to have anonymous user into your account and allow anyone to connect to the database? Again, if you're using production environment or doing a production setup, you should say yes. But since I'm okay, I'll say no over here. Now it's asking you to set the password for root user. Now root user is like the admin user. and root user will be allowed to connect from the local host. So it's asking you whether you want to disable login remotely. I'll say no. And it's asking you whether you want to remove test database. So I'll say no again. Okay. And it is asking me to reload privileged tables now. I'll say no for everything. And we are all done. Okay. So we went through a series of steps over here. So we have completed the security related configuration. But one thing it did not ask us is to set the password for the root user. So we need to set the password for the root user. So if you scroll up over here, okay, we said no over here. We do not want to validate password, but it did not ask to set the password over here. So it says skipping password set for root as authentication with auth socket is used by default. If you would like to use password authentication instead, you can set the password by using alter user command. So we'll go by this approach. So I'll clear the screen here and I'll log in to MySQL shell over here. Okay. So I'm logged in to MySQL. Now I'm going to type in a command over here, which is a alter user command, and that is going to modify the password for my root user. So this is the alter user command that we should be using. So we are saying alter user. This is the user, that is root at localhost, and we'll say identified with MySQL native password by, you need to enter your password that you wish to set over here. So what I'm going to do is I'm going to remove this part and I can enter any simple password over here. So I'll just set root over here. Okay. But if it's a production environment, you need to make sure you have complex passwords. So I'll just press enter. So it went to the new line because I have not added the semicolon. So I'll add semicolon and hit enter. Okay. So it says query okay. So we are done setting the password for the root user. Okay. Now what we need to do is I'll say exit and I'll clear all of this. So now since the password setup for the root user is done, what we can do is we can try connecting to the database with the help of root user. So earlier we just said sudo MySQL and we logged in as anonymous user. But to log in as a specific user, you can say -u root and -p like so. And I'll press enter. So I'll be prompted for the password that I have set. I'll enter that password here. And you will see that I have logged in to MySQL instance. Okay. And I can run queries over here. So I'll just exit and I'll say clear. So now since we are done with the MySQL server installation, which is the database, and it's a free database, like we have installed the community edition. Now we need an interface for that database. Like we don't want to use shell. So having an interface or a graphical user interface is really convenient. So for that, we are going to head over to Google, and in the browser, I'm going to go to google.com here. And here I'm going to search for something. So I'm going to say snap MySQL workbench community. So I just search for this. So we are going to make use of Snap Package Manager over here to install MySQL Workbench Community Edition. Okay. And that is what I have searched on Google. So Snap is also a package manager by Ubuntu, and you can happily use this. So you will see this first link of Snapcraft. So I'll head over to this link over here and I'll say accept cookies. And this is what the interface of MySQL Workbench will look like. So I can click on install over here and you will get this command which you can copy. So I'll copy this command and I'll head over back to my terminal and I'll paste this particular command here and I'll press enter. Now the moment you press enter, you will see all the processing that will happen, and it will download all the dependencies, prerequisites, and even the MySQL Workbench for us to use. So the process will take some time depending on your network connectivity and the system performance. But for me, after a while, it was successfully installed. And after the installation is done, you can just go to your application list and you can search for MySQL, and you can open the Workbench software this way. So this will open up the MySQL Workbench. I'll go full screen on this. So you can see this is the software, and here you have the list of all the connections. So from here, this is a client and it allows you to interact with the database. And from here, you are allowed to create multiple connections. So you might have different databases, like you might have a database on your local system. You might have a database that is of production and it's hosted somewhere on a cloud. And you might want to connect to different databases. So this way you can create connections from here. You can click on plus arrow, like plus icon, and this pop-up opens up, which enables you to set up and test your connection. And once you say OK, it saves the information over here. So we have a default connection created over here. You can right click and say edit connection, and you can take a look at the different parameters that have been set by default. So we did not create this, it is created by default. And you can see over here, this is pointing to the local instance of MySQL server. You have the host name as localhost, and the default port at which MySQL runs is 3306. And the username is root user. Okay. So I'll just say test connection and it will ask for the password. So I can enter the password that I had set and I'll say OK. And you will see like a successful connection was made. So the connection is successful. Now what I can do is I can just double click on this and it will open up the query editor. Okay. So this is the query editor and this is the first look of MySQL Workbench. Alright, so with this, we have successfully set up MySQL Server Community Edition onto our Ubuntu Linux system. We have also installed MySQL Workbench onto our system, and we have successfully created a connection from MySQL Workbench to MySQL database. And we are now able to access the database objects from here. Alright, so that's about the installation of MySQL on Ubuntu. Hey there, welcome to this class. So let us do a quick overview of MySQL Workbench interface. Okay, so you're going to see this particular interface when you open MySQL Workbench for the first time. And there are different panes over here. Okay, so on the left hand side, you can see the administration tool over here. Okay, and you can see administration written over here, and you can see different tasks that can be done over here. So you can like get performance reports and you can check the server logs, startup, shutdown. So all the admin related tasks can happen from here. Now in the same window here, in the same pane, you have this tab called schemas. Now schema is nothing but the databases. So you can see over here, SYS. So it's a collection of database objects. So you have one schema already present over here, which is sys, and you can see the tables inside. So here you can see different database objects like tables, views, stored procedures, and functions. Okay, and this is something that we got by default. All right, and within tables, you can see you have columns, indexes, and so on. Okay, so you can view all that information from here. This is about the two tabs that you see over here. So whatever schemas you create will appear on this side. Now here you have at the bottom, you have the sidebar panel. This is like the information about the object, as you can see, object info at the bottom left. And then you have the information about the session over here. So this is a session and this is the information about this particular session that I'm having with the MySQL server. Then here, this bottom bar, which we can expand also, and we can reduce the size. This is the output panel, and this is where you will see all the output. So you can see over here, text output, history output, action output, and so on. So you will see time, action, message, and duration. So on the right hand side over here, there is a pane called SQL Additions, and this is the help panel. So you can click on this drop down and you can select any SQL command and you will get the documentation for the same. So any command you can select and you can know more about that particular command. So I'll collapse this a bit. And here in the center, you have the main query panel where we are going to write our queries. Okay, so whatever queries you write in, you will be writing over here. And at the top, you have different buttons over here. So you can see here, this is the open script file in this editor. So if you have any script file that has been saved on your system, you can go to that particular folder and open that script over here. You have the save option, which means that whatever you type in over here, you can get that saved as a script to a file. Then here you have execute button. So these are two execute buttons you see. So one is execute the selected portion of the script. And here you have execute the statement under the keyboard cursor. All right. So you can see over here, if I type in, let's say show databases, I'll say show databases and I'll end this with the semicolon and I'll say execute. So you will see the list of all the databases that exist in our system. So you can see these are some of the default databases that we have got. And here you can see the output. So we ran this particular query. We got 4 rows returned and the duration was 0.00 seconds. All right. Now what the difference between these two is, so this will actually run everything. So it will run either the selected portion, or if you have not selected anything, it will run the entire script. But if you want only one statement to run, so let's say if you have multiple statements, so the script file can have multiple statements, okay? And if you want only this one part to run, you need to take your cursor on that statement and you need to execute this, okay? You need to say this, you need to press this button. So this will execute the statement under the cursor, and how it categorizes a statement is with the end of the semicolon. So it will execute till this semicolon ends. Okay. Now, if by chance, if I press this button, you will see it was executed multiple times. So since we have written show databases 3 times, it was executed 3 times. So if I right click over here and if I say clear, and if I press this lightning symbol again, you will see it got executed thrice. And if I select this particular thing over here, and if I click this, so it will get executed only once. Okay. So there's a difference between these two buttons. So the first button will execute the selected portion of the script or everything if there is no selection. And the next button will execute the statement under the keyboard cursor. All right. Then you have different buttons over here, like you have this drop down. So whenever you are selecting data from a particular table, and if that data is in thousands, so here you have this drop down wherein you say limit to 1000 rows, so that you don't end up loading everything into this particular tool here. Okay. So this is for efficiency purposes. If you want to modify this, you can modify this as per your choice, but we'll stick to defaults over here. Okay. Then you have multiple options over here. So you can see create a new SQL tab for executing scripts. So this will give you a new tab or a new script file. And here you have a button which says open a SQL script file. Okay. And using this, you can create a new schema on the connected server. And using this, you can create a new table. So there are different options that you can explore over here. Okay. New stored procedure, new functions. So this is just for creating different kinds of database objects like tables, stored procedures, views, and so on, and even functions. Okay. So this is about the interface. At the top, you have different menu options like every software has. Okay. And if you are looking for anything specific, you can just explore these options at the top. So now I can even customize the appearance over here. So you can go to the menu bar over here in edit. You can go to preferences. And here you can see different settings about Workbench. So I'll go to font and colors, and here you can see different font options and different scheme depending on your system. Okay. So I'm having font options for SQL editor, result set grid, scripting shell, and script editor. So I'll increase the font for everything. So I'll increase this to 30. this one to 20 and this one to 20. Okay. So I'm purposely increasing this because since I'm teaching, the font size is pretty less and I want my students to see clearly. Now, you don't see any changes, but if you open a new editor file, you will see the font size has increased. So I can say show databases, and this is like pretty neat. Okay, and I can run this. You'll see this is much more bigger than the earlier one, and this gives a clear view. So this is perfectly as per your preference and choice. If you wish to customize the appearance, you can happily go to edit and preferences and change it. If you don't wish to, that's completely fine. It's absolutely your preference and your choice. So this is about the MySQL Workbench interface. All right. So that's about this class, and I shall see you all soon. Now let's talk about the concept of ORM and understand what ORM is. Okay, and you're going to understand these amazing concepts in the next few minutes. Okay, so think of it this way. So every application that you create has something called as entities, right? Now, what are entities? Entities are nothing but these are real world entities or objects that exist. Okay, and they are being represented in our application in the form of classes. So here, as an example, I have presented to you a customer class, right? And customer is nothing but a real world entity that is being represented in our application in the form of a class. So here you are seeing attributes like ID, first name, last name, and so on. Okay. Now this entity can be anything. So today it's customer, tomorrow it can be employee, and so on. Okay. Now, if you want to make use of this entity, what you would do is you would normally instantiate this customer class, which means be creating the objects of this customer class, right? So you would create objects like customer 1, customer 2, customer 3, right? And you would have the values assigned to the attributes inside, like 1, or you could have like ID as 1, the name as John, Trump, you can have the name as Stacy over here, as you can see, the name as Mark. So these are 3 customer objects with name John, Stacy, and Mark, okay? So what you're doing, you have customer class, okay, which is like a template that you have for things in real world. And then using this template, you are creating multiple customers in your application, okay? So the template is being represented in the form of the customer class, and the objects is nothing but the different customers that you have in your application. And there are different attributes, as you can see over here, okay? Now, what would happen is you would normally want to persist this data, right? You would want to save this data into the database. So the data would be stored something like this, okay? So you would have columns, okay? First of all, you would have a table called customer table. And then this table would have columns like ID, you can see, first name, and then the last name, okay? So there are 3 columns. And the table would have the record of a customer. Okay, so this is the record of the customer with ID 1, the customer with ID 2, and customer with ID 3. Now observe something over here. Okay, here the structure of the table is equivalent, or it's similar to the customer class, right? You have ID, first name, and last name. Okay, here you are also defining the type of data that you want to store in the customer class, and here that's the exact kind of data that you are storing in the database as well. Okay, so it's resembling the customer class structure over here. Okay, then you have objects with different customers data. Okay, and every object is having the data that is being stored into the table as a single row. So this single row data over here, okay, is coming in from the object over here. So what is happening is this object is being converted into a single row. Okay, so this is how things are working. Okay, now what is ORM? Okay, so ORM is this concept over here. Okay, so whenever there's a class, it says that the class can be automatically converted to a table, and its attribute also can be converted into columns. Okay, so if you take a look at this diagram, okay, you have this class. So this class is being converted into a table here. Okay, and the attributes are being converted into columns. And whenever you're creating the objects, those becomes row over here. You can see, okay. So earlier what used to happen is this concept of ORM was non-existent, and developers had to write all the code to create the a table structure, to create the records into the table, and so on. But today, with the help of ORM, as you can see over here, whenever there is a class, it can be automatically be mapped to a table, and its attribute can be mapped to columns. Okay, so developer does not have to write any queries for table creation. It's just created automatically on the fly. You just have to write your application code. You just have to create your classes. And what this concept of ORM does is it maps those classes into the corresponding tables. Okay. Now, whenever an object is created, like I said, its data can be saved into the table as the row. Okay. And this is automatically handled by ORM, like I said. Okay. So that's what the concept of ORM is. Okay. And as you can imagine, ORM as a concept can make yours, like developers like us, lives easier, and lets the developer focus on application logic rather than SQL queries. Okay. And because of ORM, developers don't need to write SQL queries, since the translation from the application to SQL is handled by ORM itself. So tomorrow, if you want to save data that is residing in an object into the table, okay, what you have to do is you have to just call a method. Okay. For example, if customer1 is the object, you have to just say customer1.save. And what happens is that object is saved into a database. And how it's saved? It's saved in the form of a record. Okay. And this is a very powerful technique in programming. It minimizes a mistake. So earlier you used to write queries, right? And there used to be syntax errors, right? And if database changes, then those queries are invalidated, right? Now here what happens is you're not writing any queries, right? Everything is on the fly, right? And even if database is changed, like from PostgreSQL to MongoDB or something else, PostgreSQL to MySQL, and if there is any difference of queries, so that is not impacted. But earlier, if you are hard coding any queries, what used to happen is if you are writing a query for MySQL database, and if that's not the query that will work in PostgreSQL database, you have to make changes. Okay. And these issues are now handled appropriately with the concept of ORM, and the life of developers is much more easier and it's efficient. Okay. So that's the concept of ORM. I hope this was useful. So now it's time that we talk about JPA and understand what it is. So JVA, to put it simply, stands for Java Persistence API. And it allows your application to interact with the database and do all the sort of stuff that any application would want to. Let us understand how. So like I said, it stands for Java Persistence API. And if you take a look at our project right now, so this is what we have created, right? So you have a class category, which has category ID and category name. And we have created this class to store the category related information that our application is going to have. So far, we are managing all of this with the help of a list. So if our application restarts, we are losing all the data, right? This data is not persistent because it's being stored in the form of a object, which is a list, and it's being stored in the memory. We need a way to persist this, and this is where database comes into picture. So ideally, since you're storing the information of category in this way, like having category ID and category name in the application, you would ideally want to convert this data into something like this, where you are having category ID and category name in the table. And this is a single table. You can call it category or whatever you want to. Okay. But typically, this is what the columns are going to be to store this kind of information that you have in the form of a class, right? So earlier, what used to happen is developers used to create tables on their own and manage all the information by themselves. So they have a class with which they are holding the data, and then they are also creating the table manually. But later on, with the help of JPA, you can convert your objects into relational tables. So it's like a specification that you specify, and this specification is then converted into relational tables. Okay. So you have to tell Spring Boot that, hey, this particular class, I want this as a table, and you have to just specify this, right? Spring Boot will understand, and it will manually, or I should not say manually, it will automatically create the class or the object into the table form, right? And you don't have to write any sort of query. It's all handled by Spring Boot itself. And within Spring Boot, JPA is where this happens, right? So there are a few advantages when it comes to making use of JPA. So far, you must have thought, okay, it's going to be a bit complex, but it's actually not. It's very easy and really simple. With the help of simple annotations, you can get these things done. It's very easy to follow, and it's very easy as compared to writing queries. So imagine you are writing create table queries and all those SQL queries into Java code. Okay, you're going to face a lot of errors. You might make syntax errors as well. So all of that is saved. Okay, makes querying easier. Now what this means is whenever you have any sort of data that is being stored into the database, you might want to query it, right? For example, you might want to get the list of all the categories from the database and show it from the API, right? And for this, you would have to write a query to get the data, right? So with the help of JPA, you also get some methods using which you can query easily. How? We are going to see that. Allows you to save and update objects. So along with querying, you will also have to perform the CRUD operations like create, read, update, delete. So save and update is also part wherein you might want to create new categories, update existing categories, and so on. So all of this is really easy, right? And the best part, it is very easy to integrate this with Spring Boot. Okay, it's amazing like how this fits into the entire ecosystem. So JPA is an amazing way to get our Java classes mapped to the database table, and that is what we are going to do. So now it's time that we talk about data layer and understand what we are going to do. So we have presentation layer. So presentation layer is the layer where we present the data and the application features to the user. Okay, and at this layer, we have all the controllers in place, right? We have next layer as the service layer, which is where the business logic is residing, and tasks such as evaluation, decision making, processing of data, all of this will be done at this particular layer, which is service layer. And then we have data access layer. All right. So this is the layer where all the repository classes are going to reside. So far, we do not have this layer built, right? And this is what we are going to work on. So presentation, service, and then later on will be the data access layer, which will do the job of talking to the database. Okay. So this is what our application is going to look like. So here you can see that we have the browser, we have the category controller, we have the service. So these two things exist, okay? And then we need the repository, all right? The repository's job will be to talk to the H2 database or the database, whichever database we configure, okay? So for now in the diagram, I have H2 database because this is a database that we are going to configure and our application will do the job of interacting with it, okay? So right now, the application ends at the service layer, right? There is no repository as of now. And within the service layer, we are managing everything like all the data with the help of a simple list, right? So the response is taken care of here itself and it goes from here. But going forward, service will interact with repository and repository will interact with H2. So this complete flow is what we are going to do, okay? And this entire part here, the repository layer is what the data layer is, all right? I hope this is making sense. So this part is only about the category, okay, like what we have done so far. But this is the entire application Hawkeye view, okay? So you have controllers here, you have services here, you have repository here, okay? So in the end, you're going to have repositories for all of these modules, like including controllers and services as well, okay? And then you're going to have the database with which you are going to interact, okay? So this is going to be the end goal. All right. So I hope data layer is clear and let's dive right in. Let us start talking about the H2 database. So what is H2 database? So H2 database is a open source relational database and it has been written in Java and it's incredibly fast for building Java based applications. So that is something that we are going to use. So what you can do is you can head over to Google and search for H2 database and you will be shown this official website over here, H2 database engine. So you can go to this website, and I have this open over here. So what is H2? So these are some of the features of H2. So it's an SQL database which is based on Java. Now what I mean by it's based on Java, it's written in Java and it can run anywhere wherever Java runs. And this makes it perfect for development testing or even deployment in certain scenarios. Now it is pretty lightweight and it is not supposed to be used for production-based environments. So as long as you're building applications for testing, and if you need something that is really fast and get you started quickly, that is where H2 comes into picture. So as you can see, it's fast, open source. Now it has embedded and server mode. So what do you mean by embedded and server mode? So embedded mode means the database runs within the same JVM as your application. So that's what is embedded mode. While server mode means that it is running on its own, which means it has a separate process of its own and it's running as a server and it can accept connections from the clients over the network. So this embedded mode is beautiful and it makes sure that we can embed it into our application. Also, H2 database has a browser-based console application using which you can see what tables have been created and what data is being stored from our application into this particular database. Also, it is pretty lightweight. As you can see over here, it has a jar file of around 2.5 MB in size, which is really small. And it is also known for its quick start. Okay, so it's really fast and it also makes your application faster. So you can see over here, it's fast, open source. So these are more features that have been mentioned over here. So this is something that we are going to use. But right now, you don't need to download or install this database. So you can use this website to learn more about what this is and how does this database work. But instead, we will be activating this particular database within Spring Boot with the help of a small dependency that we will add. So that's about H2. So now it's time that we get our project configured to work with the database. And for that, we are going to need a few dependencies. So if you head over to our project structure within pom.xml, here is where we are going to add the dependencies that will enable us to work with database. All right. So to get the dependency, we will be heading over to the browser and we'll log into our favorite website. So which is our favorite website when we do Spring Boot development? Of course, it has to be start.spring.io, right? So here I'll head over, I'll log into this website and I'll select Maven here. Just make sure you are hitting Maven. I'll say add dependencies. You can add JPA over here because this is what is going to help you persist data. And this will give us the access to the Java Persistence API using Spring Data and Hibernate. You can read the description here, right? And then you would need the database itself. Okay, so right now we are going to make use of H2 database, which is a fast in-memory database. It supports JDBC API and it is very lightweight, like 2 MB. Okay. It also supports embedded and server modes as well. It gives access to a browser-based console application as well. Okay, so browser-based console application is really handy for us if you want to check whether the data has been saved or not into the database. Okay, so I'll select Explore. Now here, if you open pom.xml, if you scroll down over here, you will see these dependencies added over here. Okay. Now, these are the dependencies that we need to bring to our project. So it's H2 over here and this particular dependency, which is JPA. Okay. So these two dependencies are the one that we'll be needing, the JPA one and the H2. So let me copy this. Okay. And I'll head over to my project and I'll add it over here. So you can see this starter test that was shown over there is already added to our project. Okay, here, this one. So we don't need to copy that one. Okay, we just need to get the dependencies that we need. All right, this is done. Now, what we need to do is here, the moment you make any changes to pom.xml file, you are actually changing the project dependencies and Maven gets to know this, and it will show you this icon over here. So this is being shown by IntelliJ. You can see if you hover on this, load Maven changes, okay, which means that Maven project structure has been changed and you need to load the changes into IntelliJ IDEA to make it work correctly. That is what it's saying. So it's telling you that you have made changes to your project structure and you need to reload Maven to get the changes reflected. So what this means is this dependencies that you have added, okay, ideally the jar files and all the libraries associated with these dependencies should be added in the external libraries. So right now they have not been added because to get them added, you need to load Maven changes, okay. So if for some reason you are not seeing this icon, there is another way to get this. So you can head over to this Maven tab here, and here you can select this reload all Maven projects. So that is going to do the same job, okay. So what I'll do is, since I'm seeing this icon, I'll just say refresh and you'll see the processing here at the bottom right. You can see resolving dependencies of SBCom, okay. And you can see it's indexing everything. It's getting all the dependencies, okay. And now if you go to the project structure, external libraries over here, you will see the JPA related dependencies. You can see Jakarta persistence, Jakarta transaction. Okay, these are all JPA related dependencies. You will also see H2 database over here somewhere. So you need to just scroll a little bit and find it, but you should be able to see it over here. Okay, you can see H2 database. Okay, I found it. Yeah. Checking the dependencies in external libraries is optional. Okay, you can just check it out if you want to understand how things work. Okay, but right now our project is ready to work with the database. Now this is done. We additionally, so I'll right click, I'll say close the tabs. We additionally need to make some configuration here in the application properties, okay. But without doing those changes, let us see how our application behaves right now, okay. So we'll learn in the process, okay. All right, so you can see that our application is up and running. If you scroll up over here a little bit, okay, you will see some logs related to JPA. So you can see ORM core, okay. You can see JPA, initialize JPA entity manager factory. So these are all logs related to JPA, which means JPA is in action and we have literally done nothing. So in application properties, let us enable the console. Okay, we have access to a console using which you can check your database tables. Okay, so what I'll do is I'll say Spring. I'll say data or not data h2 dot console dot enabled, and I'll set this to true, something like this, okay. And I'll rerun the application, okay. Let us see what happens now. Okay, so if you scroll up over here, okay, so you saw some logs related to H2. So let us go through the logs, okay. Logs will help us understand how our services are behaving, okay. So if you come over here, you can see over here, right? So here it says starting, you have this log as starting. If you scroll down, it says added a connection, okay, added a connection over here. And it is giving you a URL of the connection. This is the URL of the connection. What is this URL? This is a by default URL for the database that is being given to you by H2, okay. So you can see over here, this is our database URL. It's pretty long, okay. So this is what we are going to use. I'll just copy this, okay. And it's also giving you a user, okay. It says user SA, okay. This is the admin user, system admin, all right. If you scroll down a bit, it says start is completed, and you can see H2 console auto configuration into picture, right? So it has configured everything automatically. We have literally not done any sort of configuration, people. Just remember, what we did is we just added the dependency and we just said Spring Boot that via application.properties that, hey, I need a console. We just set a property to true. That is it. So auto configuration came into picture and it just made our H2 console available. And it is giving us access to this endpoint over here, /H2 console. So this is your domain name /H2 console. And this is the database URL that we just copied. Okay. So what it's telling you is you can access the H2 console over here with this URL. Okay. Let's head over to this console and let's see what it has for us. Okay. So I'll switch over here. Okay. I'll say H2 hyphen, you can see. So this is a URL that you need to go. It's localhost :8080. This is our server /H2 console. You'll see this nice looking page, which is something that we did not create. Did we create this? No, it's given to us by H2 database. Okay. You'll see this JDBC URL. Here is where you need to paste the URL that you have copied. Okay. So you can see these are some settings. Okay. So I'll just leave these as it is. Don't modify any of these settings. Okay. You have the driver class. I'll leave this also. I'll just update the JDBC URL and the username over here. Okay. Now you can test the connection and you should see this message test successful. Okay. And if you say connect, you'll also be connect to the database. Okay. So isn't this amazing? It's amazing, right? Now to access this H2 console, this is running on our server. Okay. So if you stop the server, okay, it's going to be not accessible. It's just going to die over here. Okay. So if you refresh and you should see cannot access. Okay. So this is gone. All right. So this is only accessible only if your application is up and running. Okay. Also just make a note of this URL. Okay. This URL will change on every restart. Okay. Because this is a dynamic URL that is being presented to us. So right now it's ending with 398F. Let me start this again. Okay. And if you scroll up over here, you can see it's 02D9 right now. Okay. And if you come over here, if you try to access this was the earlier URL that we had added. If you say test connection, it will say not found. Okay. What you need to do is you need to get the new URL here and you need to paste it over here. That is what you need to do. Okay. So this URL is pretty dynamic. Okay. And there is a way to get this fixed. Like you don't want to be copying, pasting URLs for every change you make and for every restart, right? So in that case, we have to set one more property. Along with this, you have to say like spring.data source dot, sorry, not hyphen, it's dot URL. And here I'll paste this URL. So this is a format of the URL. Okay. So JDBC :H2:M, and instead of this string over here, which looks really long, you can have your own version of string or you can have this string only. Okay. But instead of this, I can say test over here. So this is a test database. Okay. And you can have any string in the end, but be sure to adhere to this format. I can come over here and I can paste this. So this is not available yet because we have not restarted the server after making this change in application.properties. So just restart the server. Okay. You can see the server has been restarted, and if you scroll up over here, you should see this is where it's running now. Where did this come from? This is coming in from application.properties. Okay. Now, if you break down this JDBC, this is the connection protocol for the H2 database. Okay. So JDBC is the connection protocol. H2 is the database itself. Mem meaning it's an in-memory database, right? You're connecting to an in-memory database. Okay. And test is nothing but the name of the in-memory database. Okay. And like I said, you can replace test with any other name to create any other different in-memory database instance. And it's totally up to you. Okay. So with this configuration, we are set. We have a set URL for accessing our database. We have a UI as well. So if you come over here, if you test this connection now, it should, okay, let me paste this here. If you test this, it should work now. You can see. And if I say connect, you can connect. So right now we have a interface as well to work with the database, right? And you can play around with this, okay, the interface, and you can get familiar with this. Okay. So yeah, this is about the setup or setting up JPA and H2 database to get our Spring Boot application working with it. So I hope this was useful and I hope you have been able to follow along. So now it's time that we begin talking about the entities in our application. Okay, so far what we have done is we have the JPA and the H2 database configured right now. So this is a JPA dependency and this is the H2 database dependency. All right. Now we need to start talking about entities. Now what exactly is an entity? So in the context of JPA, an entity represents a table in the relational database. Okay. So for example, here, if you take a look at our models, here we have category, right? So I want this category class to be mapped into a table in the database. Okay. So if you take a look at this diagram here, I have class category. Okay. These are the two fields in this class over here. And I want to map this into a table in the database. Okay. And this will only happen if you mark this class as an entity. Okay. So if you're creating a single category, that will be stored as a single row within that particular table. If you add one more row, it will be added as the second row. So if you add one more object, so the number of objects that you're creating of the category class will correspond to the number of rows that this table is having. Okay. Of course, you need to save those objects as well to the database. That is a different part, but every piece of data becomes a single row in that particular table. And this is something that you're going to experience yourself. Okay. So if you come back to our project over here, we have this class created, right? So this is nothing but a Pojo class, I can say. Like this is a plain old Java object, right? So you need to annotate this and you need to tell Spring Boot that, hey, I want this to be mapped into the database. So here, there is a annotation and I'm going to make use of that annotation. So you can see entity over here. So this is the annotation that we are going to use, entity, and you can see this is coming in from Jakarta Persistence package. So JPA was earlier known as Java Persistence API and recently they've renamed it to Jakarta Persistence API. Okay, but the name does not matter, but you just make sure that you're getting it from this particular package over here. Okay. Now with this, what we are telling Spring Boot is we are telling that this particular class is now an entity. Okay. And what would happen is by default, this annotation entity would map this particular class to a table in the database. And the table will share the same name as that of the class as of now. Okay. Of course, you have options to customize it, which we'll be talking about. But right now, this is the default behavior. So the moment you add @entity and if you run it, let me run it. So you'll see a few logs over here. Okay, we'll get an error. Okay, so this error is supposed to happen and I know what this error is. Okay, so if you scroll up over here, okay, so you will see that every entity class, okay, must declare or inherit at least one @ID embedded ID property. Okay, what this means is since you are wanting this particular class to be mapped into a database table, okay, and it's a relational database, right? So you would need a unique identifier within the database. So which field should be that unique identifier? That is something that you need to specify as well. All right. And what you need to do over here is you need to mark category ID as the ID because we want category ID to be our unique identifier. All right. So I'll just have @ID appear just before category ID. Okay. And that will make sure that category ID is being marked as primary key within the database. So @ID, if you see, this is coming in from Jakarta Persistence API. And if you run this, okay, so this should not give any error now. Okay. So you can see this, the application is started over here. Okay. And you don't see any queries coming in over here. Okay. That's okay. But if you head over to console, okay, this console is now locked out. I'll say connect and you'll see this particular table come in over here. Okay. And what did we do to get this table? We literally did nothing. We just added a couple of annotations into our source code, which was already existing. Okay. And if we have this particular piece of table appear into our H2 console. All right. Isn't this amazing? So this is the power of making use of JPA. You just have the entities defined, and you are making use of this class into your source code. You are creating objects and using it in your source code, right? To display, to send the category across classes and all. Okay, you're making use of this class. And you're also telling Spring Boot that, hey, this is also an entity with this being the ID. Okay. Now, if you want to customize the table name, so right now you're seeing the table name as category itself, right? That is what the class name is. So you need to add a attribute here. You can say name and you can say categories, something like this. Whatever name you want to add, feel free to add it. I'll just rerun the application. And if you come over here, if you say refresh and if I say connect, you'll see the table name has been changed to categories. Okay, so this is the attribute that you need to specify if you want to get a good control over like the name of the table. Okay, so if you want the name of the table to be a bit specific, like you don't want the class name to be as that of the table name, and if you want to follow any convention, like normally what happens in companies is there is a convention for naming tables. So the table should have a certain prefix and all if they're production grade projects. So in that case, you can make use of this, and this is really helpful, and it gives you a very nice grip or very nice control, I should say, of how things are created in the database. So I hope this was useful, and I hope you have been able to get your category into the database like this one as well. So right now, what we have done is we have configured the H2 database, and we are seeing the category being created into our database console. Okay, so this is a categories table that we are seeing. Right now, what I want to do is I want to show you some additional properties. And when we talk about additional properties, I also want to show you behind the scenes of how JPA is handling everything with the help of Hibernate and how it is saving us from a lot of effort. So what is happening behind the scenes? That is all something that I wish to show you. Okay. So first thing, I will add some more properties. So these are the properties that we need to get our database configured up and running. Okay. We need H2 console and we need to set a database URL. Now let me add one more property. So I'm going to say spring.jpa.show, I'll say SQL. Okay. And I'll add this as true. Okay. I'll add one more property. I'll say spring.jpa.properties.hibernate.format SQL. And I'll add this as true. So what this does is show SQL will show us the SQL that is being generated behind the scenes. Okay. So right now we are not generating any SQL. We have just added this annotation, and with the help of this annotation, the queries are being generated, and the query generation, the query execution, everything is taken care by the Spring Boot ecosystem and the underlying frameworks. Okay. Now let me run this. So this particular property that I have added over here, show SQL, will show the SQL statements that are being generated by Hibernate. And this will format it properly for better viewing. Okay. So I'll just go to the run tab. Okay. And if you go over here, our application started. Okay. You can see found 0 repository interfaces. So we have not created any repositories. That is what it's telling. Tomcat server is initialized. Okay. Everything is starting. And over here, if you see, it's H2 console is being made available. Okay. And here, if you go, okay, you can see no default argument constructor for this class. Okay. So we need to add a default constructor, which is something that we will be doing. It is recommended to have a default constructor if you're creating an entity. Okay. And if you go over here, you're seeing over here that Hibernate is being used. Okay. And it's first running this particular query, drop table if exist categories, and then it's creating the query. So you can see the underlying query as to how this table is being generated. We have not written this query. This query is being generated with the help of this class that we have defined over here. Okay, and we have just mapped it as entity. Okay, if you see over here, we have just mapped it as entity. We have literally done nothing. Okay, so this is the magic of Hibernate that you're seeing over here. Okay, and if you're working in a big project and if you wish to see how your queries are being generated, or if you wish to debug something, this is an amazing way to do so. Okay. So these are the two properties that help us understand. Also, if you see over here, you'll see that the table is being dropped first. Okay. So this is because of the mode in which our application is running. Okay. So whenever you start the application, the schema is dropped, and then essentially the table is created. So whatever you have mentioned. So every time you run the application, the schema is being recreated. And if you want to customize this, okay, you can make use of a property over here. So you can say Spring, you can say jpa.hibernate.ddl-auto. And here you have multiple options. Okay, so here you can have none. Okay, so if you say none, no action is being performed. Here, if you say update, so Hibernate will change the database according to the given entity structure. Okay, so here the database or the schema is not being recreated every time, but only the changes are being propagated. Okay, recreation won't happen. Now, if you say create, so what would happen is this will create the schema and it would destroy the previous data. If you say create -drop, so it would drop when the session factor is created. Okay, so when the session is created, that is when the database is dropped and database is created. So when the session factor is created, database is created, and when the session is dropped, the database is dropped. That is how it works. Okay, and if I just say update, so let me add update over here. Okay, and let me run this. Okay, so let us see what the output looks like over here. Okay, so you can see the query being generated over here. All right, and you can see the drop query was not generated this time. This time only the create query was generated because we have specified update as the mode over here. Okay, so if you don't specify anything, create drop is the by default one. Okay, over here. Okay, but this is something that we won't be using. Okay, if because I'll tell you why are we not using this, because we are making use of in-memory database, and right now what happens is for every restart we are getting a new schema, which is absolutely okay because we are going to do a lot of development. Okay, but if you're working with some other database like PostgreSQL, MySQL, which is not an in-memory database, so in that particular case this becomes really handy. So with every rerun or restart, do you want your schema to be recreated? What do you want to happen? Okay, what should happen? That is something that you need to define, and this is something that you can control from here. Okay, if you just want the changes to be propagated, you can make use of update, which is really helpful over there. Okay, so these are some of the properties that I want to talk about. Of course, these properties, like these two properties, are just for learning or for debugging purpose. You don't need them in production environment. Okay, if you want to debug something, it's absolutely fine. You can add these properties. Okay, but like this is the minimum configuration that you need to get your database up and running. All right. So one question that students frequently ask me is what is the difference between create? Create means that the schema is created every time the application starts, and there is something called as create drop. So what happens is every time the application starts, the session factor is established, the schema is created. And why drop? So in create also the schema is being dropped, right? So the difference is in create, when you start the application, the schema is recreated entirely, right? And when you say create drop, what happens is if you start the application, the schema is created entirely, but when you stop the application, the drop is also done. Okay, so everything is dropped as well. That is also a behavior that happens. So the difference over here is with create drop, what happens is the schema exists only until the life cycle of the application, or only until the life of the application session. Okay, once the session is dropped, the schema is also dropped. So that is something that you need to remember over here. Okay, so for now I'll just get rid of these, or you can even comment this if you wish to. Okay, but this is something that we don't need. If you wish to have, there's no harm. Okay, you can like play around with these properties. All right, so that's about behind the scenes and the additional application properties. Hey there, welcome to this class. So it's time that we talk about generation types for identity. Okay, so here you can see that category ID has been designated as the primary key for this particular entity over here. Often we would want our database to automatically generate these identity values. Okay, so in terms of database terminologies, if you're making use of relational databases, these are normally called as primary keys. So there are two ways. One is your application manages the primary key and ensures that the primary key that is being stored in the database is unique always. But if that is not possible, a better way is to get your database to manage these primary keys for you. Okay. And what you can do over here is you can add an annotation over here that will specify the generated value over here. Okay. So generated value, and you have a strategy attribute over here. So you can say strategy is equal to, and you can see over here, generation type identity. So I can say generation type dot, and you will see there are lots of options over here. Okay. You can see auto, identity, sequence, UUID, and table. So what I would do is I would specify the type as identity over here. Okay. And identity is a type that we'll discuss shortly. Okay. But right now what we have done is we have transformed our category class into a JPA entity. We have mapped it to a specific table in the database, and we have also set the generation type of the ID field. Okay. Now let's head over to presentation and let's talk about different generation types. So we are going to talk about a few. We are going to talk about auto, identity, sequence, table, and there is none. Okay. So let's talk about auto first. So this is the default generation strategy. Okay. And it tells JPA provider that you should choose the appropriate strategy based on the underlying database. Okay. So what happens is normally there can be different database providers. Okay. So if you may work with PostgreSQL, you may work with MongoDB, whatever you work with. Okay. So depending on the database provider, JPA will take care of how the values are generated. So you are just delegating this to the JPA. Okay. And you specified something like this. So you have generated value strategy is equal to generation type dot auto. Okay. So let's say that application that you are building, you want it to work across different databases like MySQL for development and PostgreSQL for production. Okay. So in development, you have MySQL. In production, you have PostgreSQL. So you can make use of auto over here because you don't want to worry about specific primary key generation strategy supported by each database. Okay. So you kind of delegate that to JPA. All right. Then you have identity. Now this strategy is something that we used, and this strategy uses an identity column in the database to generate primary key values. And this is supported by relational databases like MySQL, SQL Server, PostgreSQL. Also, you should note that this strategy is not supported by all the databases out there. Okay. So you can see this is how we specify the identity generation type. Okay. Then we have sequence. Now what is sequence? So this strategy uses a database sequence to generate primary key values. Okay. Now what are sequences? So sequences, if you're familiar with databases, they are database objects that create unique numbers. Okay. And this strategy is commonly used with databases like Oracle and PostgreSQL that support sequences. So these are the two databases that support sequences right now. Okay. And sequence, if you're not aware, or if you're coming from a database development background, then you would be aware. But if you're not aware, a sequence in a database is a database object. So it's an object that resides in the database, and it generates a sequence of unique values. That is it. Okay. And it is commonly used to generate primary key values in the database. All right. And this is how you can specify it. Okay. So if you're running a PostgreSQL database that manages the order, okay, and if you want to have each order as unique, you can define a sequence in PostgreSQL. Okay. And you can make use of JPA, and you can tell JPA to use this sequence to generate a new unique ID for every order. Okay. So if you want to do that, you can do something like this. Okay. So you can see over here. Then we have this generated value which has two attributes. Okay, so you can see over here strategies sequence, and then you're making use of this generator. Okay, so this is the order sequence that is that is a specific database object that has been created. Okay, so you're saying make use of order sequence, which is the sequence that has been created, and here you are defining or you are mentioning the sequence generator. So this tells how the sequence is to be generated. So here you are saying that this particular sequence, order sequence, okay, this will be the sequence name over here, okay, and you're specifying a name over here, all right, and here this is the allocation size, okay. So allocation size meaning 1, so it will be incremented by 1, and every time a new order is received, you will have it incremented by 1. And I have added additional like spaces over here. These are not needed. Okay, these were just like so that it's understood. Okay, so if you go through this, we have ID field that marks the field as the primary key. Okay, then we have this annotation which specifies the ID field that will be automatically generated by the database using a sequence. Okay, and we have a generator that links this strategy to the specific sequence generator named order underscore sequence. Okay, and then we have a sequence generator named order underscore sequence, and it specifies the name of the sequence in the database. Okay, so order underscore sequence is the name of the sequence, and then we have allocation size as 1. Okay, so this is how it works, and this is the field that we have. Okay, then let's talk about table. So this strategy makes use of a table to simulate a sequence. Okay, so what it does is it stores the next available value for the sequence in a separate table. Now this strategy is less efficient than using sequences directly. Okay, but this can be useful if your database does not support a sequence. Okay, and this is how it is used. This is a syntax. And if you're building, let's say, a application, okay, and if you want that application to run and make use of this table sequence, then you can define it this way. Okay, so you have ID, then you have the generated value, you are specifying the table and the generator as task gen, and then you are specifying the generator details. Okay, so you are specifying that the table generator is task gen, the table is ID underscore gen, the column name, the value column name, and everything. Okay, so everything is being defined, and this is being linked to the ID column. All right, so this is about the table type. Okay, now coming back to our entity over here. Okay, what we have done is we have made use of identity over here. Okay, which is absolutely okay. We are getting this from Jakarta persistence package, and Jakarta persistence is a new name of Java persistence API. Okay, and I would also encourage you all to add a default constructor over here. Okay, so it's encouraged, so I'll just add in over here. Okay, so this is a default constructor. It's considered as a good practice, although it's not strictly required by JPA specification. Okay, but it's good to have this defined over here. Okay, so this is about the generation strategy, and I hope you have a clarity about the same. So now it's time that we talk about JPA repositories. So what we are going to do is we are going to create our own repositories, and we are going to understand some of the concepts around repositories. Okay, now when we talk about our application, we have controller, we have service, and we need to have a repository, and this repository will be interacting with the database. So what I'm going to do is I am going to have, let's say, a package over here. Okay, let's create a class directly. All right, and I'm going to call this particular repository as product. Sorry, not product. It will be category repository. All right, and it is going to be in a package. So it is going to be in com.ecommerce.project. So this is what we are going to have, and it will be repositories. So we are going to have a lot more repositories here created, but that will be for later, and this will be for a lot of other modules that we are going to build for this particular project. Okay, so this is the package and the repository name, and I'm going to create this as an interface. Okay, so this needs to be as an interface. So I'll say create, and since I have version control system configured, it's asking me to add, and I'm going to do that. Okay, so this is done. You can see over here the interface is created, and it is created in the right package, and you can see the organization over here. We have project controller, model, repository, and service, all starting with com.ecommerce.project. All right, now coming over here, okay, let us talk about what we need over here. So here we have Spring Data JPA configured into our project with the help of pom.xml. Now we get two repository interfaces for us, okay, from those libraries that we have configured, like the dependencies that we have added. And the two repositories are CRUD repository. So if I say extends, okay, and if I say CRUD over here, you can see this repository, okay, and it's coming in from org.springframework.data.repository, okay. So this is one interface that provides CRUD functions like save, find one, find all, count, delete. So all these operations you can do with the help of this particular repository interface, okay. And this interface is very useful because it comes with a bunch of generic CRUD operations, which means that you get CRUD operations ready-made for any entity for free. Okay, you don't have to write a single line of code. You just create a repository interface and extend it with CRUD repository. Okay, there are two parameters like these generic ones that you need to specify. This is something that we'll talk about shortly, but you need to do this and then you are done. Okay, so this is CRUD repository, but we are not going to make use of this. We are going to make use of JPA repository. So this is also, so you can see over here, JPA repository. This is the one. Okay, this is also a extension of CRUD repository, I would say, and it also adds few more methods that are JPA specific, like flash, save and flash, delete in batch and all. Okay, and in general, if you're working with JPA, this is a better choice as compared to CRUD repository. But you should be aware that CRUD repository exists even though we are not using it. Okay, so I'll select JPA repository, and here you see two parameters, like it was T and ID. Okay, so we extend the repository interface with JPA repository, and now we need to specify those two parameters. Now those two parameters have to be the type of the entity and the type of the primary key of the entity. Okay, so over here the entity that we'll be working with is category. All right, so I'll specify category over here, right? And then I also need to specify the type of the primary key of the entity, which is long over here. So I'll say long, something like this. Okay, and this is done. Okay, and one of the greatest thing about this is that we don't have to write any implementation code for this particular repository that we have created. Spring Data JPA will automatically generate the implementation at the runtime, and we can use it to perform all the basic CRUD operations on the category table. All right, and you will be seeing all of this in a while. All right, so for now we have created the repository and we have extended it with JPA repository interface. Okay, you can go inside this interface and you can see this. Okay, so you can see this is the interface. Okay, and you can see there are lots of methods inside. Okay, you can see get one, get by ID, okay, get by reference, find all. Okay, so this will allow you to get the particular entity, like all the rows from the database. Okay, so all of that you can do using this particular repository. You can explore more, but yeah, our interface, which is the repository, is ready and it's ready for use, I should say. Okay, so that's about this class. I hope this was useful. Now, once we have the repository set, it's time that we start making use of this repository to interact with the database and start saving data related to the categories into it. Okay, so what I'm going to do is I'm going to head over to service, and in service I'll check out the service implementation class, because this is where all our source code and the logic for saving and working with categories reside. All right. And right now we are making use of list over here. Okay. So what I'm going to do is I'm first going to start using repository over here, something that we have created. Okay. So I'm going to say private. I'm going to say category repository here, and I'm going to say category repository. And since if you see over here, we will be getting an instance of category repository over here. So I can just say Autowired. Okay. So this is done. Now what we need to do is I will simply comment the list over here. Okay. And here I'll start making use of the repository methods, and you'll see like we have not defined any repository methods, right? We have not done any implementation, but you will see how we get access to all the methods and their implementations automatically. All right. So first of all, getting all the categories, what I need to do is I'm going to say category repository dot find all. And this particular method is going to return all the categories that exist in the database. Okay. Here, I need to say category repository, and I need to say instead of add, I'll say save over here. Okay, save, something like this. Okay. Here, in case of delete, okay, what I'm going to do is here, what we are doing, we are saying category is equal to, so we are making use of stream. Okay. And we need this particular object as a list, okay, which has the list of all the categories. So I'll create a local variable called category. Okay. And I'll just create this as list over here. Okay. What I can say is I can say repository dot find all. Okay. I'll keep it simple. All right. And here instead of object, I'll say category. Okay. So good. We are sorted with the error. Okay. The error is gone. And what we need to do is here, since we need to delete, so we won't be making use of remove over here, but we will say category repository dot, and I'll say delete, something like this. Okay. So this is done. And I don't think we need any more changes over here. I'll scroll down over here, and update category is another one. Okay. So here also we are making use of categories list. Okay. So I'll just introduce a local variable for now. Okay, over here, like so, and we are sorted. Okay, but instead of adding and updating into this particular thing, what I need to do is I need to save the category, right? So here I can introduce one more step. I can say category, and I can say saved category is equal to, and I'll say category repository dot save, and I'll say category, like so. Okay, sorry, this won't be category, but I need to save the existing category. Okay, one second. So I've added a new category name over here. Okay, I can set the existing category. Okay, here. All right, and we need to return the saved category, like so. Okay, so this is done. Okay. And I believe we are done making use of repository. But you can see over here, we did not do any implementation, and you have access to so many methods. You can see category repository dot, you can see delete, save, equals, you can see so many methods. You can get the count of the objects in the database. You can see delete all, delete by ID. So if you want to delete a particular category by ID, you can delete that. Okay. Delete by ID exists. You can see like so many methods. Okay. So you can just explore these methods. There are a lot of them. Okay. And they are ready to use. Okay. So that's the benefit of making use of JPA. Okay. We don't need this. This was added by mistake. All right. So I think we are sorted with the use of repository. So now it's time that we test the changes and see if we have implemented everything correctly. So I'm going to run our application, and once the application is up and running, I'm going to head over to our POSTMAN. Okay. And I already have all the endpoints created. So what I'm going to do is I'm going to first say get all the categories. Okay. We don't have the categories created yet. So we can even switch over to H2 console, and if I say refresh and test the connection and connect, you'll see categories table is over here. But right now there is no data here. Okay, so if you run and if you see category ID and category name, there's no data. Okay, now let us go ahead and create a new category. So I'll hit create. Category has been added successfully, 201 created. Now if I head over to H2 console and if I say run, you should see some data being entered over here. And you can see the category ID has been defined as 1 and the category name is travel. Okay, so travel is coming in from here and category ID is coming in from, we have a variable over here. So that is what is giving us the ID. Okay, so this is done. Okay, we are making use of this variable right now. Okay, but we also have it managed at the JPA level here. Okay, so we can even get rid of that. All right, so this is done. Okay, category is being created. Let us try to update this one. So I'll say travel updated and the ID is 1. Let me hit this and let me query this again. So if I query this, you'll see travel updated. And if you try to get all the categories, so earlier you were getting empty, now you'll get travel updated. So you can see everything is being fetched from the database, and this is not a static data. We are actually interacting with the database and our application is talking to the database via repositories, and the underlying technology that we are using is JPA. All right, this is done. Let us test delete. So right now I have one category. Let us see if we can delete the one with ID 1. Let me send and let me say get all categories. It's empty. And if I run this, you will see it's done. Okay. Now we can repeat the process and you can create as many categories as you want. Okay. So you can see over here. Okay. So this is what it is. And I hope you are able to follow. And I hope this is sounding interesting. Okay, so right now we have a application, a Spring Boot application, which is actually talking to the database and saving and getting some data. Thanks. I hope this was useful. So now it's time that we do a little bit of optimization after introduction of the repositories. Okay, so we have this code to update the category over here. Okay, so what we can do is here we are fetching all the categories and then we are converting it into a stream. This is not like the best way to do things. Okay, so let's do a round of optimization. Okay, here instead of fetching all the categories, what I can do is I can just fetch the category that I wish to update. Okay, so I have the ID that I'm getting with the request. So instead of saying find all, I can simply say find by ID. Okay, I have access to this particular method here, find by ID. And with the help of this, I can make use of ID and I can fetch the corresponding category. So I can say category ID over here. Okay. And with this, I need to come over here. Okay. And I need to say the return type over here. Let me check the return type. All right. So if you hover over here, you're getting optional. Okay. So what you can do is here, I can say optional. Okay. And here I'll say category and I'll say saved category optional. So this is the category that we need to save. All right. And now over here, I can say category, saved category. Okay. 1 second. So here, or let me write a new line of code. We can then delete that one. So I can say category and I can say saved category like so. And I can say saved category optional dot. So if there is no parameter inside or there is no value inside, like it's an empty thing. So I can say or else, okay, or else throw over here. And I need to pass in a supplier, as you can see. So I can say this and I can make use of this syntax, okay. And I can say new response status exception. So this is the exception that I'm throwing now. And I can say HTTP status dot not found, okay. And I can pass in a message as well, resource not found. Something like this. All right. So this is done. Okay. So what is happening is I'm trying to fetch the category by ID. Okay. I get this as an optional. And with optional, I'm checking if there is any value. If there is no value, then I'm throwing an exception that it's not found. Okay. So I have the saved category. Okay. So what happens is if category exists, then I assign it over here. Otherwise, I'm throwing an exception. Okay. So I have saved category now. What I need to do is I need to come over here and now I can say category. So this is a category object that we are getting as the parameter. And I can say dot set category ID here. And I can pass in the category ID over here. Okay. Accidentally I used the getter. I need to make use of setter. And I can say category ID here. Okay. Something like this. And I can get rid of all of this code here. Okay. All of this code, in fact. Okay. We don't need this. And I can simply say saved category is equal to category repository dot save. And I can pass in the category that we received as the parameter because its ID has been set, and I can just return the saved category. Something like this. Okay. This is done. So just to give you a review, what we are doing is we are getting the category optional first by find by ID. Okay. Then we are getting the saved categories. So we are just checking over here if this category exists or not. Okay. In the database. If it does not, we just throw an exception. That is the purpose of this step over here. Okay. Then we are saving the category into the database. Okay. In fact, these two lines of code can be optimized and combined into one. So what I can do is I can simply take this over here, or let me take this part over here. Okay. I can just cut this and I can replace it over here. Okay. And I can just get rid of this. Okay. Like so. Okay. So this would also give the same result. Okay. What we have done is we have combined those two steps into one. Okay. So we are making use of optionals over here. Okay. And we are trying to save the category. Now we need to do the same for delete as well. Okay. So if you scroll up over here, we have a similar logic for delete over here. Okay. So here, what I can do is here at the top, I can say category, and I can say category over here, and I can say category repository. Let me find this by ID, find by ID, like so. And I can say category ID, like so. And here I can say dot or else throw, like so. And I can simply like throw an exception if the category is not found. Okay. An exception can be this exact same one. Okay. Like this one here. Okay. And if you go over here, so let me copy this. Okay, so I've pasted it over here in the delete category. Okay, so this is done. All right, and what I need to do is, okay, so I've passed in resource not found exception, and I'm passing in the exception. That is okay. And I can get rid of this, all of this, and I can say, I can simply say category repository dot delete the category, and I can simply return this. Okay. We did not need the rest of the logic. Okay, I hope this is also clear. Let us test the changes and let us see if things look good. Okay, so you can see the application is up and running, and let me also refresh and connect to the database. Okay, in fact, we don't need to check in the database now, because if it's coming in the API, it means like it's getting saved in the database. Okay. So let me update. It's updated, and let me try fetching it. It's updated. And if I try to delete, it's deleted as well. Okay. And if I try to fetch it again, you'll see no category over here. Okay. So this is working absolutely fine, and there are no issues as such. Okay. So I hope this was useful, and I hope you have some clarity as to how we optimize the logic. So it's time we do a little bit of experimentation with our code. All right. So we have everything set, and we have everything up and running as well in Postman. We have been able to interact with our APIs, and with the help of APIs, we are able to get the data into the database. Okay. But let me show you something. So if you create a new category, okay, and if you try to get the category, you're seeing the category name come in as the response. Okay. Now, how are we getting this response and how is it getting generated? So over here in the category model, we have getters and setters created. Okay. So when you add any class member over here, it's not necessary that it will be added into the response over here. Okay. So you just create one more member over here and you will expect it as the output. That's not how it works. So to get this particular thing as the output in the response, you have to add a getter as well, getters and setters for the corresponding member name. And let me show and prove this to you. So right now we are seeing category name as the output over here, right? Let's say I don't want category name. Okay. Or let me disable these getters and setters. So let me see what happens. Okay. So I disable this. Okay. And let me run this. So this will show you the importance of getters and setters here. Okay. As to why they are needed. Now, if I try to get the categories, okay, of course, I'm getting an empty response. Let me create a category. Let me get all the category. You can see there is no category name over here. Okay. There is only category ID. Let us see the behavior with the database. What happens here? Okay. So I'll select this. I'll say run. You can see the category name is also null over here. Okay. So category name didn't go through because there were no getters and setters. Okay. So I hope you are understanding the importance of getters and setters over here. Getters and setters are very important if you are working with entities. And in the hindsight, getters and setters are being used by JPA and everything. Okay, to set and get values of the entities or the models that you're creating. Okay, so this is the importance of getters and setters. So let me uncomment this and let me save this. Okay, so this is one experiment. Let me show you something else. So I'll go over here to application.properties and let me enable this particular thing that we had added early on. Okay, so I'll comment this, uncomment this, and I'll also uncomment this. Okay, so format SQL is equal to create drop. Okay, it should not be create drop, it should be true in fact. And let me run this. Okay, so what we are going to do is we are going to observe the queries and we are going to see how much of work is being saved for us. Okay, so you saw this one query that was printed, which is drop table, and this is another one to create table categories. Okay, and you can see over here, the identity column is also being created over here. All right. Now let us try to do some operations and let us observe the console. Okay. So let me create the category first. So I'll create the category. And if you come over here, you should see some processing. Okay. You should see this output of dispatcher servlet. And if you come over here, you'll see query being printed, which is like to select the category. You can see over here, it is selecting first and then it is inserting. Okay, so this is absolutely done by Hibernate over here. You can see. Okay, so insertion is being done this way. And then if you try to get the data, and if you come over here, you can see more queries being generated. Okay, you can see this is a query. Select category ID, category name. Okay, if you try to update the category, okay, and if you come over here, okay, I tried to insert, I did not update, I'm sorry. So if I try to update, this is the update request. Okay, and if you come over here, you can see the update query over here. Okay, and if you again try to fetch this, okay, you're going to see a similar query being printed. You can see, so you can observe as to how your application is working in the hindsight, and all these queries you are not writing. Okay, so imagine writing all of these queries. There was a time in Java development, okay, or in the Java world, where developers had to write this query in the application. Okay, and there used to be, like, trust me, there used to be so many syntax errors that you used to get. Okay, because you're writing SQL inside Java. Okay, and you're making use of inverted commas, you're delimiting stuff and all. Okay, all of that. So all of this is gone. Okay, and you are just allowing the underlying things like Hibernate to do the heavy lifting for you, and you are simply making use of these methods that are being exposed to you. So these methods that you have made use of in the service implementation, like save, you're just saying save, okay, and the implementation is being generated automatically. How is it being generated? So if you come to the repository, you have said JPA repository, which is like the standard, okay. Then you're saying I want to do everything with this entity category. So JPA has the definition of this, so it understands, okay, you will need CRUD operations, and also long over here. Long because that's the ID. So normally you will do searching and all with the help of that, okay. So if you see over here, for category repository, the methods that you have access to. So if you say find by ID, you'll see the parameter is long. You'll see in the suggestion, the parameter type is long. How does JPA know that, hey, I have to have an implementation of find by ID with the parameter of long? It knows it from here, long, okay. If you try to save, you have an implementation being created in the hindsight of type category, okay. So all of this is being done just with this single line, okay, just single piece of code, okay. Isn't this amazing? All right, so this stuff is absolutely amazing, and you can just experiment with things, okay. And like we did, like we commented out the getters and setters to check its importance. So if you want to see importance of anything, you can comment it out and see your code without that. Okay, that's how you learn things. All right. So I hope this was useful, and I hope you will experiment and learn more about this. So now it's time that we talk about Lombok. Now, what is Lombok? So Lombok is a library or a dependency that you can add into your project, and it enables you to reduce the amount of repetitive code that you need to write. Okay. Let me explain this to you. So if you are here on Google, just head over to Google and search for Lombok. Okay, so something like this, and you'll see Project Lombok appear over here. Okay, be sure that you are looking for Project Lombok over here and not for Lombok. So Lombok is also an island in Indonesia. Here you can see. Okay, so just make sure that you are seeing this URL over here. I'll just zoom in. So it's projectlombok.org, and you can read a little over here. Project Lombok is a Java library that automatically plugs into your editor and it spices up your Java. Okay, so if you head over to the website, okay, it's a very simple website, you'll see. Okay, so what it does is it reduces the amount of repetitive code that you need to write, making your code base much more cleaner and maintainable. Okay. So when you work with Java, there is a lot of boilerplate code that we have written, and what happens is this code we have to write always. For example, if you take a look at our class, okay, like the Pojo class that we have marked as entities, we have written getters and setter methods along with the constructors. You will have to write 2 string methods, equals, hash code, and so on, right? So all these methods can be generated automatically during compilation if you are making use of Lombok. Okay, so you have to just configure Lombok into your project, and what will happen is if you compile the project, you have to just mention over there with the help of annotations that what code you want to generate. For example, if you want to generate getter setter methods, you have to make use of the appropriate annotations. And what Lombok will do is it will generate that code on the fly. Okay, so that is what Lombok is. And if you see over here in stable, okay, these are all the features over here. You can see some annotations over here like not null, non-null, cleanup, getter and setter. So you can see never write getter and setter again. You can see this. Okay, toString is also automatically generated. Okay, you can see equals and hash code, no argument constructor. So it also generates constructors on the fly. Okay, you have to just make use of these annotations. Okay, you just write these annotations, and what it will do is it will generate no args constructor, all args constructor, and all of that. Okay, so data is a shortcut for toString, equals, hash code, getters, setters, all of this. So if you just make use of data over here, all these annotations are taken into consideration. Okay, value is also one annotation that can be used. Okay, So this is what Lombok is. It's a very simple dependency that we will be adding. Okay. And like I said, remember, it reduces the boilerplate code. It improves your productivity as a developer. Okay. You don't need to generate getters and setters. Of course, if you're making use of tools like IntelliJ, it's easy to generate getters and setters. But I'll tell you that Lombok is better because you have to just make use of some annotations, and it also improves readability. Okay. So if someone is reading your code, he has to scroll down to see what all you have generated, like getters, setters, toString is there. Okay. Your class might look a bit lengthier. But if someone is reading your code and if Lombok is being configured and used, then he does not have to scroll. Like there is very less code that you have written. And with the help of annotations, the developer knows, or the person who is reading your code knows that, hey, these all things have been generated. Okay. So this is what Lombok is. Okay. And yeah, it is going to reduce a lot of boilerplate codes. So we are going to use it in our project. And in our project, if you see, this is what our project will look like, I should say. Okay. So you're going to have so many entities, right? You're going to have entities for address, authentication. So authentication might have users and all, cart, category, order, product. And imagine the amount of boilerplate code it is going to reduce. Okay. So there will be so many getters and setters that you are going to need, constructors, and that's a lot of stuff. Okay. And as your project grows, like imagine any production grade application, as your project grows, it's going to be like a lot of stuff that you're going to write. Okay. And that is what, yes, Lombok can assist you with. So yeah, let's jump right in with Lombok. So it's time that we take a look at some of the important Lombok annotations that you should know as a developer. And these are the annotations that are used a lot, very frequently. These are most common. So what I've done is some of the common annotations, I've clicked on them over here. So if you see over here, this is a link. And if you click, it opens into a detail page, something like this. Okay. So I've opened a few annotations and we'll go through a few in this particular video. So here you can see the first one that I want to talk about is getter and setter. So getters and setters are really common. Okay. You have a entity class and you would want to have getters and setters generated for your fields over there. Okay. So at times you will only have getters generated. Even at times you would only have setters generated. Okay. Or you would have both. So you can even use both of them. Okay. And you can see over here, you can annotate with getter and or setter. So you can use both or any one of them to generate the default getter and setter automatically. Okay. And if you scroll down over here, we have an example. Okay. You can read a lot about this. Okay. This is the entire description of how it works. You can even specify the access level. So the default access level of the getters and setters that are generated is public. Okay. But you can specify the access level as well. Okay. And let me show you an example here. They have an official example on their website. So getter and setter example. So this is the age of the person. Okay. And you can see here private integer age 10. So here we are simply saying getter and setter. Okay. And here we have name of the person. Okay. We only have a setter requested, but we have the access level that we need, that we have specified over here. And the access level we have specified is of protected. Okay. So here you can see with this particular thing, you can specify the access level. Okay. And that is what we have done here. Okay. And after the compilation, you'll see this is how the code looks like. So this is what is generated. So you have integer age 10 and there is name of the person. So you can see here getter. This is the setter. Then you have the protected setter over here. Okay. And this is because we have specified this in the annotation over here. Something like this. Okay. So this is about getters and setters. Okay. You have more configuration keys that you can read about over here, but normally those are not used. Okay. Also, I have not seen this being used a lot. Okay. The access level. Okay. Normally you just use getter and setter. These are very common. Okay. But access level is good to know for you because there will be scenarios wherein you might want to have a certain access level for the getters and setters that you are generating. So this is good to know. Okay. So this is about getters and setters. Okay. So this is one. You have constructor annotations. Okay. Now, whenever you are creating entities, you will also have constructors that you will have to write in. Okay. And not only for entities, for any of the classes, right? So you can have no argument constructor, required args constructor, all args constructor, and so on. Okay. And here is the order actually. So the order is, first it generates the constructor that takes no argument, one argument per final or null field, or one argument for every field. Okay. This is the order. So here, no args constructor will generate a constructor with no parameters. Okay. Required args constructor will generate a constructor with one parameter for each field that might require any kind of special handling. All args constructor will generate a constructor with one parameter for each field in your class. Okay. And yeah, these are the three ones. Okay. And you can see over here, required args constructor, static name, off. So this is what you have specified. And you have all args constructor over here. And you have specified the access level as well over here. Okay. And here you can see like another class you have, which is for no args constructor. So these three annotations are being used. And if you scroll down, you can see all the corresponding constructors being generated over here. Okay, so this is the static one you can see here. Okay, this is the one with the parameter. Okay, one with the argument. So this is how the constructor annotations help you. Okay, then you have the data annotation. Okay, and this is the annotation that will combine the getter, setter, toString, equals hash code, required args constructor, and so on. Okay, so if you want to combine, if you want to have annotations for all of those, you can just make use of data annotation. And if you make use, you will see like everything being generated over here. Okay, you can see like equals, toString, all of this hash code is also being generated. Okay, which is useful, I would say, right? So this is what data is. Okay, value annotation is a immutable version of data. Okay, the data annotation that we just spoke about. So what it means is, if you have a class that you wish to make immutable, okay, so you can make use of value over there. Now, what do I mean by making immutable? Means the values for the class members cannot be changed. Okay, so what it will do is it will make all the class members as private and final. Okay, and this means that the value will be assigned to the class members on the construction. Okay, on the constructor itself. Okay, because they are final. Okay, and private as well. You have a all args constructor that will be generated, and this constructor will take all the class fields as parameter, and this constructor is necessary for setting all the final fields when creating a new instance. Okay, then you will have the getters, no setters over there. Okay, so you will just have the getters. You will have toString method that will generate the implementation of toString. Then you have equals and hash code methods. Okay, so this is what value is going to do. So here you can see value, and here if you go down, you will see this is the constructor. Okay, then you have like getters, equals. Here you have hash code, toString. There is no setter over here, so this is an immutable variant. Like you cannot change the values or change the class members after the object has been constructed. That's value. Okay, then you have not null. So it's not null, it's non-null actually. So you can use this on a field and this will generate a null check for you. Okay, so if you don't want a field to be null, then you can make use of this. Okay, so here if you see, okay, here you have non-null person. Okay, and here you'll see like it generates a null check, null pointer exception. Okay, so this is automatically taken care of. If you wish to have a field always a value, so if you wish a field should have always a value, then you can make use of this. Okay, this is non-null. Then you have builder. Okay, what is builder? So this generates a builder pattern for your class. Okay, and you can like this is, so you can make use of this. And if you are working with builder patterns, then only this particular thing is useful. Okay, then you have cleanup. So this is an automatic resource management annotation. Okay, and it will automatically call close methods to close all the open if you have opened any sort of resources like streams. So it will free you from manually trying to close them. Okay, so normally people use try catch finally blocks to clean up, right? So if you make use of this annotation, it will automatically be cleaned up. So here you can see input stream and output stream. They have been made use of cleanup annotation. And here, this is how the boilerplate code will look like the vanilla Java or the compiled version will look like. Okay. So these are some of the annotations. And as you can imagine, a lot of things are taken care of, right? So I hope this was useful. So this course is going to be a bit long, and many of the students requested me that I should make use of dark mode so that it's easier on eyes. Okay. If you're normally coding for long hours, okay, I normally use white theme, but I just thought I'll switch over to a dark theme that you're seeing over here. Okay. And if you wish to switch over, you can just head over to settings, and in settings here, you'll see this theme option, which you can select light, dark. So earlier I had light one. You can switch over to dark if you wish to use dark theme. And if you're making use of Mac, you will see this option under preferences. Okay. So here you will have an option to check out the preferences, and within preference, you should be able to change the theme. Okay. So going forward, all the lectures would be in the dark mode. So nothing changes except the color of the IDE. Okay. You can follow along in the light mode as well. But yeah, this is just an information lecture where I just share this information with you. So now it's time that we get our project configured to work with Lombok. And for that, we will have to add a dependency into pom.xml. Okay. And for adding the dependency, we are going to head over to our favorite website, which is start.spring.io. Okay, this is our favorite website whenever we do Spring Boot development, right? So we select Maven, you go to Add Dependencies tab, and here you see Lombok here in the suggestion itself. Okay, and you can see over here Java annotation library, which helps to reduce boilerplate code. So just select over here Explore, and you can get the dependency from here, like so. Okay, just make sure you just copy one tag. Okay. And you come back to the project and you add it over here like so. Okay. The moment you make any changes to pom.xml, what happens? You are needed, you are given an option normally to refresh the project source or the project structure. Okay. So I'll just reload Maven over here. Okay. Because we need to refresh. I didn't see that refresh option over here that normally appears, but I'll click over here. Also, you have an option to add Lombok plugin. You can add it if you wish to. Okay. Also, there is a possibility that you might see an error that Lombok requires enabled annotation processing, like over here. Okay. And you'll have a button like enable annotation processing. If you see that option, then what you need to do is you need to head over to settings over here. And if you're making use of Mac, you need to head over to preferences. Okay. And here you need to search for annotation. Okay. And it's called annotation processing. Okay. So you can see over here, it's under compiler. So it's under build execution deployment. So this is the root. Then under compiler, you have annotation processing or annotation processor. This is called. Okay. And under annotation processor, you have enable annotation processing. Okay. So you can check this option over here. Okay. And you can apply the changes. Okay. Like so. Okay. I did not get the error, but still I have enabled this. But normally people do get and they face issues. So I thought that I'll highlight this particular step. Now we'll go to our category model over here. Okay. This is the entity that we have defined. And what we are going to do is we are going to add a few annotations over here. Okay. So what we need to do is here we'll say data. Okay. Data is 1. We'll also say no args constructor. And we'll also say all args constructor. Okay. Something like this. Okay. So this is done. And I don't think we need any further changes. Okay. So we are getting this error. Okay. So earlier, I guess we did not have this is anyways we are getting. Okay, so I'll just do Control Z. I'll have this annotation over here. And then what we can do is we can get rid of these constructors and getters and setters over here. Okay, so what I can do is I can just get rid of them. Okay, we are done. And you can simply run your application and test it whether it's working absolutely fine or not. Okay, so I'll run this. And you see the application is up and running. Here in Postman, we try to get the categories. You don't get anything. We'll try to create a category and we try to get the category. You see it's working absolutely fine. And just take a look at the class that we have now. Okay, it's just, we don't even need a scroll. Okay, like my font size is big because like I'm teaching over here. Okay, so I normally want my student to clearly see everything on the screen. So I have increased my font size. But normally if you have a little bit smaller font size, okay, you don't even need to scroll. There's literally nothing. There are like 4 annotations and then you have this class definition with 2 members and 2 annotations again. Okay, nothing much. So yeah, we have configured our project to work with Lombok and I hope this was useful.